hate this hard drive. Well, I don't hate. Hate's a strong word for this hard drive. It does a lot for me, but, oh, I hate how it's energy efficient and always spins down on me. Okay, so, first thing we're gonna do is, I'm gonna go, message my stepmom and, tell her that I'm on the stream thing, so, she wants to tune in, she can. So, hold on. I'm gonna send out a message, and then we're gonna start this, for real. But, hold on here. Let's see, to Patty. Okay. Uh-huh. Uh-huh. Okay, so, now that I got that done, let's figure out what we're doing. Let's look at the agenda screen. So unit toast code number 18 taudirt.f, that's what we're doing. Let's forget about all the other stuff because it's the only thing we want to focus on is just wrapping up this bullshit that's been taking too long. So, taudirt.f, and when we open up the data, what do we have in the taudirt.data? I know that Tau Depot has our diagrams, but we've been using those diagrams quite a lot, and I think that when we open up the data file here, and we just don't have any nice little diagrams, I think we should probably have some nice little diagrams. I'm thinking that we need to take the Tau Depot diagrams, and we need to duplicate them into Taudirt, right? Because I think that this is kind of like necessary. What we can do though is we have a lot of like a lot of excess stuff here, so maybe we want to draw the diagram slightly differently. You know, I mean, since if we're gonna actually put the stuff in here, you know, maybe we want to first Taudirt attempt was wrong. Do I really care that the first attempt was wrong here? Like, I get that. I get what that's about, because I remember that originally I didn't do everything in a properly nested structure. But is this necessary? Is this history of our blunders necessary here? Hold on, let's go into the documentation. So in our documentation, we got this little hashtag file. Let's go look that up for a second. And we can see, you know, this attempt was wrong, blah, blah, blah. And I know why this attempt was wrong. It's because it didn't account for the nested structure of everything, right? So all these rectangles we're going through, there was only one level of rectangles for everything. So, you know, originally for this, for looping through here, we actually need, you know, if we're gonna loop through cells here and cells here and cells here, we don't just need 16 of these cells, we actually need 16 times 16 of these sized cells, right? And then of these kind of cells here, these smaller cells that are nested even deeper, we need 16 times 16 times 256, yeah? Because it's 16 by 16 cells here. So, so we made a blunder there. So, you know what, I don't care about this here. We can make a note, like if we really want to make a note of this. Let's just do vid IID since we want to get in the good habit of doing this. So the video integer ID of where we are, like right now. And why is my timer not correct here? Why is my timer not spinning up here? Let's take a look at... Okay, well, it says we're streaming, it says we're recording. Hold on, so we're gonna... Oh, there we go, now it's working. So I have a little timer up here on my stream that tells me how long it's been going. I don't know, it glitched out for a second. I don't know what that was about, but now that it's running, let's take the current video integer ID. So on the bottom right hand of the screen in blue, we see IID right beneath Mon for Monday. And it tells me that this is the 53rd video that we've done. And let's take the time of the stream. So 0 hours, 4 minutes, and 58 seconds. So if I want to remember, you know, when I got rid of this, got rid of the comment, right? And I can take this, put it here like, oops, like this. And we can just say, you know, we got rid of this comment. today because it was clutter, right? So it's still in the history of like everything we've been working on, right? This is a documentation file where we put all of the newest stuff at the top. So if the comments ever go out of date, right, if these hashtag comments ever go out of date, that's fine, because whatever is closest to the top is what we take as the authority. So let's just get rid of this for a second, and let's take some time to redo some of these diagrams here, right? Let's try to maybe make some of them a little bit smaller, and just take some time to enjoy ourselves here, and just redo some things, right? So let's yeah, so we have like extra slots in here. We could actually, now, okay, so I kind of see why I did that, right? Because if we take out this, it's not exactly square anymore now, is it? But let's not worry about that it's not proportional. It may or may not be proportional depending on what kind of font you have, so just because it doesn't look like a square for me doesn't mean it looks like it might look like a square for somebody else depending on how their fonts are proportioned. So we shouldn't really be too picky about that. This is a schematic diagram. We don't really care about exact proportions here. But yeah, let's take this guy, and then we'll take a similar diagram here, and we could actually just cut-paste this, right? Because it's the exact same proportions, it's just that all the sizes have changed, correct? So, what we can also do is we don't need to say, we don't need specifically, oh wait, actually that could work, though. That could work out. So, if we want this diagram to kind of like flow nicely, we might want to say like draw like a arrow. Actually, let's just do, since we're keeping everything shorthand, we could call these we could call this T, and then this is S. So this is S because it's the subcell. And we could draw like little arrows here from one to the other. So this is 512. This is the 512 by 512 texture memory. Each cell is 128 by 128. And when you get in the next subdivision, right, these are 128. This is a 128 by 128 cell, right? It's the next subdivision down. So this 128 gets actually carried over here. So what we could do to make this a little bit better is maybe we could say like 128 here. Ooh, so now we're kind of like out of room. That kind of sucks. We could make the diagram slightly asymmetrical here and just like give this cell like a little bit more room, just so that we have like room to work with it, maybe. You know, it's kind of hacky, but I think maybe that is the proper solution right here. Okay, so, right, so this is 512 and this is 128, so we can get rid of that 128 there. And the idea is just to make a more dense version of this, right? So, so here's T, here's S, and also, if we want to know what what T actually is, T is one of the values in here, right? So it's one of these 16 cells. So this is a cell 512 value. So we might want to make a note that T equal cell 512 T, right, leads to once you use cell 512 T, we could actually do the proper syntax here. So cell 512 T, and then cell 128 here. So it's really just like this. It's cell 512 like that, and then S for the subcell. And then for the root here, the root is an instance of this thing, which is really, really a very convoluted name. So I like to use this guy right here, right? Now any is a kind of a long name here, so what we like to do is just say that, you know, any, you know, is equal to this thing, and then we can do like any dot cell 512 T, right, and then S here. And then if we want to make a note here, we can point to this here. We can say, you know, cell 512 right here. That is this guy right here. I don't really like that kind of arrow, so we'll just do like little line here, and then do you want to space it out? What do we want to do here? It would be kind of nicer if we could kind of space it out like this. Space that out. We're gonna have to get rid of that one, but let's give this a little bit more. Let's make this a little bit bigger, right? So we're just gonna make it kind of lopsided, the diagram, but the idea is that it's a schematic diagram. We're not gonna worry too much about the fact that it's not completely proportional. So this is cell 512 denoted by the T. That's a cell 128 denoted by the S, right? So there's more than one cell 128, right? Because it's an array. These are arrays. So these are a specific instance. But yeah, with this diagram, I kind of like it like that. We could, maybe do that. I don't like the fact that we got this big gap here, though, because we're trying to condense the diagram, but, I do like how that lines up. But let's keep on going with this and just see where we get here. So, the next thing is this, but, these cells, there's like 16 by 16 of these cells. Can we kind of write that in a shorthanded way, right? Can we, so we could do, since it's 16 by 16, it might make sense to do kind of like a, let's get rid of that. Let's get rid of these indices, because these indices aren't going to be valid once we do what we're going to do to this. And what we could do is we could just kind of like do some type of shorthand notation to let us know that this region is not really exactly this size, right? Like, you know, in a graph, where when you write a graph, you kind of draw it with a broken line. We could do something similar like that. So we could do this, and then we could do like a ... right? And then in the middle, we could also try to do the same thing. So we could take this down here like that. Or actually, let's go up, right? And let's go up like this and paste it up here. Ooh, that looks ugly. Hold on. We'll get this. So maybe like that. Yeah. And then we could also do you know, ... and ... right? And then what we can say is we can say that this is, this right here is a, in terms of memory, it's 32 pixels. And how we're going to keep track of cells, like, we don't want to mix up the fact that, you know, some things are cells and some things are cells here, but then other things are in terms of pixels. So we might want to have some way to be kind of consistent with that. And I don't know how we're going to do that. I'd say let's just, let's see, this is our 128. Okay, so now we kind of labeled everything twice, but, you know, we could say that, these right here are sizes in pixels, right? So we have sizes in pixels over here. And, so all these things are sizes in pixels, right? And we can put this diagram we could shoot this plumb line down here like that. And, we can put it down here like this. And so we're kind of just recreating the diagram here. Now, you could say, well, that's a waste of time. We already have the diagram here, but we could just copy it over here. But then I'm honestly just going to get confused about what file I'm in if we have the exact same diagram in one file or the other. So it'd be nice just to reimagine this diagram in a different way, right? So that no matter what file we have open, we have a diagram ready to go to explain what the hell is going on, right? So the diagram in TauDirt and the diagram in TauDepot are pretty much the same data structures. Um, but but Tau Dirt is the actual cell overlay on Tau Depot. Tau Depot doesn't actually have these cells. Tau Depot does have these cells, but it only uses this. Well, okay, Tau Depot doesn't have these cells, in terms of like having an actual data structure overlay. It just has a conceptual cells that divide the memory into certain areas for different purposes, but it doesn't actually have a data structure that has this type of partitioning, right? We just take a 512 by 512 bitmap and we informally kind of parse it into these kind of subsections here, so that we can allocate different chunks of pixels for different types of memory, right? For different types of variables. But then where we actually formalize it, this file, Tau Dirt, actually creates a grid overlay over those pixels. So this is our grid overlay. So this thing right here, like these structs here, and this is the actual instance, no, right here, this is the actual instance, LA, right? LA is this struct right here. But these structs create this data structure over here, where we're taking the 512 by 512, overlaying a grid over it, and then for each 128 by 128, overlaying a grid over that, and then for each cell in here, overlaying a grid over that, right? So this is where that kind of magic actually happens. So let's actually cell 128, and then we have cell 032. So you can see why I named the cells like that. So cell 032, because these cell sizes are in pixels, and I thought that was the best way to help me locate, kind of remember what's what. But now that we have this, this doesn't really line up anymore. We could do like this, right? We could do this, and then make a little, we could go like this, right? Like, there we go, right? Have a little curved line that goes in there like that. That's kind of ugly, but, you know, actually what we could do is, right, we have this right here, and we're already taking up a whole bunch of extra space here where we're not really using it for anything valuable. So what we might want to do is condense this, right, so we got an equal amount of space here and here, and then for this cell here, we could just we could just, there's a lot of ways we could do this. We could do something like this, where we kind of put this here, and we could cut through the diagram if we wanted to, right? We could just, I don't know if that's the best way, but we could go like this. And actually, that's not too bad. That's not too bad, right? And then if we keep more arrows like this, right? So the arrows are kind of going through the diagram and saying that the S value is, you know, right here, right? And then we could also still give that extra space. Like maybe that extra space is kind of valuable in terms of kind of like understanding or like highlighting that cell, you know. So maybe we want to do that like that, and then obviously that's not a 110, right? So like that. Oh wait, and now that's kind of off. Well, we could give that a little bit more space, because the more space we give it, the more, what do you call it? The more, what do you call it? Right, visual spaces in your code kind of serve as highlighting, right? Like if you're not looking at any syntax highlighting, the more space around something kind of like brings kind of attention to it. And so if we're going to do that, we got to be consistent and do this. And then what we could do is this cell is kind of like in the middle here, so that kind of sucks. But we could keep the same pattern here and say like we could point to here, and then we could also give this more space again, right? So we could do this and do that, right? Okay, so that looks pretty good. And then so T, S, and this is V over here. Let's actually move this over one. Or actually, let's move it over two, right? Because then we have everything nice and lined up here. Okay, and then we'll draw our like little V's here to point from, right? So it's going to be different because we're not going to see this 15 here. We just kind of have to, we just kind of know that we're scan line ordering these. So this diagram is kind of, we can't say everything, right? To be concise, we have to, oh, this is a very informational stream. Oh, hey, thank you. Yeah, if there's anything you want to know, here, let me, over here, let me put my little chat thingy on. I got a little chat thingy. Oh god, wait, hold on. It, I kind of hacked this, so I gotta be like, testing, 1, 2, 3. Okay, yeah, so sometimes the chat thing, the way I did like a little screen capture, so I have to say a few things before, whatever the last person said will show up in this little box here. But, so what I'm going over, is, the memory layouts for, okay, so in OpenGL you have these things called uniforms, and they are basically variables within your shader that you can control from CPU side code, right? So your C code can talk to these variables and, you know, say what they want to be. Now the problem with uniforms in a shader is that you only get so many of them. You can hit a limit like 256 sometimes, depending on your version of OpenGL. 1024, I think, might be the current limit for OpenGL 4. I'm not sure. But the thing is that there is a very hard limit. So, what we're doing here is we're taking a 512 by 512 texture block, and we're using that texture block on the GPU as a chunk of uniforms. So every single pixel is kind of going to be used to encode a 32-bit uniform value. Not quite like that. We're actually using a cluster of 4 pixels per uniform value, which means technically we could store 128-bit unsigned integers. But that's just an abstraction on top of an abstraction, right? The basic idea is we can use the pixels as data. We use the pixels inside of the texture to store variables. In order to do that, well, there's a problem here, is that if we have this 512, if we have a 512 by 512 block of pixels, and we're trying to like push those up to the GPU like every single frame, that's going to lag out our rendering. Our rendering is going to lag, right? Because we're trying to like push like a whole bunch of data across the pipeline. I think it's the, I don't know too much about the hardware, but I think it's the bus. It's the PCI Express port that the data needs to travel across. And it has like high latency. So to try to do that every single frame with a 512 by 512 bitmap is going to be like horrible performance-wise. So in order to fix that, we need a quad tree-like structure to overlay over the 512 by 512 bitmap, and we only want to push pixels that have actually changed each frame. Now we don't want to do that exactly though, because if we do like a GL subtext image 2D for a single pixel, that isn't very efficient either. So we're going to allocate certain 32 by 32 pixel blocks on the 512 by 512 bitmap for specific categories of variables. And so there will be a certain 32 by 32 pixel block that is just for a certain subsystem. And when you are, when that subsystem is active, all of the other subsystem variables are very unlikely to be used. And so that means we're going to concentrate all of the uploading every single frame to at most a 32 by 32 chunk of pixels rather than a 512 by 512. Then to further optimize that, we're not even going to push the whole 32 by 32 chunk of pixels because we have like a dirty rectangle that marks what pixels were set, right? So if we set a pixel here on this 32 by 32, then only this pixel gets pushed up. If we set this pixel and say a pixel over here, then the dirty rectangle covers all of this, and so we end up pushing up like all of these pixels. And so that does still mean that some pixels that were not dirty are still going to be pushed up to the GPU, but it is you know, much more efficient than a completely naive solution. And there isn't really a perfect way to do this. There's not like a there's no perfect way to do this. Well, you know, maybe there is a perfect way to do it if you were like going a little bit more low level than OpenGL, like maybe you were using like Vulkan or something, or you just knew your some low level GPU programming. Like maybe if you were a little bit more low level than I am, you could probably do this more efficiently. But this is a pretty damn efficient way to do it, and not only that, but it is going to translate hopefully pretty well to different architectures. Well, not architectures, but libraries. So if I want to eventually, if I get good enough and I can actually port this to not OpenCL, but if I can port this to Vulkan, since I'm keeping my code really simple and not using a whole bunch of uniforms, but rather using a texture to store uniform values, my code is a lot more portable, if that makes sense. I don't know how to describe it any more than that for now. But okay, so we've redrawn this diagram, and the next thing we might want to do is we might want to have an explicit example. So right now we see that this is cell 15, right? So we could put a 15 here, and then this cell right here, 11, 12, 13, 14, this is cell 14, right? So we could put a 14 here. And then this cell right here is, well, that's actually kind of hard to compute. Well, we know we know that it's the last row, and that these are 32s by 32s, right? So 32 times the last row is going to be 511. So this V is so this Vx is 1, right? Because over here is 0, and then this is 1, right? Because the first index, or the first xy, it always starts with a 0, right? And also our origin is at the top left. We're using a graphical origin for this, not a OpenGL normalized device coordinates origin. So the Vx and is 1, because it's just 1 over, but then the Vy is the maximum that y can be, and that's going to be 5, or not 511, sorry, it's going to be 31, right, because it's going to be 32 minus 1, 32 minus 1, and we could do a quick index to xy calculation here, so index to xy, or actually no, xy to index, xy to index, right? So our xy to index formula, we can actually fill this out. So the width of this memory region is 32, because it's a 32 by 32. So 32, the y, Vy is 31, right? So we could do the 32 minus 1, just so that we don't lose track here. So this is Vy. Or actually, let's not put that in there. So Vy right here, then we'll fill out the Vx here. So Vx is 1, and let's just figure out what that is. So let's pump that into a calculator, because I suck at math, and take a look at what that is. I don't know if you really want to see me pump this into So let's go to Google, because Google actually has a good calculator. Okay, so 993, is that correct? That doesn't feel correct. Well, what's 32 times 32? Hold on. So 32 times 32. What is 32 times 32? Well, 32 times 32 is 1024, right? So 32 times 32 equals 1024. We can also do this, right? 32 times 32 equals 1024. And if we want to get the origin here, we have to subtract the stride plus 1, right? Because if we subtract, let's say we're here, and we subtract the stride, we're going to end up here. We're going to end up one cell. So we don't want to... For over here, right, so for over here, at the last one, at the last pixel, and we subtract the stride, we're going to end up here, right? But we want to end up here, so we're going to subtract the stride and then add 1, and we're going to end up here. So 1024, 1024 minus the stride, which is 32, plus 1, and let's see what that is. So 1024 plus the stride plus 1. So 991. Right, so that's this guy right here. Bottom left corner. And this formula, did this get us 992? Because that's kind of what we're looking at. 993. So let's look at this. 993, is that correct? Or are we... which one of these formulas is wrong? Where did we go wrong here, right? Because we got 991 here, 992, but we have 993 here. So let's look at our math here again. So we're saying the Vx equals 1, and we're saying that Vy is 32 minus 1, because it's the max, right? And so we are taking the width times the y value, and then we are adding 1, because that's the x value, that's the leftover. So this formula is actually correct, and it looks like I've just screwed up on this math here. So this is not the bottom left corner. That is off by... the bottom left corner should be 992. So 1024... minus this here. Well, this 1024. 1024 is actually over here. 1024 is the first out of bounds, right? Because it needs to be 1023, because we have to include 0. So over here, this last cell here, this is out of bounds right here. This cell right here, when we're looking at 1024, what we're actually looking at is this cell over here. So 1024, if we want to look at 1024, 1024. I don't know how we want to do this, but we could kind of do this, right? So 1024 is this guy. Well, let's just do this, because, I mean, we already got, right? There we go, right? I mean, that's kind of ugly. It's kind of ugly, but right? 1024 is this guy right here. So we actually need to do 1024 minus 1, right? Minus 32, right? That's the stride. That's going to get us up 1, right? So if we're here and we minus the stride, we're going to end up here, but we want to add 1 so that we can get this bottom left corner. So if we take this, let's see what that calculates out to. Okay, 990, and now I still feel like I don't know what I'm doing, but okay, 990. Let's put 990 there. If this is 990, 991, man, I just suck at this today. 1024, this is absolutely 1024 here. But it looks like my logic is just off here. So, right, because if this is a 32 by 32 block of pixels, then the last index is 1023, right? Because it's 32 times 32 minus 1, because 0, comma 0 is the first, or just 0 is the first index, right? So 1024 is out of bounds, right? 32 times 32, 1024, that's out of bounds. So 1024 minus 1, and then we're going to minus the stride, and then we're going to add 1 to, and that would get us here, would it not? What am I doing wrong here? Is that maybe the math isn't? What is wrong with my math here? That looks like 990. So let's do the formula over again for the bottom left corner. So I think that's the correct math, but let's do another like index to xy. So index to, or xy to index, sorry, xy to index, right? And let's just do the formula over again. So the width is 32. The y value is going to be 31, right? Because we can't go up to 32, correct? And the x value is going to be, ooh, I said the x value is 1, right? But if we want that bottom left corner, the x value is 0, right? Because x is 0 for all of these cells, and then y is 0 for all of these cells. So that's where I got my off by 1 error. So let's take this, and this formula should get us the bottom left corner. So that should also be 990. So let me check that out. So 31 times 32 and 992. Okay, so now I am, I feel like an idiot. What the hell am I doing wrong here? So I usually don't write the formulas this way, so this is what I would think would be wrong. Because this is 992. Let's take, so this is bottom left corner. Okay, this is the bottom left corner index. Let's do an index to xy. Let's check our math and go the other direction, right? So if we have a 992 here, right, and the width is 32, and the width is 32 here, and then tx, right? So what is tx? So 992 modulus 32. What is that? So that is 0. Okay, so we're going to put a 0 in there, and that's what we expected for the x value, right? We expected x to be 0 right here. And 992 minus 0 divided by 32, what is that? Let's just put 0 here. And yeah, let's plug in this other formula, and we get 31. 0 and 31. So the math checks out for this right here. The math is checking out. We don't really need to label it like this, but I guess it's pseudocode, so why not? So bottom left corner, and there's x and y, right? So there's the index, which is one-dimensional, and there's the x and y. And so I'm absolutely sure that these are values for getting this corner right here. Now, I don't know why my math up here is wrong, but we double-checked this math here. So, well, hold on. Yeah, 992. So let's see. Let's say so let's just count. Let's pretend this is 4 cells for a second and say 0, 1, 2, 3. If we're at 3 and it's 4 wide, how much do we have to subtract to get to this 0? So if this is 3, minus, minus, minus. So 1, 2, 3. So we have to minus the width of this plus 1, right? So 1024 minus 1. The width is 32 minus 32 minus 1. That looks correct. That still looks correct. That's annoying. Oh, hold on. Minus 32. No, this should be 1024. Oh, got ya. I just don't know how to math. So, minus 32 plus 1 is not the same damn thing as... Right, that's not the same thing, right? I just don't know how to do math, obviously. Yeah, that is 992, right? So, so we take the last pixel, we minus the stride, right? So if we're at say we're at this last pixel and we minus the stride, we're going to end up here, and then if we add 1, we're going to end up here, right? So last pixel minus the stride to end up above, and then plus 1 to get the next cell, right? So here's a cell, the next cell after that is over here. So right, so the cells kind of do this like scan line ordering. So if we're here and we add 1, we're going to end up over here. So that's our add 1 to get from here to here. Okay, so now all our math checks out. We got that. So we're just doing a lot of math here. And if we're going to do all of this math for the first cell, we should probably just redo our diagram here and just put the V right here, just because that way when we're looking at the specific example, we're not like confused as hell as to why we have all this math for this cell, but we diagrammed out this cell. I think that would be very confusing. So let's not do that, right? And let's condense that down a little bit, and oh hey, look, we got a little extra room here. That's cool. And I don't know, do we want to just make like a little diagonal? Do you want to make a little kind of like try to like squeeze that in there like that? Not the best, right? But it's like, I think we get the idea that this is, or do we? I don't know. Well, I get the idea because I drew it, right? So we could put V over here like that. Maybe that'd be a little bit easier. Yeah, that's good. So then this is 992, right? So the idea is that we want some concrete values to grab onto, right? Like if our code is too abstract and we don't have an explicit example to grab onto, it can make it really hard to wrap our head around what the hell is going on. So with this little diagram of these values, it's going to be a little bit easier to conceptualize what's going on when we are writing the code. So we'll just put that little note down there, and boom, we got a nice little diagram kind of explaining what's going on. Maybe just align this a little bit better. We have size in pixels. We also need a size in sizes in cells. So we might want to do something like add a little bit extra space and do, you know, 4x4, 16 cells, 4x4 cell. I don't know what we want to do. At 4x4. I don't know. I'm going to do this. I'm going to do at 4x4C, and then ... This is also the same thing, so this is at 4x4. And notice that both of these are 4x4 cells. This is 4x4, and this is 4x4, and that's why this is called cell 512, and this is called cell 128, because I can't call this cell... Well, maybe I could, but then I'd just be really confused at what I was looking at, because the variables would have the same name, and it would be harder to write the code, because I wouldn't know where I was in the code. So, to differentiate between this 4x4 cells and this 4x4 cells, we're going to name them after the amount of pixels that are in them, right? So, it's a 4x4 overlay over 512 by 512 pixels. This is a 4x4 overlay over 128 pixels, right? So that's why I'm calling this cell 512 and cell 128, right? So let's call this one at, it's actually a 16 by 16 cell. And now that we have these little diagrams here, we can also kind of note that this is the size in cells, right? So sizes in cells, okay? And with these little annotations of at whatever, we're going to go into our little hashtag diagram, and we're going to just take each one of these things that we denoted, and we're going to make a little section to where we can find these annotations. Like, what do these annotations mean, right? So we're going to use the actual annotations to create like a little section divider. And the top of the section, we have the tokens on this side, and then for the other side of the section divider, we want to do the exact same thing, but we want to put these on the other side, right? So we want to take these and kind of put them on the other side like this. So we have this nice little section divider. There's no ambiguity where this section starts and where it ends, because all those were duplicates, so let's get rid of that. There's no ambiguity where this section begins and ends because of the habit of how I kind of label the start and end section. So now that we have this, what we're going to do is we're just going to say that, you know, at 4x4, 4x4 C is denotes 4x4 cells. Example, taudirt.d, right? And then at 16x16, same thing. And denotes 4x4 cells. Example. Right? And so now, it should be kind of obvious that 4x4C stands for cells. But the thing is we don't want to... We want to allow people to make assumptions where, like, yeah, 4x4 underscore C, yeah, that's probably cells, but a lot of people, especially me, do not like to make assumptions, right? Like, yeah, it is a valid assumption, but if you make the wrong assumption while you're reading the code, you could get royally fucked. So, you know, have this explicitly put somewhere, but we don't want it to clutter up our nice little diagram, so we'll kind of, like, put it off in this little hashtagged supplementary documentation kind of file. So now that we have this really nice diagram to look at, we can kind of finish up the tests we were writing that had to do with this code here. So let's put this all inside of a nice little multi-line comment so that we don't have to like comment out each single line, and that would also take up more column space as well. So now we got a nice little diagram. I'm feeling good about this little diagram here. That's 15, that's 14, this is 992. We did all the math down here to make sure that that was correct. And we kind of did a little refresher course on our understanding of how index to XY math works. We might want to make this like a little arrow like this. That way we can see the 1024 go like that. Maybe we're getting a little bit too fancy, right? But there we go, right? I just want to see that this is pointing from here to here, right? So I can see what's going on there. OOB, I think I've already made an annotation for OOB, but you never know, I might not have. It's just a thing I do a lot, so I do it a lot, so I'm going to remember. But if somebody else is looking at my code base, I want them to understand what at OOB means. So we'll make a little annotation for OOB as well. It's not something I need to remember, but it's something that if somebody is new to my code base, or they're not me, anybody but me is not going to know what the hell that means, I think. So OOB means out of bounds, typically an index value. So typically an index value within some type of tile map or pixel array structure, right? That's basically what I mean when I say out of bounds, right? Out of bounds index. Index or 1D index or 2D XY X or Y component or Right, okay, there we go. Out of bounds, 1D index or 2D XY coordinate, typically an index value within some type of tile map or pixel array structure that is either less than 0, neg OOB, or greater than or equal to the width or height of the tile map slash bitmap data, right? And then also we want to do like neg OOB is negative out of bounds index, and then at pos OOB is positive out of bounds index. Sometimes I might write at this backwards, so just C at neg OOB, and then at OOB pos. I may also write it, you know, there are chances that I will write things kind of backwards like this. So we're going to make sure that we can identify it no matter which way we write it. Now we could make a section divider for this, right? We could make this a little bit thicker. I don't think it really matters, right? If we search for this annotation, we're going to find it. Unless we're looking for neg OOB like this, and it has like the annotation mark on both sides, the ampersand, not ampersand, at sign. I don't know the formal name for this at sign. I'm sure it has a name. I don't think it's ampersand. I believe ampersand is the old school kind of like and symbol. So let's just make sure that, you know, if somebody is searching for it, they can find it. And yeah, this is kind of tedious to where it's like, man, we're doing more commenting than code, and that is going to be a theme of how I write code. There's going to be more comments than code. There's going to be more test code than production code, right? Because that's just the way it needs to be to have a sane grasp on this code base. Like, as this code base grows larger and larger, we want to make sure that we have steady progress. Slow and steady progress, right? If we're not meticulous about how we document things, we're going to make progress a hell of a lot faster, right? If we just want to be like, screw documentation and just blaze a trail of code, we could do that. And I guarantee, yes, we would make progress so much faster, like, you know, 10 times faster, you know, 10 times faster maybe, you know? But then eventually things would crawl to a halt. So sometimes, if you want to be cynical, when they talk about a 10x programmer, like programmers that are like a 10 times faster than other programmers, you know, one reason could be that they're a duct tape programmer and they just hack things together really quick. And then other people who aren't 10x programmers are the ones left cleaning up their fucking messes. So that's the cynical way to talk about a 10x programmer. But I do think that there are actually programmers that are orders of magnitude faster than other programmers, or orders of magnitude better, right? So, like, if you had two programmers and you're like, just sloppily prototype this and just get this thing done, like, here's this little code task, do it, and just get it done, and you gave them you told them, oh, don't worry about the quality of the code, then yeah, there could be one that's 10 times faster, right? But speed is not everything, right? So, alright, so keep that in mind, that we are going to go kind of slow, and I'm going to try to take the time to explain what we're doing and why we're doing it. So let's get into the actual test code. Now that we've kind of like made a nice little diagram to supplement what's going on, we want to actually look down at this test code. So let's take a look at where our test code is. So we put all the test code in the actual file that is being tested. The reason for that is we don't want to, there's two reasons. We don't want to be too granular with our project structure. I find that creates more problems than it solves. We don't want what I would call an administrative nightmare, where we have too many things to keep track of. if we're testing something, chances are, if the test breaks, the code we want to look at next is the code we're testing, right? So we'll keep the code that we're testing inside the same file as the test, right? Now, to avoid problems with like trying to look for things in the code, we will make sure that the test code, right, the unit test code, is at the bottom of the file, right? Because chances are, once this test code is done, we're never going to want to look at it ever again, right? So we don't want this test code in our way when we're opening up this file and trying to look at, well, what does this file do, right? The test code, we're probably not going to want to look at that. So we use a forward declaration to make sure the test code can be at the bottom of the file. And look, we're at 1264 right now. And if we go all the way to the bottom of our test code, we're at like 2005. So 2005, let's just take a quick look at how many lines of test code we currently have. So 2505, right? And at the top of our test code, if we go to the top, that's 1264. So 1264. So let's just punch that in. So 1,241 lines of test code, right? So we do not want that kind of clutter. We don't want that kind of clutter getting in the way of understanding what this does, right? So, unfortunately, we do have a little bit of clutter here where we have, like, these halting functions and these logging functions that are kind of like boilerplate that come with everything, right? This is also kind of boilerplate. These helper functions also boilerplate. And that is unfortunate that we have all this clutter, and that what we really want to know is this main logic, do one thing and do one well. We actually just want to know about this guy, this dirty sector update is what we really care about. But we want to also make it really easy to know where to find things, right? And so we've declared these functions here without forward declarations, right? So the reason that they are up here is because this function must be calling them, right? And if we're not using forward declarations, any function that calls another... If we have a function and it's calling another function, because we're not using forward declarations, the function that is being called always will have to be above the function we're inside of. So by avoiding forward declarations, we can have absolute certainty where certain functions are in the code, and it just makes it easier to navigate our way around this. Now, what we could do is, since we really have only one thing we care about, we could do one thing and do it well, and just say this. Helper, and we could also say, like, helper. Alright, the only things we really care about is this dirty sector update, and then another thing called AAC 2020 Tau Dirt dirty sector ask. So one of these things will ask what the dirty sector is, another one will set dirty sectors, right? And, you know, maybe that's not, maybe this comment is kind of dirty. Like, you might be like, well, why are you doing this? Why not just use a header file, right? And the reason why we're not just going to use a header file is the header file can act as forward declarations, right? Because they're basically just function prototypes. Or some people will call a function prototype a function signature, which I guess when we're getting really pedantic, a function signature is not a function prototype. I will usually use them interchangeably. But yeah, we don't want a header file, because then a header file with these, because then that header file could function as forward declarations and wreck the strict ordering constraints we're trying to do on this stuff here. So we could put the two things that we actually really care about. Like when we open up this file and we want to use the functions out of it, really we just care about these two functions, right? Because this is what we're actually testing and whatnot. So we'll keep these at the top, and it looks like I may have... Oh, it's not dirty sector underscore ask, it's just dirty sector ask. So let's make sure that that's correct. Yeah, okay, cool. So that's correct. Now that we have that, let's actually finish up our test code from yesterday. So yesterday I was being a complete idiot, which I do a little bit more than I wish, but that's just the case here. So let's actually give it a run, right? Because it's gonna crash where we left off, and that'll probably be the easiest way to figure out where we left off. So I'm gonna take AAC 2020 folder. So we gotta take here's our project folder, and we have a nice little build script right here. We're just gonna double click our build script, which is a bash script. And basically the bash script just runs a GCC on our main C11 file, and we're not doing anything fancy build-wise in terms of a build system. Our entire build system is just very meticulously organized C code source, right? So we're not using CMake, the bash script isn't that complicated. So we see this what the fuck message here. That is the error code, right? So the error code is just some type of unique string that I can grab onto and just control F for inside the whole code base. So this error message just needs to be unique amongst the whole code base. It doesn't really matter what the error message is here, because all the error message needs to be is something that a human being can look at and be like, oh, there's a problem, and then can go into the code, find exactly where the problem is, and then fix it, right? And so it doesn't need to be, like in Java and like C#, they get like all these fancy different error code categories. It doesn't fucking matter, okay? The only two error categories you actually need are, is this a fail fast error that needs to fail right away? Or is this a I need to fail gracefully error, like a IO exception, right? Where like it didn't fail because the program was wrong, it failed because the hard drive failed, or the user canceled some type of canceled something, right? So things that are outside of your control can be like an IO exception. And then anything that is the actual programmer's fault should be a fail fast error. So, because once you find an error in how the actual programming logic could be, if you don't crash right away, your program is now running in an undefined state, and so everything else. So now more errors could start piling up because the system's in an invalid state. So it's undefined behavior, right? It's like if we put maple syrup into your gas tank, right? If we wanted an example of a fail fast exception, that would be like there's some type of sensor in your gas tank that detects if there's not actually gas in the gas tank, right? Now, if you didn't do a fail fast exception and you're like, oh no, we should really try to handle this gracefully, right? Okay, try to handle it gracefully, and then just wait for the engine to also fail, because now your car is in an undefined state because there's maple syrup in the gas tank. Yeah, now your engine fails, and now you're trying to debug what's wrong with the engine, when the whole problem was that there were some previous bad inputs further up the chain, right? So you're just asking for more and more trouble to run in an undefined state like that. So let's look at what's wrong here, and I think, like I said, I was being a complete idiot that day. So if we look at, this is taudirt.f, we actually have like a notation, a notes file for taudirt. So taudirt.n for notes. What the hell was G? Jeez, I made way too many things here. So let's look at G. So, oh, it's a guard file. Okay. So usually I just want a .f and a .d file. A .d for data, .f for functions. Anything else besides that is kind of a non-standard thing. The reason I want to say it's non-standard is we don't want to start inventing more and more different file types, and we could endlessly categorize things until it gets out of control, right? Like, I just want somebody, when they're looking at this code base, they just need to remember two things: .d for data, .f for functions, right? We don't want to, like, as time goes on, we could invent more and more and more granular things, and those more and more granular things will be used less and less frequently, and then the amount of file types could proliferate out of control, So we do not want to expect the user to ever have to remember anything besides .d and .f. If we use something besides .d and .f, we just consider it a non-standard thing that nobody should have to actually remember. Okay? So we could say, n is a non-standard file extension. Okay, and then, right, so we could say, we could actually put that in our notes here. Right, so we could do a little hashtag, and so hashtags are for kind of like extracted commentary, and then ats are kind of like for assigning a certain property to a variable or something in a diagram. I kind of use them a little bit loosely, where the difference between one or the other isn't super strict, but in generally when I'm extracting a big block comment, I try to use this, but then you look at this and you're like, well, that's a pretty big block comment. But these are like attributes, usually, for attributes of something. Whereas when I do this is like a very specific case that I'm talking about, or some type of block comment, and it doesn't actually apply to a specific like variable or in a diagram. But like I said, it's kind of, I'm not very strict on how I'm doing that, but let's just write a little explanation of what I mean. So .n files are notes files. However, the only file types that are standard are .d, data, .f, functions. We can invent lots of other extension, but that will inevitably Alright, so basically, yeah, sure, if we want to add some supplementary information, but we do not want to force people to have to remember this. Right, it needs to be one of those little oddities in the code base where it's not something that actually is something that's always used, because it's not going to be very productive if we keep on fractionating things, because that can get out of hand. Like, over time, right? Over an infinite amount of time, we'll always kind of, like, come up with new things we can add, and so over a long enough course of time, if we keep on inventing these new extensions for new categories of things, inevitably, just a mathematical certainty is that will spiral, that'll just proliferate, right? Those new things that we create will never shrink, right? We're just going to make more and more categorization and more categorization, and that's how you get bureaucracy, right? Because a bureaucracy, it always grows, but it never shrinks. So once we've decided that there's a .n file for notes, that never goes away, right? So the way we want to avoid it from spiraling out of control is we're going to say, yeah, sure, there's a .n file, but it's not a formal thing. It's not like part of the canon of what the rules are, right? It's just we decided to do it in this one instance, but it's like a sticky note, right? It's not like a formal piece of documentation. It's just a thing we decided to do off the cuff, but we're not gonna say it's an official thing, right? Only .d and .f are official, because otherwise it's gonna proliferate out of control with all the different extensions and categories we could make, right? And same thing with here, with how we have these different folders. We got our library, and you'll notice that everything is pretty much not in separate folders. And the reason for that is there's different... The organization of how we could kind of put things in different folders to try to categorize it, all that's going to do is create a maze of things where we can't find anything anymore. And you could say, well, no, the maze of things helps you categorize because when you put things in subfolders, it's kind of like a binary search when you're trying to look for things. And I do understand that. But then you get these problems where, like, oh, does this thing belong in rendering.geom, or does this thing belong in rendering. Or does this thing belong in geom.rendering, or geom/rendering, or rendering/geom, right? You get this folder structure where inevitably, despite your best efforts of trying to go from a general to specific, you're going to end up with those things where a class or a file or something could exist in two folders at the same time, and now you have a fucking problem. So everything should be like this. Now, if you want a nested folder structure, we could do that, right? We could have some type of folder structure where we put like little where we just use the folder structure just for navigation, but it's not where everything actually exists, right? So we could keep everything in this level, and then if we want to actually find things, what we could do is we could do like in documentation, we could do something like we could do like we could do like FPT for fake project tree, and then we could do like new folder, and we could do like native, right? And then we could do like new, and then we could do folder, we could do window, right? Or actually, we could do this, new, so we already have a problem, right? So we could do native, and then we could do win32, and then window, we could do this, we could do new folder, we could say win32, right? Because when we're in native, do you want to categorize by which platform, or do you want to categorize by native window, right? So, and then in here, native, window, win32, win32, and then, so right here, we could do something like this, text document, and we could do, we could actually take the actual subsystem name that is actually our native window code. So over here, where we actually have a layout of where all of our different systems are, we can see that we have right here, graphics and window, right? So what we could do is right here, we could call this right here, we could do rename GinaWin. Right, I'll just call it GinaWin._. And this is just a stub C root of lib folder for source, right? We could say this is just a stub, right? And then over here, right, if we go this way to win32, we can go here, we can go new, we can say GinaWin._, and then we can also say, you know, this is just a stub C lib /GinaWin dot it's dot F or dot D ._, right? Okay, so the thing is that we don't want to compromise the simplicity of our project structure just because we think it's, oh, it would just be so good to organize our stuff in a fucking tree. No, it's not. Like, it's just a nightmare to organize things into a tree structure as far as I'm concerned, because I've done it so many times. It just creates a hassle, because if I want to find a certain system, right, I can just dump it all right here. And, well, how do I know what to look for? Because, oh my god, look at all these names. I can't remember what these names are for. Oh god, we should just use a folder structure so we can find stuff. Or we could look around. This is the first C file in the root of the fucking project, right? We look at the root of the project. The only C file is this. You open up that C file. You actually look at the fucking code, right? And we can see all the different systems right here, and we can see nice little summaries of what they are, right? We got this nice flat layout, right? If we have a branching folder structure, we cannot get a big overview of everything that's actually there, right? We just create this maze where we have absolutely no idea how big this code base is when we're looking at a folder structure, right? So then if you want to, like, get to something, right, you can be like, all right, we want to look at, you know, the OpenGL stuff. Oh, well, this is OpenGL easy bindings. This is OpenGL constants. We can just go to the root folder of the lib and just open up one of these, right? And I think this is a much simpler approach. I think that the folder structure thing is just stupid. Because I have been in the situation where, you know, it's like, oh, it doesn't really belong in this folder anymore, so now we gotta, like, refactor it and shuffle things into different folders, and it's like, fuck that. Like, why are we just rearranging things in different folders to organize it better? If we're constantly reshuffling things around into different folders, then we have gone too granular. That is what I think. We've gone too granular to reshuffle things into different folders. So if we want a folder structure, then sure, we'll do this like FTP thing for fake project tree, and then we can just use a folder structure. And now, because this is a fake tree of the project, we aren't limited to that problem of some things fit in more than one category, right? We can go native window, Win32, and we can find GenoWin, and then also we can go native, and we can go window, Win32, find it. Or we did native window and then native Win32, right? We can find GenoWin either way, right? And so the purpose of the whole tree, yes, the purpose of a tree-like structure is to serve as a way to binary search through the project to find what you're looking for by subdividing by different categories. And that is that utility of looking at things like that. That's great. Like, that's a good utility, but we can have that usage just by doing this, right? We don't need to actually tie that to the actual code, right? I think it's foolish to just be like, to tie that usage to the code. It's like the same reason where I don't like clean code, where let's put everything into smaller functions, right? To make the code easier to read. Okay, so what you're saying is change how the code literally executes because you want to make it easier to read. In general, I think that's a bad idea. I think it's a bad idea to change the code based on... we want the code to execute a certain way, and we want to write the correct comments in places if we need to understand it a little bit better. I don't think we should change the code. We shouldn't actually change what is actually executing just because we want it to be easier to read. Does that make sense? If this is the way it needs to execute, then keep that execution and write the comments for it. Not partition it into smaller functions because you think it would be easier to read, and then change how it executes. So, I mean, sometimes I do that, but when I do that, I note that I'm being hackish, and that, in general, this is a bad practice. Now, even though it's a bad practice, sometimes the performance hit doesn't really matter that much, but I still think it's a bad idea. So for this FTP, we should make a note of what that is. And so in here, we're just going to make a note of what FTP is. So FPT is fake project tree. And we'll just make a little note of what this is, right? So in here, we can do, you know, FPT fake project tree. Stub files for all of the subsystems of the project, organized in a tree structure to help people find what they are looking for. No executable code should exist in this folder. No source code should exist in this folder. Okay? Okay, and exist in... Right, so we also want to make that, same thing with the subfolders, right? Right, this is big thing here, right? This is just a documentation aid. Okay. Actual code is laid out in a very coarse and flat way. Okay. I'm not being lazy. The course okay, so make a note of this. There is a very specific reason why I'm doing what I'm doing, and we want to make sure that we kind of document that. So right now this kind of seemed like a little hackish, where it's like, oh, we're gonna name this really shorthand, and then we're just gonna throw in a text file to explain what this is. Well, why not just give this a longer name? And I'll tell you why we're not gonna give it a longer name, because I hate long file path names, right? It just makes longer file paths inevitably will lead to some type of problem. A lot of it is, you know, now we have longer strings, we have longer column lines in our source code, we have, when we're trying to copy things over to back them up, sometimes the file path is too long, and it doesn't let us copy all the files because of certain file system limitations. It just is it's a fucking problem. We don't care that much. If you use these folders a lot, you're going to know what they mean, right? And if you don't know what these abbreviations mean, then that means you're not familiar with the code base. That means you need to dig into these folders and figure out what they mean, right? So with that, we're not just going to leave somebody hanging just because we're kind of like, we have a very opinionated way of how we think things should be done. It doesn't mean we want to be mean about it, right? It's not that I want to, like, leave you hanging. Like, I want to give you the tools you need to find what you're looking for, but I'm just going to be really strict about how I think things should be done. So, folder name, and this is... I just forgot what it means. So, see, I don't even remember. It's, fake project tree, yeah. So, fake project, and then tree, right? Okay. And then we might want to try this again, where we do, like, fake, and then project, and then tree. And then also I'm going to do this, so, fake project tree, right? Just so I can find that in other places. Then also in my shortcut notes, where you don't really see these. These are kind of like my own personal notes. But for me, I can also do something like this. FTP, or fake project tree, means... so let's do fake project tree means and fake project tree means. And we'll do like this, so fake project tree, fake project tree. Oh god, I can't spell. For documentation help, right? No. Okay. Okay, then another thing we can do is we can do like fake project tree, fake project tree, and fake project tree. Anonymous account 15. Interesting account name. I don't know. I'm gonna assume that's just a interesting name. I'm just looking at the chat here. I'm gonna assume that's not an auto-generated account name because the number is 15. I assume it would be a bigger number if it was auto-generated. So then for here, we're just gonna see, we're just gonna do FPT like that. We'll just paste that. And then if we do FPT or FPT like that, we're gonna do FPT. And I should probably explain more of what I'm doing here, because if you're new to this, you probably have no clue what I'm doing. Okay, so these are my shortcuts. I can type this, or I can type this, and it will get me this. And this is my data, and what do I do with this data? Oh, I'm going to paste it to wherever I'm typing, right? So this is, these are the shortcut synonyms. This is the data, and this is what to do with the data. And it's always in clusters of 3, and the clusters have to have no spaces between them. And then to separate the data, we can have any number of spaces, or comment characters, right? So comment characters, so this line right here is going to be processed as a blank line because it's nothing but comment characters. Okay, so that's going to help me kind of remember what FPT means in the future, but we have it in the documentation as well for other people. Okay, so now that we have done that, let's just close this documentation file. And we were looking at this, and we're getting this to crash. And the reason for that is because we were being stupid earlier today. So, or not earlier today, but yesterday. So ask less than or equal to 0. So what does this mean right here? And if we think about what this means, well, less than or equal to 0 is going to be this one or this one, -1 or 0. And that means it's clean or outside the dirty rectangle, or clean or inside the dirty rectangle. So to fix this, what we're going to do is we're going to put a commentary. We're going to put clean data point, right? That's what this means. And we're going to put it inside here to note that what that means. And then we see we're doing a get here, and this is inside of a scope. And then somewhere we're doing puts as well. So let's highlight the puts and highlight the gets, and so we're clearing everything. So all we're making all the data points clean. So, you know, make all data points clean. And I described what this does many times before, but we can comment that one more time here. And if we're making all the data points clean, then if we're going to ask if a certain data point is clean or not by using this get function, right, dirty sector ask, which is going to ask if the data point is clean or not, then this ask should say that it is clean, right? And it looks like less than or equal to 0 is a clean data point, and then we're just going to error here, so that makes no sense. So we just got our logic kind of inverted here, right? So what we want to actually do is say, you know, reported clean data point as dirty. So this is the error. So the actual error here is this, but our error message can just be anything, right? It just has to be some type of unique string. But we can also make a notation of what actually went wrong in the code, right? Because we don't really care at this point. At this point, when somebody sees this message, we don't give a fuck. Okay. We give a fuck when somebody looks into the code base, finds where this was called from, and then sees this code here, and then we can actually give them some more commentary. But as far as the error message, it just needs to be something unique people can grab onto, so that's there. So now that we have this, now that we've structured it like this, we're going to say that, oh, good. Data point is clean as expected, right? So we've kind of restructured how we wrote this to make it a little bit more comprehensible, because we found that the way we previously wrote it, we just, for some reason, weren't wrapping our mind around it correctly. So we added a nice comment inlined to understand this. We cross-checked it with our little notes file here, and now this is going to work. And I know I did the same mistake later in the code as well, but we're going to give it a run, and we're going to see where the next problem kind of pops up on us, right? Okay, so the next problem we see expected clean 2020 12/19, right? So we put an exact date next to that error message. So we didn't have to think too much about how to make that error message unique. We just stuck a date on it. The reason I like to stick dates on things is that, you know, eventually when it's 2025, I can see these error messages and kind of be like nostalgic about, oh, hey, look how old that error message is. I wrote this 5 years ago. Wow, we've come such a long way, right? So this get right here, well, what does this less than or equal to 0 mean? Well, let's look at our table right here, and we see that both of these are clean, right? So clean data. Okay, and if it's a clean piece of data, the error here is saying that we expected the data to be clean, right? So yeah, because we're inside this loop and we're making sure the data is clean, then we're marking it as dirty, and then we're expecting it to be dirty, right? So we just messed up this logic. We literally inverted the logic the wrong way. So we just need to do good, data is clean as expected, right? Right, so this is actually our good case. And our bad case is actually this, right? Because we expected it to be clean, but it was not clean. And for some reason, we just wrote this horribly and didn't know what we were doing, right? And so we put all this debugging stuff here, but it probably doesn't matter anymore because we just didn't know what we were doing. But whatever, we'll keep it because we wrote it, and it could be helpful if this error ever does get triggered in our test. So then we're going to mark the data as dirty, and then we're going to expect that the data is dirty, so we have greater than or equal to 1, right? Because if it's 1 or greater, it is a dirty piece of data. And if it's greater than or equal to 1, that's actually the good case. So we're going to go good data is dirty as expected. Okay? And then we'll just put like a little else here, and then we'll have the error, right? So you see how we've the situations where it was an error were actually flipped, right? So we've flipped that logic by putting these errors into else's, right? So these errors are put into the else case, and we'll make a note of when we wrote this, right? So fixed on date, and the date is 2020 12/21, and we can see vid integer ID, and the video is, let me close this for a second to see. Okay, so the video we are on is, and also let me move this. I think I wanted to have this over here. Hold on, I'm just reorganizing some stuff on my monitors here to make this a little bit easier. Okay, so the video integer ID is 0053, 0053. And the time, the stamp time, is 1 hour, 32 minutes, and 37 seconds. So if we want to remember, like, when we wrote this code, we can see the commentary above this block, and we can know when that was written. And to make it kind of easy to see this section, we might want to kind of like take this and make like a line here or something. Or actually, you know what we could do is we could do like this. We could actually say like we could do like IID 0053 like this, right? Right, we could make a little section divider like this, and then we could put it above and below what we're working on here, like that. That's not too bad, right? So we can kind of see it there. And then we don't need this, right? So we can just say fixed on date, and that's good enough here, right? So this is the formal way we usually document this, where we do vid IID. And I think we usually use the @ symbol for that, so we can find it. So we can search for anywhere it says @vid IID and find that. But we'll also do this just to know exactly what this section of code is for, right? So I'm pretty sure that that's all we need, and our tests are going to work, and the code's going to run, and then we can go on to writing tests for other sections of code, right? So this these Tausync tests should be finished now. Yeah, so they're finished. We're done with that. So a little review of what is here in case you're new. The number keys on my home row correspond to the numbers 0, which is this little shader here, which is the is ready shader. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And so what we're going to do is, as we code this game, we're going to have different subsystems. Each subsystem is an editor. Even the actual game will be an editor. This is going to be an editor-centric game. It's part of, I have kind of explained why it's editor-centric. It's because we don't want to maintain both editor code and game rendering code, so we're going to make it all one thing. Also, to make the code less abstract, we want concrete implementations to kind of grab onto. So everything is just going to be an editor, right? So rather than calling this subsystem 1, subsystem 2, subsystem 3, subsystem 4, etc., it's actually going to be editor 1, editor 2, editor 3, editor 4. So every single subsystem itself is an editor. And to make things even simpler, editor 1 is tied to key number 1 on my keyboard, editor 2 is key 2, editor 3 is key 3, key 4, etc. And now we only have editor 1 that we're currently working on, developing, but we just want to keep everything dead simple. The last prototype I worked on, I made it a little bit too complicated. You had to press the tilde key and then one of the number keys to switch editors. And that extra step actually makes it really hard, because after 3 months of not working on the project, you come back to it and you have no fucking clue how to get back into the different editor modes, right? So we just want to keep it as simple as possible. Now, that does mean that if we're going to hard code these different keys here to switch editors, that means we can't use these number keys for editor-specific commands, right? So we've lost a whole bunch of our keys to this, right? And that's why in my other version it was, you know, press the tilde key first and then you press the number key. That way you could use the number keys for commands specific to different editors. But we're not going to do that here, because I think that's just too complicated. We're just going to use all of the letter keys for editor commands. We're not even going to use these special characters. And we're going to keep it like that for a very long time, right? We're going to keep it dead simple for a very long time. We might be tempted to be like, oh yeah, plus and minus, that could be like zoom in and zoom out, right? And the arrow keys, we could like totally use the arrow keys to like move around our tile map, right? Oh man, we should totally bind those arrow keys. We're not going to do that. And it might seem like you might think that's completely stupid to not do that, but you might be right, because the idea is we're keeping this stupidly simple, right? Because this is a large system, and any little thing in isolation, you can be like, oh yeah, that's really simple, right? But it's the whole system we have to think about. So we want to do things dead simple. And maybe, like, idiotically simple, like, where you're like, oh, man, like, why are you writing it that stupidly simple, like, you know? And so you might look at it and be like, wow, this code is written by an idiot. But it's written that way because we have to remember that it's not just that one piece of code in isolation, it's an entire massive system, okay? And, all these little complexities, they're going to compound on each other. So we need to make sure that everything is dead simple, because the whole is going to be much more complicated than the individual parts. So yeah, so there is a reason why when you might look at my code, you might be like, wow, why don't you use more loops for things? Why are you kind of like cutting and pasting things in making a lot more code? And the reason is I want to keep things dead simple. And to keep things dead simple, you may see just large blocks of code kind of like duplicated over and over. Like right here is a good example, right? We see this. It's like, if you're going to do this over and over again, why not, you know, make some type of helper function, right? Because you see these big blocks of duplicated code, that's a sign that you could use some type of helper function, right? But that's just going to add more mental indirection and essentially make things harder to follow when we're reading the code. So We want to keep things dead simple. Okay, so we're at the point where those unit tests are done. So what we're going to do is we're going to do a git bash here and just push up our stuff and just note that the tau-dirt unit tests are done. So git status, git add dot, git commit dash am. And yes, some of these things that we did don't apply to the tau-dirt unit tests being done, like the doc/fpt, right? Because we did a little bit of other stuff. I don't care. Or not, it just, yeah, I'm not going to try to be super detailed with my commit messages. I just want to know basically what I did. Some people will want to say, oh, don't say what you did, say why you did it, because people can just look at your commits history to see that. I disagree with you. I disagree. I think that that's a good strategy. You can write what you did, why you did it. What you did and why you did it are both valid things to do, or a to-do message of what to do next. I think those are all valid things, right? As long as it's not nonsensical, I think it's a good commit message. So we're just going to say that tau dirt unit testing is finished, right? So just a little note. I put it in square brackets so I can see it, and then git push GitHub master. And let's just take a quick look at our GitHub, right? Let's actually take a look at that so you can kind of see, well, what does my GitHub look like? So www.github.com. Okay, so if we look at GitHub here and we look at my code base that we're working on right now, we can see, so where were we? So in the lib right here, so tau-dirt unit testing is finished, and then we also touched the documentation stuff when we did this as well. So this message doesn't really apply to here, because, you know, it didn't really have anything to do with that, the unit testing. But the thing is that it's still informative to me, because I know that I made these changes over here at the same time that I made these changes, and that's good enough. That's good enough for me. So we don't need to worry about these being kind of exact. It's just a reminder of, oh, it's probably when I made these changes, you know, these are just little reminders. These are just like little mental hooks to remember when you want to find something. It's not, it doesn't need to be don't be super strict about this. Just keep them terse, keep them concise. You know, let's not be super militant about how we need to do these. So, which is weird coming from me, because I have this very stringent way of doing things, but then you'll see that here I'm kind of pretty loose on that, right? Like this to-do kind of piques my curiosity, so maybe I want to look at that, right? Let's not be too terse about that. Also, I'm going to check my email really quick while I'm here. Gmail.com, because I messaged my stepmom telling her I was starting the stream, so I wonder if she checked in. I wonder if that was her in the anonymous chat thing, or if that was somebody else. Maybe it was somebody else. I don't know, because they didn't reply to my Gmail. Okay, so let's just keep on going here. So where are we next? Let's take a look at our agenda screens. Agenda screen here. So number 18 is done. So let's go over here. We're going to edit this really quick. So 18, we're just going to kind of like underscore it like that, because that's checked off. And we see we need a dry run unit test for Tausync. So I believe Tausync is the next up for our unit tests. We kind of wrote that. Basically, this is 19 basically says to do. Like if we were to write it similarly to item number 18, it would say like tausync.f unit test code, but we kind of wrote it a little bit differently because we wanted to make a specific note of how we actually want to test that stuff. So let's look at our library chain to see how all these systems are related. These systems stack onto each other in a linear order. That means that keybind will never reference anything up here, right? And it also means that pixload never references something here, right? So as we stack on new systems, they never reference something behind them, right? And we do that so we can, when we amass a lot of systems, by knowing the exact dependency order of our systems, it's going to be easier to find our way around the code, right? like for the same reason that people organize their code in like a tree so they can do a binary search for things, this is also going to help us conceptualize how the project was built and what the different dependencies are, right? So GPU data, I know that GPU data does not backwards reference the pixel names or the fragment shader testbed, right? And that's all helpful. So we can look at this and go, oh yeah, we were just doing the test for Tausync, and and the Tausync is kind of related to Tau Depot, and oh, here's Tau type. What's that about? Why are we jumping directly to Tausync? And I know why we're jumping directly to Tausync. It's because Tau type, we don't want to allow Tau type to synchronize stuff with the GPU, because we don't want synchronization to happen on that granular of a level. We actually want to call Tausync once per frame of the game, and so we want to make it impossible to abuse that, so we don't want to have like syncing functions in all of our different data types that are hooked up to the GPU. So that's why Tau type is right here. So even though this is the order that we've ordered it, this is actually the next thing I want to test out, because I haven't actually written the code for this. So it's slightly out of order in the way we're coding it. And that's kind of weird, but there's different orders for different things, right? There's this strict ordering for how I want the dependencies, but then the ordering of how I am checking off the different tasks that need to be done as I'm building this system up, that order is slightly different, right? So it's kind of, hey, there you are. How's it going? El Papa Pig, how's it going? Oh, awesome. So how do you spell Hero Cell? Like, he's the guy who's working on the CUI for games, which, like I said, once I start working on UI code, like, I'm going to use his code base, because I suck at UI, and I've done UI before. Also, let's go back to my code screen here. I just remembered that I wasn't actually showing this. So, we just did the unit tests for this thing called Tausync. And Tausync, right here, we have a nice little diagram here. There is a thing called, oh, nice. So, Hero Cell will know what I'm talking about with uniforms. So, you're going to think I'm batshit crazy. So, I am batshit crazy, because that's why I'm coding in C, right? How would I be sane if I was coding in C, right? We're all crazy for coding in C. Anyways, so, uniforms, right? There's a limit to how many uniforms you can have, so I'm doing this really hackish thing where I use a 512 by 512 texture to store uniform values on the GPU, right? And so if we're trying to push a 512 by 512 texture, like every single frame of the game, that is going to be absolutely horrible performance-wise, right? We do not want to do that. So what we're going to do is we're going to like overlay a quad tree-like structure over the 512 by 512 bitmap, and we're only going to do a GL subtext push to the dirty regions of that bitmap that have changed, right? So we're going to designate, first we're going to take the 512 by 512, we're going to split it into 128 by 128 cells, and then we're going to take those 128 by 128 cells, and we're going to split those into 32 by 32 cells, okay? And this cell right here, cell number 1 in this subdivision here, it's, if we want to look at the actual tree structure here, it's this anyObject.cell512. This index here is one of these cell indices here on this 4x4 division. And then for one of the cells in here, it's this cell. These are the actual variable names here. And this is S. So, and then to get the final 32 by 32 block, we take this V variable to use the cell 032. To get like this block here. So they're named after the number of pixels in the memory block, right? So this is a 512 by 512 section of memory. This is a 128 by 128 section of memory, and this is a 32 by 32 section of memory. Let me read the comments here. Yeah, coding tends to do that, at least professionally. Oh, nice little Python icon. The white space thing with Python, like, drives me crazy. I do like that it's, like, really clean, so I get that, but I'm, like, a really paranoid person, so I'm always paranoid that I'm gonna, like, accidentally backspace somewhere and, like, destroy my code. If you've noticed with my code, you see how there's, like, 2 semicolons here? Anytime one of these scopes spans more than one line, I use 2 semicolons to denote that the scope spanned more than one line. And that's just a little thing I do because I'm really paranoid that while I'm editing the code, I'm going to accidentally do something like this. And so I have like little redundancies in my code just to make sure that visually I have this type of visual consistency where I can just glance at the code and know if it is correct or not without actually thinking about it. So like in psychology, there's a thing called fast and slow thinking, and I want to use as much of the fast thinking, or I guess the instinctual thinking part of my brain to parse the code, to kind of like reduce the cognitive load and also have another layer of kind of air checking on my code here. But yeah, so basically we're putting this quad tree structure on top of the program, on top of this 512 by 512 block of memory. Here, we'll run the game right now. There's, yeah, no problem. Yeah, I got ya. I got ya. Go eat. Go get that food. You're also doing alignment, I see. I like y'all. Yeah, exactly. Yeah, I mean, powers of 2 all the fucking way, man. So, let me talk about, like, okay, this is subsystem 1, which I'm working on, subsystem 2, subsystem 3, subsystem 4, subsystem 5, etc., all the way to 9, and then the 0 key is just this basic shader. So, you press the number keys on the top row to get to the different subsystems, and what we're going to do is we're going to have an editor-based game. So, rather than maintain editor code and maintain editor code and then game engine code, I found that is a problem because then you have 2 code bases to maintain, and sometimes, oh, it looks one way in the editor, but it looks like another way in the game. We're going to say, fuck that, it's all the same code base, right? So the game is basically going to be an editor where the only way you can edit the level is through using your player to move through the level and have, like, bombs explode to, like, destroy the tiles. Yeah, embedded game tools, exactly. So we just want to make one code base for both of those things, just because it's going to be easier to manage. The other thing is, I said it was editor-centric, so every single subsystem in the game that is tied to one of these number keys is going to be an editor. So none of these subsystems is going to be anything but an editor, and the reason for that is we want to keep the code as non-abstract as possible. So I'm not, I think I'm doing kind of like a data-oriented design thing, where it's kind of data-oriented design in the way I'm writing this, and also I'm trying to be as explicit as possible, because I found that when I abstract the code too much, it's hard to wrap my mind around it. So every single subsystem that is tied to one of these number keys will be an editor. Also, the top row of keys for the number keys will always be reserved for different editors. We're going to keep it dead simple, and that means that in the editors, we can't use the number keys, because the number keys are designated for switching editors. And that may be a problem in the future, but we're not going to address that until we're, like, really far ahead in the future. The reason for that is we want to keep things as dead simple as possible. So it may seem really stupid that it's like, oh, we're only going to use the number keys, and then we're also going to use the letter keys, but oh, we're not going to use the arrow keys, but wait, the arrow keys could be really good for, like, moving to different tiles. And what about, like, plus and minus? That would be really good for zooming in and out. We're not going to do it. I know it seems really simple to be like, oh, it wouldn't be that hard to bind to the arrow keys or bind to plus and minus, and you're totally right, it's totally simple, it's totally easy, but we gotta remember that this is a big system here, and we want to do everything dead simple, as stupid as possible, because in isolation, something might be really stupid, but we gotta think that we have this big system, right? And all the complexity is gonna compound on itself, right? So we want to keep things as dead simple as possible. What else? So I know, a Zarlock Twitch. I don't know if I'm pronouncing that right. Zarlock. It's the age-old technique of get it working, then add the extra shit. Yes, exactly. Exactly. Get that shit working. First priority is get it working. Exactly. First priority, get it working. Worry about all that other stuff later. Yeah.
Totally agree. One of the best things you ever taught me.
Yeah. All right. Can I hear you through the radio on the door shut? Would you talk softer? I don't know. I hear the radio right there, so I don't want the radio to drown me out.
No, not. Dad, can I?
Okay.
I don't mean this one. I mean one upstairs.
Oh. Okay.
Dad, can I move
So,
the radio near you?
All right. Sorry, I'm a little distracted. Because some things are going on in the background here. There isn't really a specific pronunciation. Okay, got ya. So let me try to get my bearings here, right? So we're doing memory alignment. Yes, we are. Oh, that's what I wanted to talk about. Leverage, data leverage. The way we're going to organize this game is, let's say you're using,
Jamie, it's
yeah,
off.
okay. Let's say you're using, 4-byte color or 32-bit color, R, G, B, and A. If you have a blue canvas, right, and let's say it's pure blue, it's RGB, so 0, 0, 255, and then 255 for alpha, right? And it's a pure blue canvas, and then one of those pixels, instead of being 255, it is 254. If you look at that canvas, you probably cannot pick out that one pixel that is different, right? Because it's just one, it's off by one, right? And you can't see the difference because there's a very fine gradation. Well, all of the memory in the system, for every single subsystem, it's only going to get a 512 by 512 block of memory. And we want to leverage that data as much as possible. So if we have just a one single bit that's different in our data, we want a lot of contrast. The way we're gonna, it's gonna be a while until we get there, but basically every single pixel is going to encode like different tile types for different materials and whatnot, and all the subtlety, all the gradation, all of that stuff will be done by the engine, but we don't want any of that subtlety to be packed into the data itself, because then we're just wasting bits, and we only got 512 by 512 pixels to work with. Now, you can be like, well, that's kind of weird, why are you doing that? But here's the thing, I'm an indie developer. We got to remember that, let's take Doom Eternal, because I love Doom, and it's the only game I play. The id Tech engine is absolutely nothing without the art, okay? Without the art to render, you just have a black screen, right? So even though their technology is really impressive, that technology needs to be backed by a lot of human hours, people hours. Actually, we'll call them brain hours, right? Organic brain hours, right? You need a lot of organic brain hours to make the art that goes into that game, right? If we're doing an indie thing, we need to structure our engine in a way where we're leveraging the data in such a way that we can use a small team of people to get a lot of quality assets into the game, right? And the more data we have, that's more data that the artist has to fill out, basically, right? So we're going to structure the game in a way where we have a way of creating graphics that leverages the data in a way where the artist can get a lot done very quickly. Also, when we're talking about the artists, id, and I'm going to read your comment right after I'm done with this rant. One thing id does is a lot of their tech is not just the engine. A lot of their tech is unseen. It's like the the iceberg where you see a little bit at the top, but there's a whole bunch beneath it. That hidden tech is the tool chains they create for their artists and their artists, right? Where they're trying to help their artists get assets in the game and develop levels. There's like a whole tool set for getting the data into the game. And as we're designing this, we're going to design with the artists in mind. We're going to try to make sure that the engine can help the artist get data into this game. Because if the artist can't easily get data into the game, then it doesn't matter how awesome our engine is. Anyways, I mean, it's fun/interesting, would be plenty of reason to me. See, now that I am not sure what that comment was for now, because it's because I ranted. So I'm not sure which part that was interesting, but I'm glad that you think that what I'm talking about is interesting. Let's look at our little task list. Well, not our task list. Let's just look at our library chain. So I don't know if I described this, but basically my build system is a whole bunch of macros that tell me what order that everything goes in. And you see how I have these numbers 1 to 24? Let's say I do something really fucking stupid, like I do a memory stomp, or I do a seg fault somewhere, or I have a threading issue, and there's like weird, strange behavior, right? Because we're doing C, and eventually we might like shoot ourselves in the fucking foot, and even though we write tests and whatnot, we could do something incredibly stupid that leads to just weird, undefined behavior that makes the system very unstable, and we might not be able to find where that's going on. So what we can do is, if we ever run into weird, undefined, unstable kind of behavior, and we're noticing that, we can take this libchan, so library chain current, we can take, instead of compiling up to 24, we compile up to 14, right? And then that means that only these systems are going to be compiled. And we've built up our project so that we can compile up to any one of these systems here, and we'll have a running executable, right? And so we're kind of layering everything on like this, and we're trying to do it in a very chronological order, but sometimes we do have to go back and insert things, hence why I have this like little free spot here, because I made some insertions and deletions, and this is just, I didn't want to shift everything over. But yeah, so let's say we have some type of weird behavior, we don't know where it's coming from, so we split here and we compile to here, and then we find that, oh, now it's working, right? It wasn't working here, but now it's working here. And we can keep on splitting and doing a binary search. So it's not working here, and then now it's working, so we know the problem's somewhere between here and here, so we split again, right? And once we split here, we say, is it working or is it not working, right? And then we keep on splitting between where it's working and where it's not working until we hone in on the one problematic system that is introducing some type of undefined behavior. And I know that's like hackish as hell, but the thing is my code base is kind of like a lowest common denominator thing. Like, look, I'm using Notepad++ for crying out loud. And no, I do know how to use an IDE, but so yeah, for release is just always the highest number. Release is always the highest number because the final project is every single system, right? But for release, we're just going to use this, and then we have some other things here. So sometimes you lose track of to-do messages. So right here we have crash on vital to-dos. These are to-dos that I absolutely need to do. Let's say unit tests that I have forgotten to write. And then on maybe to-dos are things that I think might be nice, right? And sometimes, like, I know you could just, like, make a convention of, like, searching for a certain string in your code to find where all the to-dos are, but I never actually do that in practice. So what I've been doing is just doing this. And so let's say I come back to this code in like 5 months and I have no fucking clue what I was doing, right? And it's like playing an RPG. Like, you play an RPG, you set it down for a few months, and then you have no clue what you were doing, and you can't finish the game because you don't know what you're doing, you don't remember what your quest was, right? And imagine if you can't complete an RPG that you put down 3 months ago, if you can't even complete that RPG game because you forgot what you were doing, well, code is a lot fucking harder, right? So basically picking this back up is kind of like picking up an RPG and being like, oh god, where did I leave off? So by setting this to 1 in running the program, you're going to get a crash somewhere, and you're going to know exactly where to start writing more code, right? So that's why I kind of do this. Right, so that's only for debugging, not release. Oh, that's better than my system. I should start using that. Oh, awesome. I'm glad that I have some type of tip trick kind of thing that you like. So let's see, one more thing about the project organization is, well, let's look at the root folder here. So I'm trying to think of myself as a steward of the code, and I want to try to organize the project in a way where someone new to the code can find their way around. And it's the hardest thing about coding on a new project, or when you join a company and you're going to work in a new code base, is just like wrapping your head around it, right? You have this big like cognitive payload, and you're like, oh shit, I don't know what any of this stuff does. So what I've kind of done here is, in the root of the project, the only actual C file is this. So my hopes is that when you look into this project, you have only one thing to grab onto right now, because everything else is this weird shit, and you see, oh, this is the C11 file, let's open it up, right? And immediately when you open up, one of the first things you see is this library chain, this high-level overview of what everything is. And then right here we have this little expectation breakers. And this is me basically saying, this is the one weird-ass thing I do that you really need to know that I do, okay? So the first thing is, it's C code, so you might be expecting header files and implementation files, right? Because that's probably the conventional way that people do things, perfectly acceptable way to do things. But for me, we're not doing header files and C files. We're doing .d._, for data. We're doing .f._ for functions, and sometimes we're going to do .p._, for public interfaces, which this is basically like a header file. But we always want to include this last because we don't want any forward declarations in our code. The reason we don't want forward declarations in our code is because, let's say we're looking at the code, and we're in the code, and let's say we find a function that gets called somewhere. So we see this get function right here, which is assigned to a macro way up here. So we see the get is assigned to this macro here, to this function. We absolutely know that this function is declared above, right? Because we're not using any forward declarations, so that imposes a very strict ordering on where our code, different functions are going to be declared, which I guess might be a very procedural kind of style, but that's how I want to do it. I just want to make sure that we have some very, I want the code to be very rigid. So, you know, a lot of people think that code is like this flexible thing, and I kind of disagree. I think code is more like a house than some type of ethereal thing that you can just refactor to your heart's content. Like, it's digital, and sometimes people think that just because it's digital, that it's like this magical clay that you can just refactor and shapeshift around your heart's content, and I just disagree with that. And so a lot of the philosophy of how I'm going to write this code is going to go against, I don't know if it's against the mainstream kind of C philosophy, but it's definitely against some type of mainstream, where I don't want flexible code. I absolutely do not want flexible code. What I want is a little bit of hybrid of waterfall, where I know exactly the design of the system that I want, and then like a little bit of discovery, where we do a little bit of Scrum kind of a thing, right? Like, we're on a sprint, right? We're trying to deliver a certain feature right now, and so that's kind of Scrumish, but then we want this like high-level overview, which is a little bit more waterfall-y, and we want to be as rigid as possible. And the reason we want to be rigid is because that makes the code less abstract and easier to wrap our minds around. So we're going to have a trade-off. And I would rather have rigid, very difficult to refactor code that is very easy to understand than some type of code with a lot of indirection that is very flexible, but it's harder to wrap your mind around because there's a lot of indirection. So that's kind of the philosophy of how we're going to go with this. Just very rigid code, because we're going to waterfall out a lot of stuff where we know exactly what needs to be what, and that means we are going to dig ourselves into holes. It's flexible in the sense that metal is flexible. It can be bent in any way you like, but it takes a lot of effort, and you really don't want to keep bending it back and forth, so everything is going to break. Yes, exactly. That's a good example. Sorry, my little chat thingy doesn't kind of like show everything you're writing here, and the reason why, so I can just put this here for a second. so the reason why my chat window is like it is, for an explanation, is eventually I want to like release this code base out into the wild, and let's take your comment right here. So let's go into like my little documentation thing here, and let's just do this. Let's go video integer ID, and in the bottom right hand of the corner, I can see that we're on video 53. So I'm going to do 53 right here. And then I'm going to put the time, right? The current time is 2 hours, 9 minutes, and 56 seconds. And then what I can do is I can take exactly what you've just told me, right? I can take that, and I can throw that into the documentation. Actually, let's do PF44, format that a little bit. I can take exactly what you just told me. I can throw that into the documentation. And once I upload this video to YouTube, it's going to have this exact video index in my playlist, right? So you're going to go to video 53, and you find 2 hours, 9 minutes, 56 seconds, and you can find exactly when you said this to me and what we were talking about at that time. And the reason for this is a lot of times you write code and you're like, what the fuck was I thinking when I wrote this code? And even when you write a lot of comments like I write, you still end up with the what the fuck was I thinking when I write this code? Like, it's almost like inevitable. So what we're going to try to do in this code base is we're going to tag a lot of things with the video integer ID. And actually, I use @ symbols rather than hashtags for that. Also, I'm going to explain this file I'm editing right now once I kind of like change this. Okay, so this file right here is my commentary file, where a lot of times as you're writing stuff, you just get a lot of comments, and the comments kind of clutter your code, right? And the clean code advocates would say, this is why we don't write comments, because the comments end up getting out of date, they clutter up the code, they distract from the code, etc. What if the code doesn't match the comments? Blah, 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 blah. So what we're going to do is every time we need to extract commentary from, like let's say we have a very long commentary somewhere, we can extract that long comment. So imagine we have like this some type of very long commentary somewhere, like this long commentary. We can extract it and strip it out of the file, and we can put like little tags, right? So we can leave the tag in the file, but we can throw the actual bulk into here. The reason for that is I do agree that the comments are the last thing people read, right? After everything has gone wrong, then they read the comments. So it makes sense to keep little tags to where the comments are, but to throw all the comments into this file. The next thing we're doing with this file is all of the newest comments go near the top, right? Because, so newest comments always go at the top of this file, so we have a record of what was done in what order. Also, you know how, like, as things change, the comments might become out of date? How we're going to solve that problem with minimal maintenance is if at any time we have comments that conflict each other, we're just going to say it's the newest comment. The comment nearest the top is the overriding comment, is the authoritative comment. No worries. The main reason for viewers to see the chat isn't seeing the messages. It's having content for where you're currently at time-wise to understand what you're reacting to. All right, awesome. But yeah, so this is going to act as like a kind of like a history and a comment file at the same time, right? And so I don't really expect anyone to have to read this linearly, right? Because it'd be very weird to read this linearly, because you have to read it like this, then you have to scroll up like this, and so you're constantly like reading down, scrolling up, reading down, scrolling up. That's really stupid. This is just a place where, hey, Master Z, yeah, you might want to change the text size so it doesn't get cut off screen. Yeah, that's what I was thinking. Yeah, I feel like you just I'm thinking, yeah, I don't know, man. That's a thought. Like, maybe I should change that. I'm thinking that I want it to be like a little billboard where we can, even if you've minimized the screen, that you can kind of still see what you've said. So kind of like a what do you call it? What's the Jumbotron? Jumbotron is kind of what I was going for there. But yeah, there is definitely a problem. My main priority with this stream, however, is the code here, right? Yeah, it was a raid from a guy who works on CUIs. His name is Hirosa. I can actually go like this. I can go like, I can go into my, here, let me show you something. So in my shortcut script, I can go like a CUI guy, if I type that, and then 2 commas. Okay, not exactly, but close. I can see this guy, and I see his Twitch right here. So whenever I want a guy who is doing C stuff that is related to UI, I can find him, right? Because maybe I'm not going to remember his name, so I can just be like, who is that CUI guy? And I can type that. And also, I noticed that CUI guy didn't really get anything. So what we're going to do is we're going to take this commentary here, we're going to take this little tag here, and we're going to say, use this, we're going to put the date. And this is just a little synonym in my shortcuts for finding this, right? So CUI go. And then in my shortcut script, I'm going to take this. I usually keep my shortcut script off screen. Shortcut script, I'm going to just put this in here. I don't know if I've described how this works to the new viewers, but it's just a file where here are the synonyms you can type, divided by little or symbols. Here's the data, and then here's what to do with the data. So if I type this, this is the data, and the data is going to be pasted into whatever editor I am working in. So it's an IDE agnostic system I have here of shortcuts, of snippets, of documentation, of tons of things. It's over 300,000 lines. I'm hoping to eventually get to 1 million lines, and I'm hoping that once I get to 1 million, I'll be a genius, or at least my shortcuts will be a genius, right? I'll have a genius level knowledge base, but it'll all be offboarded onto the computer, so I'll be part cyborg. Well, we're all part cyborg technically because we use computers. But yeah, so I know I've been ranting a lot, but I saw like a lot of new people. So I thought it would be good to kind of describe what the hell is going on here. Because, frankly, we're working on unit tests, and unit tests are boring as hell. So it's not like I expect this to be exciting. So I thought, hey, let's give a little rant about what's going on here. So Tausync is what we're working on next. So let's explain what Tausync is. So let me open up Tausync for a second. So Tausync, let's open up the data file and the function file. We want to keep data on the left. Data is on the left and functions are on the right. The reason for this is because functions depend on data. Data does not depend on functions. When we assemble our code base, we string together all of the data files first, then we just string together the function files. The reason for this is because we don't want, once you're at 1 million lines, you just write in the command for programming a game, and it finishes it for you while you go have dinner. Yeah, I mean... Yeah, kinda. I'm thinking, what I'm thinking is, it'd be interesting, like, you know, once deep AI takes over, I just give some, like, AI bot, like, all my shortcuts, and I'm like, here's my shortcuts, now do the thing that I wanted to do, and it'll just look at all my shortcuts, and it'll be like, oh, this is nicely normalized data, thank you, human, and it'll just be like, bam, here's your game, and I'll be like, yeah, that's awesome, thank you, you know? And I'll be like, yeah, have it ready after dinner, you know? Okay, so Tausync. Let's actually look at the overview here, because you notice that we have all these things called Tau right here. So let me clear my stamps here. So let's highlight Tau right here. So what does Tau stand for? Tau stands for texture as uniform, right? Because it's a big block of pixels that are going to be used as uniform values in my shader code. So Tau dirt is a dirty flag overlay of the actual pixels. The actual pixels, like the texture as uniform, that actual data is in Tau Depot, right, for our, like Home Depot. Except you'll notice that I didn't put a T at the end. You'll probably notice the very OCD style of everything here is exactly 7 letters. Which some people will be like, wow, who do you think you are? What are you doing, Fortran? But that's to eliminate the mental search space, right? If we have a very rigid naming convention, it reduces the mental search space for trying to think of things, find things, remember variable names, things like that. So this is the actual 512 by 512 texture memory is here. The dirty flag overlay is here. And this overlay it's like a quad tree overlay that goes over these pixels, so we know which pixels to push. So this is what marks everything as dirty. and this is what pushes it up to the GPU and marks everything as clean. So mark things as dirty, and then this is what pushes things up to the GPU and marks things as clean, and this is the actual data. And these are an abstraction on top of Tau Depot that creates certain types that we can wire up to the GPU memory. Now, the reason why Tau type is before Tausync is because we want to make sure that we only sync up to the GPU once per frame, so we don't want to allow Tau type to have any type of granular access to syncing with the GPU. So we're going to make that impossible by putting this system first, right? If we put this system first, it's not allowed to reference any systems in front of it, right? So a way we can avoid things reaching into places they're not supposed to reach is we have a very strict ordering, right? So pixel names cannot reach into FragMed, right? Because it's a backwards reference, right? The OpenGL constants cannot reach backwards into the window code, etc., etc., etc. I'm going to read some of the more of your comments here. TBH, that's probably going to be a thing eventually, not quite to that extent, and with some feedback from human every now and then, but still. What I'm really worried about in the future is, you know how you have, like, Manifest Destiny, you go out there, you get your property, you tell people to get off your property with a shotgun or something, and then eventually, once everybody's taken up all the property, people end up being serfs to landlords, and that's horrible, and then the rent's goddamn too high, the rent's too goddamn high, blah, 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 right? Property is this, like, limited resource, land is a limited resource. Eventually, we're going to have the same exact Manifest Destiny kind of problem, but it's going to be with servers. Right? So instead of, let's say you own a big plot of, I know I'm getting kind of political, so I'm going to try not to be too political, but let's say you own a big plot of land in downtown Seattle. You're rich. You're absolutely rich. You can just make a parking lot, you can charge money for it, but if you have that property in downtown Seattle, you're set for life, you don't have to work at all, right? Because you have that. So eventually, we're going to have the same Manifest Destiny kind of problem, but it's going to be with servers, right? Because if robots start to do all of the jobs, then your wealth is going to be determined by how many servers you own, right? It's going to be, your wealth is going to be determined by how much computing power you control. And I really think that's going to happen in the future, right? And I'm also worried that, I also think the way deep AI may destroy humanity is, right, you know how they always say that deep AI isn't going to be like, it isn't going to be like Terminator where it like shoots us, it's going to do something indirectly, and I think I know how it's going to happen. You're going to start to have like androids, right? And when it comes to that job at Five Guys, we might want to, the android is just going to be smarter than us, right? The androids are going to be so much smarter than us that why would we hire a human who's like a complete idiot compared to the android, right? So literally, like, all the androids will start to take humans' jobs. And if the androids start to look like humans, and we start not to be able to tell the difference, then slowly and slowly humans will kind of like be phased out, and we won't even notice that we're going away because we won't even be able to tell the difference. And so humanity might just like starve to death. In like well, it depends. Like if we get past a capitalist system, maybe we can survive that. But in a capitalist system, right, if we can't get jobs, we're all going to starve unless we get like some universal basic income. I'm not actually a communist. I'm actually kind of like a socialist capitalist, if that makes sense. Like I believe in things like worker-owned co-ops, and I think that's the future. So the whole like seize the means of production, I kind of agree with that, but I think that could work in a capitalist framework where you have very small corporations rather than large conglomerates. Especially with the advent of CNC and 3D printing, I think that a lot of products, the demand for products is going to become very niche, and pretty soon in the future, people are going to buy like tailored goods. Like when I wear a shirt, it's not mass produced, it's like produced by a small company, and I'm like only one of a few thousand people who wear this brand of shirt, right? Because the means of production as we do like CNC stuff and 3D printing, it's going to proliferate to a lot of small groups, and as greedy people who own corporations are trying to like pay us less and less money, it's going to be more and more affordable for us to like do CNC, and so it's going to be more and more of a lucrative option for people to start up very small businesses, and so we're going to see a whole bunch of micro factories and micro businesses that have the means of production. And so, I mean, I'm getting way too political. I'm trying not to like offend anyone here, because really I don't care what you politically believe. I really don't. I don't even care if you're a good person. If you like programming, then you're welcome here. I don't care if you're a serial killer. If you like programming, you're welcome here. Obviously, if you're a serial killer, you're not invited to my house, but you know, but you're welcome on my stream. So I'm gonna read more of the comments here. That's a bit different, though, in that we can manufacture servers, but not land. Yeah, you're correct there. We also have to think about limited energy resources then. But yeah, you are correct where we could, like, right, we can even build up. But then it comes back down to land, right, where maybe it's still a land issue because the servers have to physically exist somewhere, so it still comes down to who has the land. But now the land is like a server farm. It's not necessarily about being smarter so much as 100% obedience, no salaries, no emotional needs, no HR necessary, no toilet breaks, no smoke breaks. Yeah, you have a point. You have a point, right? There's all of those other aspects. It's not just about being smarter. It's also just about just being that perfect cog in the corporate machine. But yeah, AI advancements are definitely going to have a huge impact on the fundamental structure of society. Yeah, you are correct. Unless you keep unless you keep the servers in space. Yes, I want a space server. Yeah, my cloud, I want my cloud just to be like, you know, it's a gas giant. Yeah, my servers are literally like in a gas giant cloud somewhere. Yeah, I think that's a good idea. So hold on, I've been drinking way too much coffee, so I gotta take a break and just get a whole bunch of fucking water. Because this is my one like caffeine day. I don't drink caffeine on any other day except for today. And the problem with that is I think I've drank way too much, so I'm gonna like put this coffee cup really far away from me. Because I can kind of feel it giving me like little cramps. So if like I die on stream, you'll know why. But hold on, we're gonna go to the break screen. I'm gonna get some water really quick. I'm gonna put on a timer for. I'm gonna actually set a timer, so it's not like you're gonna be like, oh my god, they're on a break. When are they coming back? We're actually gonna set a nice little timer here, and we're gonna give it like 8 minutes. Yeah, I can almost hear the caffeine as you speak. Yeah, so. I have a problem with caffeine. It's one hell of a drug, and it makes you really efficient, but if you drink it every day, you start to just need it to be normal, right? So what I do is I just drink it once a week, and so Monday is my super productive day where I get a shit ton done. But I'm actually kind of like abusing my body a bit, right? So you don't want to be like constricting your... you don't want to be constricting your blood vessels like this on a daily basis. That's not healthy. Okay, we're on break time. You don't want to be doing this drug like every single day. It's not good for you. People kind of like treat it a little bit more casually than it is. I treat coffee like it's like cocaine or something. You know, I think that's probably a better way to treat it than how people treat it so casually. Like, I mean, think about it. If we were like, if I made tea with like coca leaves, it would pretty much be the same thing as like coffee or tea. Like, I can't tell you why I know that. Just connect the dots there. But yeah, so coffee is one hell of a drug. You got to be careful. The problem with caffeine is 70% the problem without caffeine. Yeah. Okay, hold on. I'll be right back. I got to get some water. The problem with caffeine is 70% the problem without caffeine. Let me think about that for a second. Oh, also, since I want to make sure that that when I put something on break, that I don't what do I mean? I don't, even though I'm back right now, I don't want to start coding or anything until the timer drops to 0, right? Because I want to make sure that if you're watching along and you also want to break, then you can do whatever you need to do right now, right? So I don't want it to be dependent on when I come back. It's whenever that timer goes back down to 0 that we're out of break. So, you know, if you're doing something, you know, you got like 4 minutes and 46 seconds still to do whatever you need to do. So what I mean, we can chat or whatnot, but we're not going to do any more code stuff until people are back, right? And then, oh, and I got my water, by the way. So, oh, by the way, I don't know if Master Z is still here, but how you feeling? You feeling all right? Oh, I know, Master Z. But Master Z has been having a rough time lately. I'm not going to get into why, but I know that things have been kind of rough. So, hopefully they've been feeling a little bit better. I've been through kind of the same things that they've been through, so I kind of understand. But yeah, life's rough, man. What else? Yeah, so we're still on break, and we're gonna start writing those unit tests. And like I say, you know, I'm not gonna feel bad if anyone leaves, because this is not gonna be this is not gonna be fun today. Today is not fun. Today is writing test code, right? Tests are not fun, but tests need to be done just because it's going to give us sanity of mind that everything's correct. And the more and more code we write, the bigger our system gets, the more potential for error compounding, right? So a small little bug in one system isn't a problem, but if we have like 15 different systems kind of like chained together and they all have one really small bug, that's going to compound exponentially, and then you're going to get like really weird, very hard to find problems. So even though I hate writing tests, we're going to write tests to make absolutely sure that things work properly. Tests are not fun, but can prevent a ton of unfun down the line. Exactly. So to speak of that, one of my other philosophies for how I write code is I write my code slow as hell. Slow. But I'm like a bulldozer, okay? So I'm going to go really slow, but I'm never going to slow down, right? So we're going to write things in a way that takes a lot of time, right? We're going to comment things. We're going to write diagrams. We're going to write tests. And it's going to be painfully slow the way we're going to do this. But we're never going to slow down, right? So, like, if you ever started a project and you just kind of hack it together, and you're like, wow, I'm making so much progress, this is so awesome, you know? And then eventually, more and more problems compound because you've been so disorganized, right? And eventually you hit this critical mass where everything slows down to a painfully slow pace, right? But now you're at a painfully slow pace and you have shit for code, right? So what we want to do is we just want to start out at that painfully slow pace and have excellent quality code, which is very subjective, obviously. But we want excellent quality code, and we're just going to keep on going at a nice slow pace. So that's also why I have C code. So my previous game was done in ActionScript like 8 years ago, and then ActionScript kind of died, and I was really depressed about that. Did some enterprise programming jobs after that. Took me a lot of experimentation to kind of figure out what tech stack I wanted. And I eventually chose C and OpenGL. And I was messing with Vulkan, OpenGL, and OpenCL. Vulkan right now is just off the table, honestly, because I'm just not a good enough graphics programmer to be doing Vulkan. I did 2 of the Hello Worlds. I did 2 Hello Worlds in a row and got up to the swap chain, all with my code, all native Win32 code and Vulkan. Oh, time's up. But yeah, so C is my language of choice because, yes, I am doing, I guess, turtle coding. I don't know if that is a actual thing that exists or if that's just something you've come up with. But I'm using C because I want, I know I'm going to take a long time, and I want some type of code base that is going to be around for like 10, 15 years. I want like this to just, I know I'm going to take a long time, so I want something that I don't have to worry about, oh my god, it's no longer a relevant language. And so, because a lot of things are built on top of C, all of those technologies kind of have to die before C dies. So I think C is a good choice. Also, C has a proper application binary interface, which means that other people who are using C++ should be able to easily use my engine, right? Just made me think of the story of the turtle and the hare is all. Oh yeah, totally. So, let's look at Tausync and see. I know we said we were gonna write the unit test code. Do we even have the actual functions? So we have this texture push 32 by 32 region max. So it takes this pixel bounding rec, and it looks like we have abbreviated it as PBR right here, pixel bounding rec. You're going to notice that my code is very macro heavy, but I try to make sure that all the macros I use are locally declared, right? So I put all the macros up above in this section, and then within this section I usually have only one function, and then I immediately undef these macros. At any time, if I am using a macro that is declared in one file and used in another, I'm going to actually use the word macro. Notice that all of these say macro, because one of the things I hate about macros, I think the worst part of macros, I mean, there's probably a lot of bad things about macros, but one of the worst parts is you think you think you're not using a macro, but you are using a macro, right? So we have this thing, and is rect correct size, 0 to 1 inclusive. So we have this halting function. Another thing we could do is we want to make this a little bit easier to read. We don't really care about the namespace of this halting function, so we could just do like define ERR and put this here, and then down here we could put this right here, and then ERR, right? Because we don't really care about the exact name of this, and it's actually just a lot of visual noise, so we can just kind of like do this and make that a little bit less noisy. So yeah, let's see. We're taking, okay, so we're making sure that the, so this is a, it looks like a width and height check, and then, okay, and this is making sure that the rectangle is not, making sure that the rectangle isn't flipped, right? Because if this is less than 0, then we have the x0 and x1s swapped. So the bounding rectangle for the region of pixels to update is an inclusive rectangle. The lower bound is an inclusive x that's called x0. The upper bound is x1, and the same thing with y. The upper bound, or near the top of the screen, is y0, and the lower bound is y1. And this is just, you know, making sure that the rectangle is the correct size. So since we are very verbose in the way we write our code, we kind of do these little dividers to kind of be able to quickly see what this is about and then scroll past it. So to do vital actual subtext 2D push here. So this is going to suck because I need to, it's been a while since I've done any OpenGL, even though I'm doing this project in OpenGL, so I'm going to have to look up the documentation for doing the correct push, but I also have some projects I've written previously where I can reference them when I'm doing this. But we'll notice that in the agenda screen, it says a dry run unit test. So what we're going to do is we're going to pretend to call this but we're not actually going to call this part, right? We're just going to do everything else and kind of do like a stub this in and do like a fake call to this. So let's see. So this is the actual syncing function we're going to run. And we do see a vital to do need to run the dry test. So right, this might look crazy as hell. So traverse that bitch, and then all the different nesting levels for if we want to look at the data structure. That would be in tau dirty, right? So Tausync clears all the flags that are in tau dirty. So if we look at, let's close this one. If we look at tau dirt, and the data, right, this stuff here is traversing this data structure here. And so we can kind of reference this for help. Now you'll notice that everything is very particularly aligned where I didn't really... we have a lot of nested loops. We have 1, 2, 3, 4, 5, 6, but we notice we don't have like 6 levels of indentation. And that's very intentional because I think that this type of spacing is actually going to make this easier to see because we can see if we highlight things, like if we highlight everything that's 0, and then we highlight everything that's 1 here, and then we highlight everything that's 2 here, you're going to see a very obvious pattern right here. So even though it's like a lot of code and you're like, oh god, this is confusing as hell, we can do a very quick visual check to make sure that this code is correct, right? Where we can just see a very consistent visual pattern. And one of the things you'll notice, so you see this tau, sub, and var. That is actually in a different diagram, but we can notate it here as well. So right here, this thing right here is, so let's take, so tau would be, so if we like point at one of these guys, this would be tau, because it's one of these cells here. So there's different annotations that sometimes are synonymous, but tau is this guy right here, and then the sub right here, at sub, is like this guy right here, so at sub, right, is this guy right here, and then at var is like is this guy right here, at var, and so this is a little bit claustrophobic, like. I mean, that makes it a little bit harder to read. I think I might want to put like just one more space here to make it a little bit nicer. Then we can go like that. So that's what when we're looking at the diagram. At tau is talking about this data structure here, and then at sub is talking about this next nesting level, and then at var is talking about this final nesting level in our tree. Okay, so. We need to figure out how to do this test. So where is our unit test? Our unit test should be at the bottom because, right, our unit test code is going to get really bulky. So we see this unit test. We got to make sure it's actually being called from somewhere. So let's make sure that in our initializer it's being called. So I got this little log message. We see unit test init none. So to make sure we don't forget any of these systems in our project, we're going to use a thing called init none. And why we call it init none is so that if we are searching for this system and we're searching for init, we're also going to find anything that says init none. And that is saying, oh, we don't really have any initialization code. Okay? At kanji coder. So far in DC, going to be home soon. Oh, cool. What the hell are you doing in DC? So I do have, so the reason why we're not calling this none init or no initialization or something like that is, remember, we want to think of ourselves as stewards of the code. Make sure people can find their way around the code. So if someone's searching for an initializer, they're going to stumble to init none. And then init none is going to be called, if you want to know where that's being called, we have a main file that kind of chains, that kind of like puts all this stuff together. So let's go look for init none in the main file. And so this says Control F help because we want to figure out where this is actually being called from. and it's being called directly below here, but we're using some indirection with macros, so we want to make it kind of easy to figure that out. Tausync init none. We have tausync init none is right here. And if we highlight let's just highlight this part here. We'll get rid of the namespace and we'll just do this. And we should notice f macros, tausync init none. So you'd be like, well, why do we have this f macros thing? Well, first of all, it's called f macros because, once again, if we're using a macro, but the macro is declared in another file, we want to make absolutely sure that we know it's a macro. So we call it f macros. The reason why all these functions are macros here is, remember, we have this, we have the library chain, right? This library chain of how we're compiling up to any level, right? And so if we're compiling up to only pixload, let's say we're only compiling up to pixload, then we need a way to not call these, right? But we want to make this like a nice little list of all the things that are being initialized to like account for all the systems. So if we only compile up to pixload, then these macros here will turn into empty lines of code, right? So if these systems are included, then these macros will actually route to the correct initializer functions. If the functions are not included, then these turn into empty lines of code. And that's just so that we can, also these checksums are wrong. Let's take this checksum right here, right? We have 14 lines, and let's update this checksum and hope that we're not missing anything. Okay, yep, so we got 14 and 14. Yeah, so it's just a way to have a nice solid chunk of everything initializing, because if we wrap all of these in if-defs, it gets really ugly and really cluttered really quick. So we can be pretty sure that this init none is going to be called, and even though it doesn't initialize any data, we still kind of use it to hook into the unit tests. So we're kind of like embedding our unit test really deeply into there. The reason why we're embedding our unit tests kind of like into the code like this is, you know how like sometimes like it's like a temporary, where people are like, oh, it's just a temporary change, and then it ends up not being a temporary change or something like that. We got to think that everything in life takes the path of least resistance. So what do I want the path of least resistance for my test to be? Do I want it to be really easy to shut off the test and forget about them and let the code rot? Or do I want to, like, ingrain the unit tests so deep into my code that it's a pain in the ass to shut them all off? And I would say I want to make it a pain in the ass to shut off all the tests. So I want to get those tests, like, really tightly coupled with my code. And it's not that, oh yeah, eventually once we have a running game and we need to optimize everything, yeah, then maybe we'll have to figure out how to shut off these tests. But we want to make sure that our code is correct, and we want to make sure we have a working product first. So we're going to, yes, exactly. Nothing is as permanent as a temporary solution. So taking that adage into mind, I want to think, well, what is the... So we know, like, in the hypothetical academic space of, like, in a perfect world it should be this way, but it's not a perfect world. So in our imperfect world, how do we want things to, I guess, go wrong? And how I want things to go wrong is to have these tests kind of, like, painfully ingrained into this code base where it's so hard to, like, stop running them. So that's kind of like why we're going to do it this way. So that's another, like, kind of like insane thing where people will say, oh, that's a separation of concerns. Why the fuck do you have your unit test inside of the same file? Shouldn't you have, like, a unit test file? And nope, we're going to do it this way because we want it ingrained in there. We want it ingrained in there. We want to dig it in there. Also, if something ever goes wrong with my unit test, the code I want to look at is going to be in the same file, right? Because the functions I'm testing are in the same files as my test, which actually makes a lot of sense. However, This is the unit tests are the one exception where I am going to use forward declarations, right? We see this forward declaration here. I use extern here because I just want to be as explicit as possible. And sometimes people forget that extern variables and forward declarations are the same damn thing, because extern is implicit when it comes to a function forward declaration, but extern needs to be explicit when it comes to a variable declaration. And I find that confusing as hell. I get why you would do it, because if you're like a pro C coder, yeah, you just get it and you know it. But like as a newbie, like as if somebody who is new to C code is looking at my code base, I don't want them to like look at something and not realize what it actually is. So if we have the extern keyword here, and somebody's looking at this line and being like, what the fuck is that? And they don't know C very well, they see this extern keyword, they have something to Google, right? They have some way to get into this code base. And, you know, we got to think about, well, how much do we want to aid people who don't know C very well, right? Because at some point that could hinder your programming if you have to explain every little thing you're doing, right? But I don't see it as a big deal just to include one extra fucking word so that people who, you know, aren't as good at C can kind of figure it out. I'm not saying I'm a genius at C, okay? I'm not saying I'm like a super C expert guy. I'm just saying that we want to make this code base as inviting to other people as possible. Even though we're being batshit crazy and we have like very strict ways of doing things, I actually am a person who wants to make this code easy for people to find their way around it, even though I have these weird ways of doing things. Okay, so what are the functions we need to use here? So let's go and make a little notes file here. Let's just make a little notes file and kind of throw things in here that we need to look at, right? So, you know we're not going to need to look at this unit test file. That's one of the things we're going to need to look at. And then what are we actually testing, right? So, oh yeah, we're testing this run function. Are we going to just keep the public run function? Yeah, sure. We're going to just test the public interface. So this is what we're testing. And when we're testing this, we're going to have to use it in conjunction with the dirty stuff. So if we look at tau_dirt for a second, so tau_dirt functions, we have a do one thing and do one thing well function. So dirty sector update, we're going to need dirty sector update. And so let's put dirty sector update. Let's actually look at the signature for dirty sector update really quick, and let's just throw this into our note file as well. So dirty sector update needs this thing right here. And now when we're going to when we're actually going to set stuff, actually we're not going to use dirty sector update. We're actually dirty sector update is going to be indirectly called by the depot. So if we look at the depot, so tau depot functions, right? So this is where we're setting the actual variables, and you're going to notice that this putter and this getter, these function signatures look awfully suspiciously like dirty sector update. And the reason for that is, right, our dirty quad tree is just an overlay over that 512 by 512 texture memory, right? So these things just put the stuff on the texture, but then we want to, in parallel, update the quad tree, right? So the quad tree and the actual data are not one and the same, right? And a lot of people would be like, that's a horrible design. Why are you using these like parallel data structures? Why don't you just nest all the data together? Well, one reason we could say is, oh, well, it's cache friendly the way I'm doing it, right? Like I'm doing it in a data-oriented design. The other reason is kind of data-oriented. It's because what we're actually manipulating is a 512 by 512 block of pixels that we need to push up to the GPU, right? So we can't ingrain this data with the quad tree metadata. They need to be separate structures. So let's take these put functions, and let's take the get functions. And so the thing is, this is kind of going to be like an integration test in a way, right? Because we gotta in order to test the syncing And we're gonna need to mark things as dirty, right? Gonna have to go now, but it's been interesting. Definitely gonna come back some other time. Oh, that's awesome. Thank you. I'm hoping that, after coding for so long, I have something unique to offer, because I don't know. Yeah, awesome. So, what is slash? What is that? What is that acronym? What is that? What's that? What's that? What is this thing here? What is the O slash there? Anyways, yeah, good talking to you. Good. I'm glad you find what I'm doing kind of interesting. But yeah, I'm gonna do this every day except for Sundays. Sundays I'm not allowed to program because my girlfriend says so, because I work on stuff too much. But every other day I'm working on stuff. I don't have a consistent schedule, but I try to do 8-hour blocks. Supposed to be a head and an arm, as in a person waving. Okay, yeah, actually, oh yeah, I can see it. I can see it. I like your ASCII art. I'm a fan of ASCII art, as you can kind of see from what I've been doing. But yeah, I will see you later. And I'm going to continue kind of explaining things as I go to other people who might be watching, because I see 6 viewers. So let's keep on doing this. So, in order to test the syncing with the GPU, right, because this code is going to run over all the dirty sectors of data and push them up to the GPU, we obviously need to mark stuff as dirty before we can even test that. So we need to, let's see, Tau Depot, we just need to we collected those function signatures, that's all we need from there. Dirty, we might need, in dirty sector update, what we might need is we have a little helper function in here, which, for unit testing, I think it's called for unit testing. We also might need that function as well. I don't know what it's called. Let's look for the word testing really quick. I thought it was called something. Complementary function for unit testing, not that one. Actually, we called it clear or something or other. It was called clear. Force clear for unit test. We're going to take that one as well. So I got this just stuff we need. So this is just so we have a clean slate when we're doing this. And in here, what we should do is, we did this in the other function where the public version of the function kind of like backed up the data. And okay, so a lot of times when people are doing testing, like in Java or JavaScript, they'll use like mock objects, right? And we're not going to do that. What we're going to do is we're going to back up the systems we're mucking around with. We're going to back up their data. We're going to muck around with the systems and test with them, and then we're going to restore the data. The reason for that is we don't have to worry about, oh, does the mock exactly match the data, right? So we don't have to add mock code, so that's less code we have to write. And then sometimes making mocks can be really tricky with trying to like emulate certain behaviors. So I'm like, fuck that. I don't want to write that code. It's hard to do. And then even if you think you've got it right, it's not actually working with the actual system. So it's like a rough proxy, and you just hope you got it right. So I think a better way to do it is to not write mock code, is just to back up the certain sections of data that we're going to muck around with, and then just manipulate that data, run tests on it, and that way we're working with the actual live data rather than some type of proxy. So I think that's probably a not very test-driven development way, but I'm probably going to trash talk test-driven development a lot. I like tests. Tests are a great idea. You need to write tests, but the whole idea of like writing tests first just seems stupid to me. Sometimes you know what the data needs to look like first, and you don't know what the interface needs to look like, and so you should start writing the code from wherever you have the most clear, concise picture of what needs to be done, right? And so to arbitrarily force yourself to work from the front to the back, right, from the interface to the code, I think that is destructive. Okay, so now that I'm done trash talking, if we look at Towdirt, we have some code that we can kind of reuse. So we have like backing up and restoring some data, and we're backing up the pixels that are actually storing the data. And you notice the actual pixel data is in this thing called pixname. Let's take a look at pixname so you can see what pixname is all about. So pixname.d for data. And what we've done here is we wanted to centralize all of the 512 by 512 texture allocations. Just because it kind of makes sense to have one place where there's a high-level overview of where all the different data for all the systems are, right? So when we're talking about Tau Depot, right? Tau Depot, this system's data is right here. For Paint 5D, this system is right here. And then you're going to see 2do 0, 2do 2, and 2do 3. These are kind of like systems that we don't know what these systems are going to be yet, but we still allocated data for them. The reason for that is we want an obvious pattern in our code, and we need like at least 3 things to have an obvious pattern. And some errors in our code aren't going to happen until we have like at least more than one of these. So to kind of like make sure that our program flow is correct and doesn't have any problems, we're going to kind of like stub in some things here and waste a lot of memory and whatnot, just so that we can have a program flow that's more consistent. So this backup and restore thing, we're gonna actually use kind of like all this stuff. So we're gonna take, we're gonna clean it up a little bit, but we actually need all this stuff. So let's take all this backup restore stuff. We'll clean it up a little bit, because this is kind of ugly, isn't it? We commented out some things because we realized it wasn't a good idea. But let's let's just take this all the way down to here, and then in Tausync we're going to we can keep that. We could actually move this back here like this, so we can kind of guard it like that. I know the spacing is kind of weird like that, but now let's take everything that's commented out right now. We don't need that. We thought we needed it. Well, let's make sure. Oh, actually, we do need it this time. We thought we needed it for the other test, so we backed it up, but we didn't. But for this test, we actually need the stuff we commented out. So we'll get rid of these stamps here. Don't abuse the stack. Yeah, we'll keep those commentaries. And we'll highlight this because we're going to have to change this commentary here. We'll just remove all these things here because we were backing up some things that we didn't need, but we need to back up those chunks of memory. Okay, so we're going to just... okay, so now that we have this here, the next thing is... yeah, we can back that up too as well, even though maybe it's not necessary. And then actual test stuff, that's going to be... actually, we're not going to run Tausync run. That's actually wrong. Or actually, is this the... oh, shit. Okay. Oops. I'm in the wrong place. Let's take this. AAC 2020. My bad. Okay, so this is going down in my unit test code. So let's just paste this in here. Okay, that's where it needs to be. And then the unit test. This is the wrong unit test. Oh, okay, this is, sure, we can do that. So this unit test should be guarded, where if it's already ran, we're going to run it again. If it's already ran, we'll skip it. It has like a guard inside it. And we just want to make absolutely sure that the test code that this depends on is going to be ran before we run this, right? Because if this fails, but we had a problem with the previous sub-library, then we're going to be looking in the wrong place for our problems. Okay, so this thing needs to be changed here, and then the unit test right here is now going to be Tausync unit test. And let's make sure that's actually declared, right? So yeah, so this test right here, so this is the public version. Do we have a private version of it yet? Doesn't look like it. Okay, so within here, we're going to do a void, and then we're going to take the same thing, but it's going to be lowercase. And we don't care about it returning anything. This is a private thing. We don't care about. If we need to return from it, we can do that eventually. But right now we don't care. Oh, hold on. Dash line I1x64. Yeah. Okay. So this is our private unit test. The public unit test is kind of like doing all of this backup logic. So there's a lot of like excess kind of bullshit that is cluttering this up. So we're gonna do the backup of the data, then we're going to call the actual unit test code, and then after we've done the unit test, we'll restore the data that we've kind of mucked around with, right? And we'll have some logging messages for when we have, like, you know, exited and entered the unit test. And another thing we need to do is, I believe, why is that not indented correctly? We need to change these things. So these little headers here are incorrect, right? Because it's no longer Tau Depot we're in Tausync. We kind of like cut and pasted there. So Tausync. And we'll just paste that here. And you'll notice I called them backup or restore, right? So the reason they're called backup or restore is because that way I just can see these sections, right? So I can see this section here, and I can see this section here, and I can see the complementary sections, right? So we could call this backup, and we could call this restore, but I think it's nicer just to be able to highlight this token here and see it light up here and see it light up here, so that we can see where the paired pieces of a code are, right? Because these pieces of code actually have to be paired with each other, right? Because this is the backup, this is the restore, right? It's kind of like a, right, wherever you do your mallocs, you got to do your frees, right? So kind of a similar concept right there. So with this unit test code, let's get into it. So we got right here, we need to fill some stuff out. So what's the first thing we can do to make sure that everything's working? Well, we're assuming that all of the data is clean right now, right? So how are we going to push up to the GPU, like simulate pushing up to the GPU and get some type of feedback? So I think that the syncing function, should actually tell us how many chunks were pushed up to the GPU, right? So we have some type of feedback function that will give us some way to test what we're actually doing, because I think that's the first way, and then also just being able to yeah, I think that's the first thing I want to do. So let's look at the syncing logic. So this is what actually syncs the CPU side textures. So these CPU side textures, this Tausync is using this texture memory here. Tau stands for texture as uniform. And this is going to do the actual syncing logic. And we got like a whole bunch of shit here. So we should probably return a value that tells us how many chunks that we have have pushed up to the GPU. So let's see if we have like a public version of this function or anything, and it looks like we do. Let's change the signature to be, well, let's think about how much, God, we have a lot of things open. We're gonna, for our sanity, we're gonna put this over here, our notes, and we're gonna close everything to the right for a second. And I'm actually going to call this, I'm going to save this as tausync.n for notes. So in my library, I'm just going to call this tausync.n.underscore. So this is like my little notes file for these systems. Just because I want to, there's a lot going on there. So in, hold on, I lost my train of thought. Let me get some water here. Tausync run, we want to change the signature here. Oh, we want to look at the diagrams. So Tausync's data. I don't know if Tausync actually has a diagram in the data. No, it doesn't. But Tau Depot and some of the other related things do. So let's look at Tau Depot .d. So we want to know how many of those dirty sectors that we updated. So we're doing like a quad tree overlay over the 512 by 512 the 512 by 512 pixels that we use as texture memory to store uniform values. We have a quad tree like overlay that's 4x4, and then within that 4x4 we have another 4x4. So one of these cells gets once again divided into another 4x4, and then one of these cells gets divided into a 16 by 16. So we need to think about that. So that means we have 16 times 16 cells here, times 4 times 4 times 4 times 4. So how many total cells is that? So let me just get a calculator up here for a second. Let's go to Google. I really like Torch browser, but I tried to get the default page to be configuring it nicely is sometimes hard. So 4 times 4 times 4 times 4 times 16 times 16. Okay, what kind of number do we have here? So we definitely can't use an 8-byte integer here. Let's just use a 32-bit integer. And since we have enough room, let's just use a signed 32-bit integer. None of those numbers should be negative, but let's just use a signed, because we have the extra space. Let's just work with it. So the reason I'm not using like a 16-bit integer is like I don't want to be that granular. So let's call this I32. So it's going to return int 32 value of how many dirty sectors were pushed. And we can kind of like space this out. So return number of dirty sectors pushed to GPU, right? So this is what we're going to return. And then we kind of like wrapped this in some logic. So we're going to have to make our formatting proper again. And we're going to say right here, we're going to do I32 num dirty sectors pushed to GPU. So a lot of times I write my code very terse, but if it's not a very common variable that I use very oftenly, we'll just give it a very long readable name, and we'll call that 0. And down here we're going to return it, right? So we're going to organize the code so that we have exactly one exit point, just because that's the way I like to do it. And then this number of dirty sectors pushed is going to be equal to this function call here. And if it's not dirty, right, if the root of the tree is not dirty, it's just going to be 0. We already have 0 here, but what we're going to do is we're going to do an else to make it a little bit more readable. And in the else, we're going to call it, we're going to mark it as 0. And then what we're going to do up here is we're actually going to do a trap value, right? We got the signed integer, and a negative value is always invalid, right? We're either going to push a positive number of dirty sectors to the GPU, or we're going to push nothing. So a negative value would be invalid, so we're just going to use a trap value. So we're going to say 666, and it's a trap value. So what that means is in our one site where we can return a value, if we get a negative value, it means we royally screwed up our logic somewhere, right? And it's kind of like a number that we can kind of grab onto, right? And it could be like 066 or something, right? Something that kind of like obviously has a pattern, where you're like, that looks very patternish. Maybe we can find that in our code somewhere, right? So we could actually do something like this, and then let's see if that number is used anywhere in the entire code base. So if we take this entire number here, and we do like a find in files, and we look for it, we only find it in one single file in the project. Now, obviously, we have a limited amount of numbers that we can do that for before we run out of kind of like unique numbers with patterns. But it's better than nothing, right? So if we see this number anytime, we can be like, this number looks suspicious. Let's look for it in the source code, right? All right, so dirty sector push. We're going to call the private version of this. We're going to change the signature on that as well. Now, we may need to actually declare... we see that in this section here, we've kind of like declared a lot of types. Oh, I32 already declared, cool. So let's look for where this is called. So right here, we're going to change this to I32 for int32, and it'll still take void, and we should give it the same exact name. Like, if it's the same exact piece of information, it should have the exact same name verbatim. So even though this is kind of long, we're going to use the exact same name here. And we can use a different trap value this time, right? So if the problem came from here, we can do like 777077, right? Some just random ass trap value, and it's an int32, right? And then down at the end of the function, right here, we can return, right? We'll have one exit point. And this is the other thing, like if we screwed this up and we have some other exit point somewhere else, we'll probably catch it because we'll get that weird trap value for some reason. And, well, possibly. So, num dirty sectors push to GPU right here. Okay, so. How are we figuring that out? So, it looks like right here, this is the bounds of the 32 by 32 section that we're going to push up to the GPU. So we're obviously using this somewhere. Okay, we got a nice little diagram here to remind us of each variable is actually stored in a 4x4, each variable on the GPU is stored in a 2x2 cluster of pixels, meaning that we could have an up to a 128-bit integer unsigned value stored in our texture memory, because we're giving everything 4 pixels. The reason for that is a lot of my data is going to be rectangles, and rectangles need 4 data points, x0, x1, y0, and y1. So I'm like, you know what, let's just give everything this amount of space, right? And maybe we'll waste some space, but at least we'll have a very normalized data structure that has enough memory for the common use cases. Okay, so in here, we see the texture push right here. And so what we can do right here, this is kind of where we need to increment that value, right? So the number of dirty sectors pushed to GPU, that needs to be updated right here. So we'll just, ooh, what the hell, come on. So we'll paste this right here, and we'll just do ++, and that's all we need to do. Now, if we wanted to have some other type of feedback, like the exact number of pixels, I think that might be some good feedback. Now, the problem with that right now is we're only returning one 32-bit integer. So if we really want to keep track of the exact number of pixels pushed, right? Because remember, it's not always going to push up. It's not always going to push up this exact 32 by 32 region, because there's going to be a thing called a dirty rectangle, which is going to encompass all of the dirty data points. So we're going to try to optimize that and not push more data than we need to up to the GPU, because we're going to do this every single frame. So what we could do is if we want some more fine-grained kind of feedback, we can make a private variable to give us a little bit more feedback. So we could call it AAC 2020 Tausync, and num dirty pixels pushed, something like that. I'm gonna say num dirty right. I don't really have a this is a very specific thing, so I don't have a normalized way to make this variable because I'm just making it off the cuff. If I'm just making up a variable off the cuff, it's going to have a more verbose name, right? And so we'll just say num dirty pixels pushed or something like that. And then in our data file, so this is tausync.f, in tausync.data, we really don't have any, it's a function-only library, so this is a unit test flag, and this is really just for unit testing as well. So this is a, this is also going to be an i32 value, so int32, and we'll initialize that to 0. We also need to make sure we clean it up correctly as well. So define i32, and then we're undefine it in this section here. So undef i32. Okay, so this is just for, this is gonna give us more feedback. Give us more feedback in our unit test, right? So we have some more data to kind of grab onto to verify the correctness of what's going on here, right? So, so the number of dirty pixels pushed, it's not just a plus plus, so we're being idiots here. So let's actually figure that out right now. It's going to be the regions, right? So we have this rectangle here, and it's actually going to be the area of that rectangle, right? So it's actually going to be PBR, which if we want to look and see what PBR stands for, like I know what it means, but if we want to know what the actual abbreviation is, we can go look at this define and we see pixel bounding rect. I didn't actually need to see that, but if you wanted to know what that meant, that's what it means, pixel bounding rect. Oh, we have it here as well. So the pixel bounding rect is what we're actually pushing up to the GPU. So let's do dot x1, the larger bound, minus PBR dot x0. And then plus 1, because it's an inclusive bound, right? And then we're going to multiply that by PBR dot y1 minus PBR dot y0, and then plus 1, right? And now that we've done this, right, if we want to make sure that people following along, if they get access to this code base, we want to make it easy for them to know where this kind of came from. So we could do this. We can go into here, we can inline a comment saying the video integer ID, the vid integer ID is 0053, right? Because in the bottom right-hand of the stream, the bottom right-hand corner, you're going to see that the date is Monday, and the integer ID of this video is 53. The current time of this stream is 3 hours, 23 minutes, and 4 seconds. So now, if you want to ever look at this code and be like, what the fuck were we thinking? We're going to have a little commentary here where you can go back to the video archives and see exactly what the hell we were thinking when we wrote this, right? So this should be just the area. Another thing I do is if I will quickly want to make sure that this is correct, we know that all of the x's should be on one line and all of the y's should be on another line, right? And so we see the colors match. Then we also want to cross-check it the other way, so we can highlight all of the 1s and highlight all of the 0s and see, oh, we got the 1s on the left and the 0s on the right, which seems like a very tedious way to check things, but we want to be slow and we want to be careful. And so some of the big bugs that I get are from transposition errors, from doing something stupid like that, and they can be really hard to debug. Like, you rip your hair, screwing this up, like if I screw this up right here like this, and I don't realize it, I'm going to be pulling my hair out for 3 hours, writing test code to narrow down where this is coming from. So we don't want to do that, because it's gonna it'll fuck us up royally. So we want absolutely want to make sure of that. In fact, sometimes I will do something like this, where I'll do like x, and then like 1, and then over here I'll do like or not x, because these are x's and y's. So so I'll make something like this where the pattern is more obvious, where we see these 1s and all the 1s line up. And then we do like, you know, x and y, or this is x only, right? X only. And this line is y only, right? Right, it's a very paranoid way to do it. It takes up a lot more lines of code. But the idea is we want to be as paranoid as possible, because if we screw this up, then we're going to be pulling out our hair for a very long time. So let's make sure that everything is unique here. Right, so another little heuristic is all of these colors are unique, so they're all unique tokens. So we're pretty sure that everything is correctly accounted for here. And this is what I'm talking about, fast versus slow thinking. We want to make sure that that when we visually look at this code, we can kind of see, we can visually see if it is correct or not, right? So, now that we're here, are we correct here? Are we off by 1 with this formula? So let's say this is 1, and this is 1, and this is 1, and this is 1, right? Well, 1 minus 1 is 0, but then we're going to add 1, because we're in an inclusive rectangle. 1 minus 1 is 0, but we're going to add 1 because it's an inclusive rectangle. So that's 1 times 1, that's 1, because it's a 1 times 1 area, and that makes sense. So the math makes sense. So sometimes to make sure you're not off by 1, you want to test with like the smallest data set, right? Because the math is going to be uniform no matter what values you're using. So just use the smallest values you can think of, and just make sure that the logic works with those small values. And right, it's helpful that way because you can actually do the math in your head with those small values, right? So that works. Now the thing is if we're going to use this, we need to make sure that we kind of clear this every time we use it, right? Because this feedback isn't going to work if we don't use it correctly, right? So in our unit test code, so we have this unit test code, we're going to need to set this to 0. And then we need to, the first test is just, we're going to, see in our notes, we're going to run, let's call this like i32 num pixels pushed, npp, num pixels pushed, and then i32 number of blocks pushed. Or let's num blocks pushed. Okay. And num pixels. Okay. Let's do np like that. We're gonna keep this kind of shorthand. And actually we don't need, oh, we'll get to that. So Tausync run. Okay. And then the number of pixels, the number of blocks pushed is going to be equal to this. And for the number of pixels pushed, it's actually going to be assigned to this. So we could just use a define for that. So define, and instead of lowercase, the number of pixels pushed will be all capitals because it's a macro. And the reason for that is because this is, you can just comment that out, you know, but we can keep it for reference. Or actually, let's not do that. Let's keep it like that. Right. So we just want to be able to see that pattern here. We want this like shorthand we can use for some of this. And then right here, instead of doing this, we'll just do like a NP. Okay. So we got to reset this state. Okay. Equals 0. Okay, and then our first test is really simple, right? It's just like if NP is not equal to 0 or NB is not equal to 0, then we've failed our most basic test. So error, it's Tausync smoke test fail. So we'll just do smoke test fail. We just need some type of unique string. It doesn't need to be anything, doesn't need to give a detailed description of what went wrong. We just need some type of unique string here. So STF smoke test failed, STF smoke test failed. What else do we need to do here? I mean, that's the basic smoke test. We're going to need to define all of our macros here. And for our unit tests, it would be nice to have an error function for unit tests specifically. So Tausync unit test fail will actually make a function for failing unit tests. And down here we have 2 more macros. So before we go any further, let's duplicate this line twice and paste our macros down here to undefine all of them. And then up here, we're going to add a unit test fail function. So just a very simple kind of boilerplatey kind of thing. 2020 Tausync and unit test fail. And then it's going to take a const char pointer, and it's going to be called message error or error message. I don't remember. Oh, message error. So the general category of it is a message, and the specific category is that is an error message. And within here, we can do the details of what needs to happen. All we need to do is print off that error message, know where it came from, and then crash the entire system, right? So this is a fail fast assertion. Now we can just use assert, assert whatever the hell, but then that just gives us a line number and whatnot, and I actually want these asserts to not turn off if we are in release mode, so we're not going to use asserts here. So just a simple printf, and then we want to know where it came from, right? And then the actual message, so %s for the message string, a new line, and that is literally all we need. And also, we kind of screwed that up, so I don't know what the hell we did there, but there we go. And then we need the message, the error message, so msg_err, and we were almost out of space there, but we got just enough. Then we're going to flush the std out, make sure, absolutely sure we see this before we exit. And we'll exit with, it really needs to be a code between 0 and 255. I don't know what number that should be, it doesn't really matter. Let's try 38, try to have some type of number. Maybe I should have done that sequentially. It's not something I really keep track of, it's nothing that really matters usually. But we'll give it some type of number, just to be official here. So now we have this unit test fail function, which is just going to be assigned to error. Write ERR, because we really don't care about the exact namespace when we're working here, and also we just want to save some column space for the message, right? So if it's very long like this, right, if we have this very longness here, we end up going past our column space. We don't want to go past this 64 column limit, and I also don't want to spend too much time manually wrapping code. So what is the length? Oh yeah, so this is pure C. C99/C11, so hold on. So let me give you a history of what happened. Once upon a time, I made a game. Here, let's actually look at it, because Flash is actually gonna be unusable in Chrome pretty soon. So let's just show you that and make this kind of interesting. www.newgrounds.com. Newgrounds.com. And, oh, actually, it's right here. So once upon a time, 8 years ago, I made this game in Flash. I made it in ActionScript 3.0. And Flash is dead now, right? So it took me almost 8 years to figure out what language to use next. I've done a lot of different prototypes in a lot of different languages, and I decided on pure C because I don't want to ever get burned by, I spent years on this code base, and now this language is shit now. This language is antiquated, nobody uses it anymore, right? I don't want to have that problem. So I chose something that it takes a lot of time to code in it, but it's going to be around for a long time. So I can take my sweet time getting the code right, and even if this takes me 15 years to do, I don't have to worry about the language going out of date. Okay, so because I really got burned with this. I put 2 years into this code base, and now it's worthless. So let's go play the game. This is just like a little loading screen that's kind of fun to play with. I won't describe all of it. We're just going to give like a really quick demo of this. We're not going to go into the details that I usually go into for this, because we're trying to coding. This is more of a coding day right now. So got to suspend my hotkeys here. So beta 12. So it's like Bomberman side-scroller. This is the engine. We're writing an engine for this game. So it's like Bomberman, except you have destructible geometry. So you got these little pillars. The pillars, when they fall and they hit the lights kind of shatter, except we don't have an animation for that, so that kind of sucks. When pillars hit bombs, the bombs explode. Pillars need some type of geometry underneath them. If the geometry is not underneath them, then they start to fall. The bombs, there's 4 ways: vertical bombs, horizontal bombs, and instant kill bombs. And they're used to create these chain reactions that destroy parts of the level, right? These pistons here have sparks, and when the sparks hit bombs, the bombs explode. So if I hit this piston up here, bam, it makes a spark, it explodes the bombs, right? Now, when parts of the level explode, sometimes parts of the level will leave scaffolding behind. Oh, also, I programmed that lighting engine. Isn't that cool? So, certain types of tiles will allow the bombs fire through them, but will not destroy the tiles. So, you see these vent tiles, the blue tiles underneath here? If I hit this... this is a called a flame piston, and it emits a spark when I'm on it. It ignites the bomb. So let's reset that for a second. So it emits a spark, it hits this bomb, it chain reacts, the flames go through the vent tiles and explode this wall so I can get to the end of the level, right? Bam! Okay? So there's a lot of stuff in here, but we don't want to spend too much time going through this, so I'm going to go through this kind of fast. These are just the intro levels to get you acquainted. There's a lot of different level sets in this, but this is not the purpose of the current stream. But you said, what language am I doing this in? So I wanted to talk about why the hell am I using C, right? C, why not C++? I'm not using C++ because I want the code as simple as possible, because I am already good at over-engineering stuff. Like, if you look at this, there is a whole bunch of crazy stuff going on, and we don't want to make really complicated C++ code, so therefore, we're going to write it in plain C, just because I'm confident I can write these systems in C. So we're going to make a rendering engine for this, but we're going to mix together some other tech stacks. So you've kind of seen what this is. There's other levels. I think I'm going to press next so you can kind of get a glance at some of the other levels. But I don't want to get into a whole tutorial of this game, because we're just writing the engine for stuff, and there's a lot of different features and things we can go over, a lot of different level sets. Each difficulty is actually a different set of levels, so instead of changing the amount of health you have, every single time it's a one-hit kill with the bombs, but different level designs are organized for different styles of play and different levels of difficulty. So there is a lot of stuff here. I don't want to go over it all, but I will go over my tech demos. So let's just look at my my demos for a second. Let me put on my hotkeys again here. So if we go to JMIM demos right now, so this is a pixel art game, right? I'm going to take this pixel art and I want to make an engine that can do this game, but can also do some more things. So, right, we got this basic mechanics of this explodey engine where things fall apart and whatnot. We want to mix it with one of these technologies, where we have like a tile map with like awesome kind of like auto-tiling shader tiles, right? So we want to, just because we're doing 2D, right? Just because we're doing a 2D engine does not mean we don't want to make it look super fucking fancy. We want it super fucking fancy, nice and shiny. People kind of think that to get better graphics, you have to go from 2D to 3D. I think that is a lie. I think 2D and 3D graphics are like different branches of an evolutionary tree. Of technology. So 2D graphics can keep on evolving alongside three-dimensional graphics. So you kind of see what this is all about. We can set these different tile values and they nicely auto-tile together. But if we wanted to zoom in here and say like 128 and 128 and make these tiles bigger, you can see that we have not lost any resolution. But we do lose resolution in the Atomic Alice game because it is in pixel art. So we want to take this technology, we want to merge it with this technology, and then we want to merge it with this technology, which is tile maps with different layers and different rendering settings. So you'll see we have these 3 different images, and these 3 different images are the exact same tile map, but different rendering settings have been applied to them. This one is Starry Night, this one is Sunset, and this one is Foggy Morning. So we want to take this technology, we want to take this technology, we want to take this technology, we want to merge them all together into a single code base. We want to take this technology here, which is an auto tile set editor. We want to take that technology, we want to merge all this shit together. All this tech you're seeing in my little demo reel here, we want to take all of it and we want to merge that shit together in a nice, awesome code base that has a renderer like you've never seen before. So when people are using this engine is going to have something that Unreal Engine cannot offer. It's going to have something that Unity cannot offer. It's going to have a very unique style. It's going to be tailored to very specific types of games. But if you want to make this type of game with this type of style, with this type of visual, and you want it to run performant, this is the engine for you. Okay? I think I'm going to do something like some type of royalty thing where, you know, you have to have made like at least $100,000 on your game before I want any royalties from you. I don't know exactly what the royalties would be. I'll figure that out as I kind of go. Yeah, this is kind of like what I'm working on. I'll have to assemble like a little technical demo of this pitch for later, after Flash goes out of style, and after the end of this month, right? I'm fucked. So you see what I'm doing here. Let's go to... okay, so we got unit test fail right here. We got the error macro here. So let's go in here. So we got this little... let's put this back to ERR like that. Okay. Okay, we got a little unit test. Let's also do a log here. So we're going to log, and we're going to say that... this is the begin. So we're going to say that begin here, or we could say enter and exit. I'll say begin just to be terse. And then over here, we're going to say log, and we're going to say end. And then we want to make sure that, do we have a logging macro? So we have a logging macro, that's good. The logging macro has optional information that can be passed along with it. So we're going to pass it a null pointer. That's what that 0 is. I know that's kind of hackish to just say 0. We do have enough room where I could put a null pointer, a proper null pointer like that. We could say void cast to 0. That is actually what null is. I like to be as explicit as possible when I can. But if we didn't have enough room and we were going to go over this column, then we would just call this a 0 rather than this explicit cast here. So let's give this code a run. I'm sure I've made some syntax errors because we've been kind of like all over the place. Let's just give it a run. We're going to have to clean up some syntax errors, but then we'll be in the depth of kind of like writing out these unit tests. So, 428 in Tausync.f. So let's go look at that. So 428, it looks like unit test fail. So I forgot my semicolon here. Well, that's what I did. So a lot of times when you see me kind of looking, like compiling and looking for the problems, a lot of the times I'm just going to look at the line number. I'll look at this, I'll glance at this, right, and where this arrow is, and then I'll glance the line number, 438 in the file where it's coming from, and I won't even read this. I usually won't even read what the error is. Unknown type name I32, because, like, you know, 90% of the time, if I know what line the error is on, 438, That's all I need to know. I'll just look at line 438, and I'll look at it more carefully, and that's usually all I need to know for what went wrong. And that is easier for me than trying to like read these long specific error messages that are sometimes not even what's actually wrong. A lot of times the error message says one thing, but it's something else. So I just like to look at the line that's wrong and be like, okay, what's wrong here, right? And I'll make my own decision, right? So int32, it was pointing at this. I'm going to guess we don't have an int32 macro, and we are correct. So we got to define i32, right? We got to define a signed integer version, right? So we got our uint32 and our int32, and then down here where we undefine our macros, we'll do an undef for i32, and then we're good enough to run one more time and see what else is going on here. So I see LA something something. So we have some code that we kind of cut and pasted when we were putting this together. So it is LA, and it is on line 473. So I already know what that means. So 473 is right here. LA, and we even see that says Taudirt's tree, right? So in Taudirt, if we take a look at Taudirt and we look at the data, right? Because this is a reference to a piece of data. So in Taudirt, which is texture as uniform dirty, it's the dirty flags, Taudirt.d right here. Let's open that up. And we see LA in a whole bunch of places. So LA is a alias for this big struct name here, which is way too much to type all the time, and it clutters up our code, hence why we use LA sometimes to stand for it. So I absolutely know that's what this is, and we can even look to see where it's referenced. So we're like mallocking a backup version. Yeah, that's exactly what this is. And if we look at the backup, right, let's see where we're storing it. So we're storing it right here. We see a mem copy to the root. So this is also the LA thing. So I have way too many synonyms for thing, but this is also LA, this thing right here. So with that, where do we want to put those macros? Do we want to put the macros at this level, or do we want to put them at the top level? Well, we're already kind of like, we're already pretty macro heavy here. I think I'm just going to put it up here. It looks like that's kind of where I put it in the other one. That's why we kind of lost it when we cut and pasted the code. So we're going to take LA, and LA is just going to be this struct. And is it accompanied by the struct keyword? So let's look at this. Yes, it is accompanied by the struct keyword. So we need to say struct right there. So I'm never going to do type def structs. I'm always going to explicitly use the struct keyword, but sometimes that will be hidden with macros. You know, that's just how I do things. Okay, so we got that in there. Is there anything else we're missing? We're not even going to think about it. We're just going to give it a run, and eventually we'll have solved all of the problems, right? I am running out of UO8 and 475, so 475 right here. So let's add the macro for an 8-bit integer. So the 32s, we should probably keep the 32s next to each other. So we'll put the define for an 8-bit up here. So this is an 8-bit integer define. And right, this is a note for the GCC compiler suite. This is going to be declared in stdint.h, in case that wasn't obvious. And now that we go down here, we're going to undefine this here as well. So now you might be looking at this and being like, wow, that's a whole ton of clutter, right? Well, I mean, we can't undef them all on the same line. So it's just a consequence of the way I like to do things. Now, the nice part about this is with this divider for this unit test section, we have this big kind of space for things to breathe, and that actually is kind of nice. But sometimes we might want like a little checksum. Like once we get a whole bunch of macros where we're like losing track of how many macros we have, we might want to do like a quick little checksum up here where we just kind of count how many of those undefs we have, right? Because the number of defines should match the number of undefines, right? And if we don't have that, then we need to more closely inspect what's going on here. Now, we're kind of like running out of room here, so we'll kind of like do a like yeah, we can do it like that, and then 2, 3, 4, 5, 6, 7, and 8, right? So we got 8 defines here, and if we look down here, how many do we have? We have 8, right? So we have a quick checksum to make sure the code is correct. So I believe Alan Turing kind of like proved that, you know, he didn't exactly say it this way, but my understanding of Alan Turing's halting problem is that no matter how many tests you write, you can never, without a doubt, prove that your code is correct. And because of that, having little kind of things like checksums, visual checksums, so that a human being can look at the code and kind of determine if it is correct, right? Like, we're kind of like a human compiler right now. We're like looking at this and making sure it matches. To have little things like that, I think is perfectly acceptable, because there's always going to be some uncertainty with is our code completely correct. So any type of measure that we can add to make sure that code is correct is good. Okay, so with that, we've added those macros, and we've done a little checksum here. We're going to give this another run, make sure that the code actually runs, right? Okay. Okay, so the code's running, but something is wrong here. Oh, hold on. That's weird. Something is wrong with my keyboard bindings. I've never had that problem before, so let's try to, oh, you know what? I might be... Yeah, something's wrong there. What does the console say? Is the console doing anything weird? Yeah, something is wrong with my... let's make sure that it's not... It could be my shortcut script. So let's look at this. Suspend hotkeys. But that's wrong. Something's wrong. Like, we've added some type of code that seems to be... You might be executing something that's, like, taking a long time. So maybe one of our flags is... not working properly, but let's, okay, so I think it's just my shortcut script is interfering with my keyboard listener, which kind of sucks, but it does that with, even Flash games. I have to disable my shortcut scripts, because the keyboard listener won't work correctly. That sucks. I don't know why. It's never done that before, though, so... I don't know why it would all of a sudden start now. And this is what I'm talking about, of having, like, weird behavior, where you're like, that's weird, what the hell is going on, right? So, what we could do is, right, we think that maybe we've done something odd, right? That's kind of weird. Like, I'm skeptical. I think that we've introduced maybe some type of weird behavior, right? That it doesn't quite seem correct. Like, something seems kind of strange, right? It's one of those things, you don't have a test for it, but something seems really fucking off. So what we can do is we have this library chain, right? So we could, say, compile only up to system 19 right now. And if we compile only up to system 19, we're going to exclude all this new code we wrote. And if we compile up to there, if the keyboard listener all of a sudden starts behaving properly, we're going to know that we introduced some type of weird behavior, right? So let's just try this out. Let's run it. Okay, let's look at that keyboard listener. Okay, so the keyboard listener is still doing weird things. I'm pretty confident that it is just, it's just my keyboard, it's just my shortcut script that's kind of doing something weird. But as another sanity check, we could go a little bit lower. We could go all the way to the window code, right? Actually, no, let's go all the way to the fragment shader code, right? Because this is what switches the different fragment shaders. So 16 right here. Let's go to there and just see what happens, right? So we're eliminating more code and just see if what that looks like. I might have some changes that I need to fix, so it might not compile down to here. I might have some things I need to fix. Nope, still compiles down to here. Let's take a look at what we got. So yeah, it's still being weird. Let me suspend my hotkeys here. Okay. So this is correct. Now you'll notice that this is blacked out, right? It's because the Paint 5D system has not been introduced yet, and so there's a certain data allocations that don't exist at this point within the compilation, right? So the idea is we're going to layer on our systems in a very linear order, and we always have a working project. But now, if we cut out a lot of code, of course, we're not going to have the same executable as before. But the idea is to always have a running executable no matter what libraries we compile up to. So that looks good to me. I'm looking at that. That looks fine. We haven't accidentally introduced any strange behaviors as far as I'm concerned. So we're going to go put this back at 24 so we can compile everything. And then we're just going to give this one more run. And we're going to see what this looks like. Okay, so take a look at that. And yeah, so that looks good to me. And let's take a look at these logs here. So we should somewhere see, we got like a lot of logging from systems that we really don't want to look at right now. So what we're going to do is, cancel. We're going to go Control-C, close that. Let's unclutter the console for a second. So let's go into the silence subsystem. So in our library, we're going to go into silence, silence.d. We're going to open that up. And we're going to see what systems are we currently silencing. And I noticed that these say to do, so that is worrying me a little bit. So let's look at Tau Depot. Probably has a log message. Let's look at Tau Depot for a second. So Tau Depot. We want to silence these systems, so let's look at the logging for this. Do we have logging? Do we not implement it correctly? Let's look for AAC 2020 silence. Right? If we're actually using it, we're going to see that flag. So we see info any logging message. Do we have any other logging messages that may need to be silenced? No, this is like the only one. So this to do, we can get rid of that. The code is actually added. Let's X that off because yes, we have added that. Tau type, we haven't even implemented tau type yet, so we can keep a to do there. Tausync. Let's go into Tausync. We don't actually need to shut this off, but we can look for the word silence and see if we've implemented that correctly. And we can see that for our logging messages here, we have the option of turning them off as well because they have a guard around them, so that is good. So now that we know that that is like that, we can get rid of this little to-do message here, and we can go into our little lookup table of things that are on and off, and we are going to shut off the logging for systems that we've already kind of looked at. So pixload, we're going to turn off pixload. Pixload is fine. Do we want to turn off key bindings? Yeah, let's just turn off like everything. Let's really focus in on what we want to look at. So we've already looked at this. We've done the unit test for this. We've done the testing code for this. Let's turn that off. Paint 5D is kind of the system that we're trying to finish, but it relies heavily on these Tau systems. So we're going to keep this on because we're kind of working towards Paint 5D, and we're going to keep this on because this is what we're currently debugging, or this is the current thing we're writing tests for. We're going to keep this on because we haven't written the code for this yet. So we're going to keep the logging for all of those systems on. And we're going to rerun this, and we're going to check the logs, and we should see kind of a a little less cluttered of a console. Yeah, look, that's much less cluttered. And let's read what we see. So we see entering Tausync unit test. So this looks like this is the public unit test code. And this is exiting the public unit test code. And then we see this lowercase. This is entering and exiting the private unit test code. So notice that the public has a more verbose name here. It's entering and exiting, but in my private version, I'm just going to say begin and end, B-E-G and E-N-D. But that's enough for me to see that, okay, we've ran that basic unit test code, and we're not in any trouble right now, so that's good. So we need to write some more test code, right? We need to... we've done a little kind of smoke test. Let's close some of these. Taudirt.f, we can close that. And we can go back to the unit test code, and we have, like, we're ready to write some unit test code, some more unit test code. We've kind of stubbed in a little smoke test. Let's give ourselves some space to breathe here, and just start kind of like writing some code. So let's say that let's organize this a bit. So let's organize this as variable variable declarations. So our function scope variable declarations will be right here. And we'll have to change some of the indentation here. But we're just going to make a nice little section, kind of get this organized. Okay. And then right here, we gotta, like, indent that a little bit, because we kind of, like, we don't want to go off the column space. We don't want any mystery code. Like, when you're looking at this code in the stream, I want you to see everything that's there, right? Everything I'm looking at, you should be able to see, and there shouldn't be any type of mystery code, so you don't know what's going on, because some code is, like, going off the screen. We never want that, so we want to keep to these nice column limits where the code is nice and large on the screen, and you can read everything that's there. So we got these variable declarations. This here, however, is not a variable declaration. This is a initial basic smoke test. So this is smoke test. We'll just call it smoke test, right? It's a basic test, right? It's such a simple test where it's dead simple, right? It's a dead simple test, and if it fails, it means you have a serious problem. So we see this Tausync run. We see that, so this actually goes in the smoke test, right? So this is not a variable declaration. This is just, this is the setup section. So if we want to think of this is a setup test. You want to think of it in a test-driven development kind of way of thinking. This is setting it up, and you know, right? We have enough room where we can kind of indent a little bit more if we wanted to organize that. I'm usually not going to get this verbose, but we have enough room where we can kind of like make the sections here, the sections here. I write the sections like this so you can easily see where a section of code begins and where a section of code ends, because I like things to be as explicit as possible. So what's the next thing we're going to do? How are we going to test this? What's the next thing we can kind of do to really test this out? So let's close some stuff. Let's close this. Let's close that. It's nice to have this little diagram here. So which diagram do we want? Do we want this diagram or do you want this diagram? I'm going to say we want the smaller diagram because I think it's easier to have everything up here for the viewers to see the data structure that we're kind of looking at. This thing we don't need. It is nice to keep track of. No, we're good there. We can get rid of this. Yeah, that's fine. Number of dirty pixels pushed. Tausync. Yeah, that's fine. So in here, this is just our like notes for what we're doing. All right, that's good. So the next thing we want to do is this is kind of a integration test because Tausync really needs to correctly test pushing things up. We need to pretend we're like putting data on the canvas, and we can even query what that data is as well. So we're going to use these putters and these getters, and I think the first thing we want to do is we want to do the most horribly inefficient thing, and we're just going to try to dirty one pixel within every single 32 by 32 block, and make sure that the checksums for how many dirty blocks of pixels were pushed kind of like matches correctly, right? So the way we can do that is we can do like a nested loop. So dirty 1 pixel of each block. So this is our test. This is what we're going to do. We're going to dirty 1 pixel of each block. That's what we're going to do. So let's kind of do this like that. Okay. So, how are we going to loop through this data structure? Well, we see we got T, S, and V, and that stands for tau, sub, and var. They're the different subcells here. So we can see in the diagram T, S, and V here. So I think T, S, and V is terse enough for us. So let's just say that we could do the, yeah, let's just do int32 and T equals 0. T, S, and V. S and V, and if we want to know what those are, we can kind of like do this. We can do an at and a tau, at tau, and we can also, if we want to know what this block is, this diagram is also described in tau depot.d. And we see this is diagram tau cell, so we can also take this little annotation here, and now we have kind of like diagrams to grab onto. Like if we ever want to know what the fuck t is, we can look at these annotations, and it'll get us back to the diagrams that we're using, right? And that's going to be very helpful, right? And we're going to actually inline that comment, right? So the reason we're using these parentheses is we're going to inline the comment into the assignment, so that it's kind of like embedded in there. It's really hard to get it out, and that is very intentional, right? Now this is tau, this is sub, and this is var, and then tau and sub and var. And if it's not obvious already, dia is for diagram, right? And if you want to know, like, when we wrote this code, we can do a video integer ID. And what video are we on? We're on 0053. We can check in the bottom right hand of the screen of the stream. We see the day is Monday, and the integer ID of the video is 53. So we're going to write that so you can look at the archive and see this, right? So when you're looking at the source code, you can find it. So the timestamp is 4 hours, 5 minutes, and 42 seconds. Okay, so if we ever want to know what this has to do with, we can look at that commentary, right? So we could do this, and we don't really have anything here. I guess what we could do, if we want to make it kind of uniform, let's describe what this is right here. So this right here is, well, number of pixels pushed and number of blocks pushed. So when we're updating that memory on the GPU, when we're syncing the memory with the GPU, this is the total number of pixels that's pushed up to the GPU. This is the total number of 32 by 32 blocks of pixels that is pushed to the GPU. So we'll describe that. I just want some uniform formatting, so that's why I'm going to add this tag as well right here, so that we can make the formatting a little bit more consistent. So we mentioned this at 4 hours, 6 minutes, and 36 seconds. Right? So if you're looking through this source code and you're like, what the fuck is this? What the fuck is this? And there's not enough explanation in these comments, you can hear where I was talking about them, and maybe it'll help, right? With that, we're ready to dirty one block of each of them, right? So we're going to do like a triply nested loop to loop through these cells, loop through these cells, and loop through these cells. So we're going to do a for loop, and we're going to do for t equals 0, t is less than or equal to t is less than or equal to 16 minus 1, because there's 4 by 4 cells. 4 times 4 is 16. The first index is 0, thus it needs to be 16 minus 1 to account because we're starting to count from 1, right? It's 0 indexed, right? And so we're going to duplicate this line 3 times, and then we're going to close it off 3 times here. There is no need to add extra indentation. All of these things are highly related, and it actually is going to help us if we can see the T, S, and V aligned with each other. Now, the last sector, or the last overlay of our quad tree-like structure is not a 4 by 4. It is a 32 by 32. So that means that this loop is incorrect. We need to change this to 256, right? And if we want to make a note of why it's 256, we can say that, 4 by 4 equals 16. Right, we can make a note of what the hell are those magic numbers, right? So if we want to know what those magic numbers are, we have a little bit of space. We can take advantage of that. 4 times 4 is 16, and, 256, that's a 16 by 16. We're a little bit out of room here. 16 by... But we'll get to this, so 256. So we're kind of crammed in there, but it's better to be a little bit crammed than to... than to go over that column limit. So, yeah, just have a little note there to know why, what this means, right? So let's do a little comment about where we are, what it all means. So let me indent that correctly. Looks like the indentation was off by 1 here. So the video integer ID is 0053, and the time right now is 4 hours, 9 minutes, and 12 seconds. So let's describe what's going on here. We're going to traverse every single 32 by 32 cell, right? And the T is for traversing these cells here. The S is for traversing each one of these cells, and the V is for, this V right here is for traversing each one of these cells in our quad tree-like structure that overlays over the 512 by 512 pixel allocation that is used to represent uniforms within texture memory. Okay, so a dirty pixel of each block. N by n loop to go over to hit every 32 by 32 block, right? That's what we're doing here. Okay, so now that we're in here, we need to just mark a single pixel as dirty. And let's not be fancy about this, right? Let's keep it dead simple as to what we're actually going to dirty here. So we see we have this like put command, right? So let's take this put command right here, and let's just say that for these variables right here, I don't know if I want to call it that. I actually think I want to call it variable 1, or actually no, it's these data points all represent a single variable. So let's call it P1, P2, and or actually, how about P? Actually, let's not worry too much about it. Yeah, let's just call it that for now. And let's go over here, and when we're declaring stuff, let's so let's go video integer ID 0053. I'll show you what that means for a second. Time is 4 hours, 11 minutes, and 21 seconds. Okay, so what is P1, P2, etc.? So it's going to be a U32 first of all, because we're storing these values in an integer texture that uses RGBA, 4-byte color. 4 bytes being 32 bits. And P1, this is part 1 of 4 pixel variable, right? So we can use up to 4 pixels for a single variable value. We don't have to use all of it all of the time, but that's kind of how it's structured. So P1, P2, and P3, P4. Now, if we want to see where that is in the diagrams, this diagram isn't the best for that. Let's look in Tau Depot's data. So right here in this 32 by 32 cluster of pixels, each time we lay data that represents a uniform or a variable within the texture memory, it's going to be a cluster of 2 by 2 pixels, right? So 2 by 2, 2 times 2 is 4, right? We can see these 4 pixels right here. So this is P1, P2, P3, and P4. So what we could do is we could actually do at P1, at P2, at P3, and at P4, right? At P4, and that's kind of a vague thing, so that might change, but then we can make a little note right here. Part 1 of pixel var, let's try to shorten that, because then we can do like we can do that, at P1, at P2, at P3, at P4, etc., right? And now we have like a diagram to grab onto. Like if we want to know like what the hell are these variables, what do they actually represent, we can see this and we can kind of search for it in the code base and see it here. And if we want to make sure that we can find it, we can do like a diavar cell, right? So we could say C diavar cell, and then we can say in, and then we can say tau depot dot d dot underscore, right? So that way we have something to grab onto, right? Because it's very hard to visualize code, right? Code is very fucking hard to visualize. So we're gonna ASCII diagram the hell out of this, right? So P1, P2, P3, P4 corresponds to the 4 pixels that represents a single variable that is packed onto texture memory, right? So we're going to use that texture memory as a cluster of 512 by 512 uniforms. That way we can just have as many variables as we need in terms of the CPU to GPU communication, right? Okay, so now that we have this allocation here, there is one more thing I need to do because we are documenting the hell out of what we do. So we're going to take over here, and we're going to just say at P1, and at P2, and at P3, and at P4, right? And it's kind of vague, so maybe this will actually mean something different in the future. But for now, let's just take that and create some section dividers in our documentation. This is like a dump of where I put like all my documentation, or it's a linear place, right? Newest comments always go at the top, and that's so we know what is done in what order, right? So if these comments ever become out of date, it's basically whatever is closest to the top of the file is the comment that will be taken as correct, right? Whatever is the newest comment is whatever is correct. And this file is not meant to be read from cover to cover, right? Because you wouldn't, first of all, you wouldn't be able to read it this way. You would have to like read it backwards. But it serves as a documentation as well as a history of what the hell kind of like happened while we were coding. So at P1, it means pixel number 1 of pixel 1 of 4 for packing that rep of tau variable, right? That's kind of what it means. Okay, and so same thing, P1, P2, P, right? It's very redundant here, so we can kind of like cut and paste a little bit. So pixel number 1, 2, 3, and 4. And then we can explain what's going on here. So we pack each variable that we want to store on the GPU is packed into a uint 32 RGBA texture. Each variable gets a cluster of 4 pixels, meaning we can store up to a 128-bit unsigned integer if needed. Also, we decided on 4 pixels because we commonly need to encode rectangles that have exactly 4 32-bit unsigned integers within their defining them, maybe? Defining. Okay, so let's make a little marker of what time it is. So we're going to say that at vid.iid, and I think I'm forgetting at vid.iid a lot, so, but at vid.iid, and then the time is 4 hours, 17 minutes, and 1 second, or 1 second, I don't know, 1 second, doesn't really matter too much. So let's describe what's going on here. So, right, P1, P2, P3, P4, it's 4 pixels that represent some type of variable that is going to be encoded into texture memory. So what we're trying to do is we're trying to not use uniforms. We do have some very basic uniforms, as in like proper GL, SL uniform variables, but for any other variables besides iTime, iResolution, iMouse, besides those very basic uniform variables, any other type of variable that needs to get into the shader is going to be packed onto a texture. And that's what the whole tau system is about. It's tau for texture as uniform. So now that we have that, we're ready to kind of get back to what we were doing. And you notice that, yeah, I am documenting the hell out of this. And it may be kind of annoying to watch, I guess, but I think that if you end up using my engine, you're going to thank me for how meticulous I am in documenting this. Or at least I hope you will help. I hope that when you look at this code base, you will thank me for how detailed I've gone into documenting this, right? Because when you're looking through this code base, if you don't know what the hell this means, you can literally look at the 53rd video I made and look at 4 hours, 11 minutes, and 21 seconds, and you'll know exactly what was going on at that point in time that I was coding that, right? So I think that's going to be a helpful way, right? Because nobody has time to look through all of these videos, right? Nobody really has time to even watch my entire stream. So I want to use this stream as a supplementary documentation to the code base, right? And I don't want you to have to watch the entire stream or the entire backup videos of this, right? I just want you to be like reading the code, being like, what the fuck is this? Oh, it's this video and this time. Let's go look that up on their YouTube, right? Okay, so now that we've kind of like documented that, what are we doing here? So we got the variables that we're going to set, and we don't really care too much about what those values are. Hold on, let's do this. There we go. We don't really care too much about what these variables are for this. This is just a basic smoke test, but we probably should not set zeros. So let's just say like, you know, P1 equals 1. We could actually do like 1, 2, 3, 4, even though, you know, maybe that's a bad idea, because now we're thinking that you know, that implies something that I don't know, maybe it makes the implication that confuses people. I don't know, maybe it's a bad idea. But yeah, we'll just say 1, 2, 3, 4. So in this certain sector, we're going to set these values on the memory, right? But we're not going to use these hard-coded values. We're going to use T, S, and V, but these are just different aliases for what those names are. So we're going to delete this, and we're just going to say T, S, and V. So we'll take T, S, and V, and we're just going to paste it right here. And this is the first tree. This is the first subdivision level. This is the second subdivision level. And I probably should explain what's going on here, because this might be a little bit confusing. Okay, so first of all, what do we mean subdivision level, T, S, and V? Well, T is locating one of these cells, and one of these cells is going to be divided into 4x4 cells. One of these cells is going to be divided into 32x32. To identify one of these cells, we're going to use a one-dimensional index rather than a two-dimensional value. So this cell is number 6, this cell is number 0, one of these cells is like 5, and this cell right here is like 0. So if we want to find you know, a certain cell, we just can say T equals 5, S equals 1, and V equals 0, right? And we can locate that exact cell. So why are we using an index rather than an X and Y? The reason why we're using an index is eventually these values here, T, S, and V, will be enumerations. And so this variable will use a variable enumeration, and by using some type of enumeration, it's actually going to be a define, not a proper enumeration. But then we can say like paint 5D viewport rectangle, right? So we're setting the paint 5D viewport rectangle, right? And here's the data for that rectangle, and we're storing it into the texture memory. Then in the shader code, we can inject the shader code with this exact same define that resolves to the exact same index, so that on the CPU side, when we're pushing up, the value to the GPU. Within the GPU code, we can inject the GPU code with the exact same define so that the getter within the GPU code can effectively extract the exact same piece of data from that texture memory that we were manipulating on the CPU side, right? We need to make sure that the CPU and GPU code can coordinate. If they can't coordinate, then the whole point of this is going to be completely pointless. So some of the convolutedness of how I am doing this relates directly to the easiest way to get the GPU and CPU data to sync up with each other, okay? So this put looks good to me, right? So it's kind of weird because we're testing Tausync, but we're calling Tau put, and so we just need to sync cannot really be tested without creating some dirty data to sync with the GPU. And vid IID 453. Okay, time. And this is 4 hours, 24 minutes, and 1 second. Sure. And that's, let's just remove that 0 so we can kind of indent that a little bit better. Okay, so, right, we really can't test the GPU, CPU syncing of dirty data unless we actually set some dirty data, right? So that's why we're going to loop through every single 32 by 32 cell, and we're going to set one piece of data onto that cell using the actual utility, using the actual public utility. We're not going to mock up anything. We're going to use the actual system itself, right? Because we backed up the data. We're going to muck around with it, run our tests, and then we're going to restore the data we backed up. Okay, so that looks good to me. So the next thing we want to do is we want to test, did this actually work? In order to test that it actually worked, well, we actually have to run the sync function. So we see that right here, we need to reset these flags, right? Before we dirty anything up, we need to reset our variables that kind of query what the hell happened, right? So we're going to reset this, and NB actually needs to be set back to 0. And right after we do this loop and dirty up our data, we're going to clean up our data. Clean up our data. And we need some way to make sure that we don't actually push the texture memory, right? Because the texture memory was kind of like stubbed in there. So I think we should have some type of, we're going to do a thing called dry. We're going to give it a variable called dry. And then over here, we're going to make another class variable. It's going to be called AAC 2020 Tausync dry run for debug for unit test. Okay, we're going to call it dry run for unit tests. And we will, we'll assign that, we'll define that somewhere else after we do this. We'll call it dry run for unit tests, and then down here we also have to undefine that. So I know I'm all over the place, I'm full of caffeine, and people are like, what the fuck is he doing? And I apologize for that. Today is the one day that I actually drink caffeine. I don't drink caffeine on any other day, and it guarantees that I'm productive on Monday, and then all other days it's kind of like up in the air, right? So in Tausync, in the actual data file, so we have our notes file. We don't really have our data file open. Let's open up the data file for Tausync, and tausync.d for data. And we need another kind of thing here. So it is a dry run for unit tests. We could make this a define if we wanted to. I'm just going to say that it's a const i32, or a const, actually let's make it a const u08. We don't need to take up that much room, and we'll set it to, it really doesn't matter what it is. We could call it like I don't know, it doesn't really matter. let's just call it 3330, or actually, let's give it a, it can't be over 255. Let's use a hex value, I guess. I don't know, 0x77, right? Doesn't matter, right? And const U08, we're gonna call this, I don't know what the difference between dry and, I guess it's, what is the opposite of a dry run? I mean, wet run kind of sounds really fucked up. So let's just Google that. What is the opposite of a dry run? I don't even know if this is going to get the thing because, right, this is kind of like jargon. Antonyms for dry run, performance cold turkey. Yeah, this is stupid. We could call it wet run, which is kind of like, what the fuck does that mean? Yeah, let's just call it wet run for production, right? And we'll say 0x, I don't know, 99? Sure, why not, you know? Sure, I don't know. It doesn't really matter. And now that we have this, right, we're going to look at the Tausync code and make sure that it's actually going to implement that. So in here in our test code, we're saying dry, and let's go look at the syncing code, and we see that it takes a void right now. So we got to change the signature and say that it's going to take a U08, and we might want to call it like, let's call it dry or wet, or wet, right? Or maybe we want to call it or. Now that's a weird-ass name, right? Because it's or with two R's. But you'll notice that when I'm coding, I have a very rigid way of coding where all of my variables seem to be clusters of 3 characters or clusters of 7 characters. That is intentional. And we'll just make a note that, you know, this variable right here can be, you know, dry is going to be this thing, and then wet is going to be this thing, right? And dry and wet, yeah, that's kind of a weird name, but whatever, you know? So we can make a note of what the actual parameters should be. And we can make a note right here at the video ID. So at vid integer ID, we are on video 53. So vid 53, and the time is 0 to, yeah, oh, wrong time, sorry. The time stamp for this video is 4 hours, 31 minutes, and 38 seconds, right? So now that we have that, we can make a little bit more note on what this is. Maybe we want to say that, you know, I mean, actually those enumerations are pretty descriptive, but we'll say that dry will... dry, I don't know, dry will not actually push anything to the GPU, while wet will push the pixels to the GPU. Okay. So we are kind of mocking stuff, right? We are kind of have this slight difference between the test code and the production code. The reason is we don't really... I'm not really going to make any mechanisms for getting the data off of the GPU. It's going to be a one-way thing, right? We're going to have very strict record keeping, and we're just going to track what we pushed to the GPU and just hope that everything's synced up, right? And if we screw that up, then we're in some serious trouble. But as long as we make a strict record of what was pushed up to the GPU and keep that record on the CPU side, we don't actually need to push the actual pixels to the GPU to make sure that our tests are running correctly, right? So now that we have this like dry or wet, let's actually put a define here for that as well. So let's just go define and wet, and then we have a define for dry. And did we do it in that order? Actually, we did dry and then wet. So define dry, define wet, and we're gonna take both of these guys right here, and we're gonna paste them over here. Because, you know, it's a real pain in the ass this makes the code very verbose, right? So we want to make sure that we don't make the code really visually cluttered by huge tokens. I just think that makes it a lot harder to juggle the code in my brain. So we're going to make sure we have sensible defines that correctly abbreviate this, right? So we got the word dry in here. We got the word wet in here. I think that's good enough for me to where we can see dry or wet here as the parameter to this function. And then we got to make sure that we also undefine it, right? So all the way at the bottom here, we have this section where we're undefining things. So we're going to like make some undefs here, and we're going to undef dry and then undef wet because it's the order we define them in. And it is going to be defines 12 and 13, right? We have a little visual checksum here so that we can kind of make sure that the code is correct, right? Because we got a lot of defines here, and we want to, once we get a lot of defines, we just want to make sure we're not losing track of them, right? And the defines also help to block out the sections of code, right? We're in the GPU sync section here, and here's all of our defines. Now, if we go GPU sync here, we go Control F, we're going to end up in the end of the GPU sync section, and you see the undefines, right? So the defines here kind of make sense because they help give like a very thick border to this section of code, right? So it is a weird style, but that is how I do it. So now that we have this dry or wet flag, let's implement it somewhere in here. So somewhere we have some type of like little to-do message here. So we have all this logic, blah, blah, blah. Here's the regions of the 32 by 32 subsection of the texture memory we're about to push. And then down here, we see rect032. We have a nice little diagram. And here's our actual rectangle. So let's highlight that really quick because we're getting hotter, we're getting warmer. Here we go. So here's the things we're doing for our push. Here's the actual push right here. This is just an accounting thing so that we can we're going to use these to query that things were done correctly. Pixel bounding rect is the PBR. That's fine. Good. So we're here. Let's take this here and let's just guard it, right? Let's just guard it with that enumeration that we created. So we're going to have to fix this up a little bit, but let's just say that define, or actually, you know, let's do if dry or wet, and we're going to say that if wet, actually, no, we're going to do it this way. So dry or wet is a const, right? So we're never going to be able to override that. So we're going to write it this way so that if we accidentally do this, we're not gonna have any problems on our hands, right? The compiler is going to catch us if we write it that way. So that's called the Yoda expression when you write things weird as hell so that the compiler catches some of your mistakes. So let's do a little, actually, let's call it dry. And the reason why we're going to do dry first, and then else, if dry or wet equals wet. The reason why we're going to do the dry first is because when we run the dry, we're not going to do anything, right? So when we have some type of branching structure, or we're going to do one thing or the other, we want the decision that takes the least amount of code to be first. The reason for that is because if this is a simple little one-liner here, and this ends up being like 1,000 lines of code or something ridiculous, if we did the 1,000 lines of code first and then the one-liner second, there is a very high potential that we're going to miss that last branch. That last branch, we're just going to not see it. So to avoid that kind of mistake, we're going to put whatever is the least amount of code as the first branch. So I'm very intentional the way I do things. So dry run is for unit tests. do nothing here. No texture push to GPU, right? Right, so we make a little note here, and then also, what we can do, we can keep on doing this, because I think it's going to be really helpful for anyone looking at this code base later. The video ID right here, the video integer ID is 0053. I can't type, sorry. The video ID is 53 on the bottom right-hand corner, and the time is, we're 4 hours, 39 minutes, and 6 seconds in. 39 minutes and 06 seconds, right? Alright, so if you want to find where this, what the hell we were thinking when we wrote this, now this kind of also kind of defeats the whole purpose of you know, having those two different statements, so we might want to clean this up a little bit more than this. But we got something kind of good here. Also, for the last else, we're gonna halt right here. So if we get to this case, we're gonna do expected dead code line, and we can also do like a I think I use a hash expected dead code line, or it might be at. You know what? We'll just do at expected dead code line. I don't know. Like I said, I use hashtags kind of loosely for what they mean, but let's do expected dead code line, right? Abbreviate it, and then let's just take the date. So 2020, 12/21, and it's 04:38 p.m. right now. So let's take that, and that's our error, right? And you'll be like, what the fuck is that error message? Like, that error message makes no sense. How is that helpful? And I'll tell you right now how it's helpful. It's a unique string that you can find in the code base when the code base crashes. We don't give a fuck about what that error message is. The only thing an error message should do is locate where things are going wrong. Nothing else matters. That Java philosophy of like making all those error subtypes, that C-sharp philosophy of doing the same damn thing, it's stupid as hell. We only need 2 categories of errors. We need fail fast kind of errors, and then we need like IO errors, or errors that say do not crash the program and recover gracefully, right? If we have an IO error because the user unplugged their thumb drive, we don't want to crash the program, right? Because we as the programmers did not control that. But if we as the programmers are controlling what is happening, and there's a mistake, and it's the programmer's fault, then we should crash right away, right? So there's only 2 categories of errors you need, as far as I am concerned. And I know I'm like very opinionated there, but I'm going to stay opinionated like that. So now that we have this, I'm thinking this looks like shit. So, I don't know, let's just call it push, I don't know, let's call it to, we can be fun about this. We can say to push or not to push. 32 by 32. Okay, so it's kind of silly, but let's just give it a nice little kind of section header, right? And then down here, we're gonna block it off the same way, right? And now that we've created this section, we have a problem where we're not indented correctly anymore. So you notice that a lot of my indentation is not just scope-based. I indent based on scope, but I also, when I make a comment, the comment also serves to create a level of indentation. So we can clean this up a bit. We want to make absolutely sure we're within that column limit. I'm thinking that this actually belongs do nothing. We're just going to say this is do nothing right here. And then over here is actually where we're going to put this kind of commentary block right here. Maybe like this, or maybe like this. I'm not sure. Let's just do that. We got enough room for it, so let's do that. And let's put some stars around it. Right, let's we can get a little designy here, have some fun. I was an art major, if you don't know. I did technical art for a little bit, so if you think that my code is a little bit too designy and artful, then I don't know, bingo, you're right. It is. Yeah, wet or dry. Now this is a short little block. This thing needs some cleanup, so this kind of sucks, where this is like really fucking long. So we're just gonna call this right here, right you know how I said I use the defines to kind of like further accentuate these sections in here? We're just going to call this push 32 by 32 chunk is what we're going to call it, which is kind of a big, or maybe we're not, because we're still kind of like, well, that sucks. Well, let's see what we can call it. Oh, no, we're still out of room. Oh, this fucking sucks. Well, fuck that. Okay, so you know what? We're gonna have to... I don't want to alter my formatting. So, you know, it's not... yeah, it kind of sucks, but you know what? Since we can't get it there locally, we're just gonna call... Yeah, this sucks, but this is the best we can do. This sucks, but push 32 by 32 chunk. We're just gonna call it push 32 by... actually, you know what? Fuck it. Yeah, let's just fuck it. Yeah, because even that is, like, too long. Oh, this fucking sucks. So this is 14, right? Yeah, this is 14. Oh, yeah, I fucking hate that. Let's look at our... Okay, so this... Yeah, that is... Okay, that's ugly as hell, but at least it's not... at least it's not off the border here. So that kind of sucks, and I hate it. It looks horrible, but I have certain constraints that I do not want to compromise on. So I fucking hate that. I'm sure if you're looking at that, you fucking hate that as well. But there's, you know, there's certain priorities I have with how I want my code to look, and that's just one of them. So P32 is obviously very dense. So I think what we could do to kind of like help mitigate what's going wrong is, well, first let's take this guy right here, and let's see where else we're using dry and wet. I think what we could do is we can say, like, define push 32 by 32 chunk, and that's we'll set it to P32, right? So now we got this is kind of crazy, right? So now we've added, like, way too many levels of indirection. We've added more mental indirection than we really want to add, right? Because that's going to be a pain in the ass. So what we're going to do to kind of help this mental indirection is in here, we're just going to say that, you know, assert, and we're going to assert that the address of P32 is equal to this, and that's still kind of ugly. It's still kind of ugly, but at least we have some type of what do you call it? We have some type of way to assert what we're looking at. Now, also, this is... Yeah, that's ugly as hell. We could shorten this. We could get rid of this namespace. Why not? Here, let me show you how to do this. This is something I try to avoid doing, because I try to keep my defines as just ways to shorten variables, and I try not to do this, but let's just do it, because we're running out of room. So let's say define fn, and the function name, and then in our macro, we just take this, right? We take this, and then we glue it together with the name, right? So we take the name, and we stick on this prefix here, right? And if we do that, we can do this with our macro. We can just say fn like this. And you can see why I would try to avoid this, right? Because if we're trying to look for this specific function name now, we can't find it anymore now. With a little Control F search is going to fail us now. If we try to look for everywhere where this is called, if we look for it with the namespace on it, we're not going to find it. And so that's why we want to avoid kind of stuff like this, because it's going to become very hazardous when we're trying to find things. So we're just going to do like little sanity check here, and we're going to put this here, and we're also going to make sure that the address of that... Okay, and also we have to actually... technically, we don't have to use the address operator on functions, but I like to just be as explicit as possible, so I am. Okay? We have a little bit of room. Let's just kind of line that up so it looks kind of weird as hell. but it was better than the alternative. So we're trying to eliminate some mental indirection of this, right? Because this ends up being this, and then this ends up being that, right? So we want to know that this is actually this, right? So these two functions are the same thing, and we used a lot of mental indirection to get this line that was short enough, and to aid in unwinding some of that mental indirection on the person reading the code, we're going to add these asserts, right? So now what was 2 levels of mental indirection now is back to a single level of mental indirection because we have this, right? So now that we have that, we have a push and a function define. So we already undefined that, but we want to also undef the fn, right? So undef fn, right? Okay, so I don't know, maybe we want to do it in the other order here. I think that visually it's a little bit more pleasing, right? This looks a little bit more solid, like this, like from a visual aesthetic point. Oh, I see kind of why we did it. Yeah, it does. So yeah, so that looks, this order looks a little bit better. But yeah, this is weird as hell. So I would avoid doing that. I would use that very sparingly, because it's just going to create problems for us. Right, like if I get bit by some weird type of macro, it's probably going to be one of these kind of macros, right? It's going to be, the more complicated those macros get, the more problems you can end up with in the future. So we want to be very careful about doing this kind of stuff. Okay, so now that we have this this push function right here, we know that this is the same function here, and we just want to call it, right? And now it's kind of a little bit more palatable, I guess. So we're just pushing a 32 by 32 chunk of memory to the GPU using the pixel bounding rectangle that we calculated for the current dirty sector, right? So we can make a note of where we are. So the at video integer ID. I kind of keep on forgetting the @ symbol, so I apologize if you're actually trying to look at the documentation and you can't find things, so I'm very sorry. So 53, the time is 4 hours, 50 minutes, and, oh god, okay, let's do 51. 4 hours, 51 minutes, and 6 seconds, sure. Okay. That looks good to me, where I'm confident that we've kind of stubbed that in there. Now that we've done that, let's look for where wet is being used, or actually where dry is being used. Aren't we supposed to be using that somewhere, or do we declare it, but we haven't really used it yet? Looks like we've declared it, but we really haven't used it yet. Also, P32, did we undefine that? I believe we did. Let's make absolutely sure. We have 14 defines. Do we have 14 undefines? Yes, we do. Awesome. Okay, so in our test code, here is our private unit test. Here's our, oh, sorry, that was our public unit test. This is our private unit test code. Here we see here is where we're running the syncing code, and we see we have the dry enumeration right here. This dry enumeration is this guy right here. Since we have a note, we can also, you know, make a note that dry equals this, right? We have enough room where we can kind of like throw that in there. For a little reminder, since we're just starting out the tests. Okay, so what are we expecting, right? So we've set a dirty pixel on every single dirty cell, every single 32 by 32 dirty cell. We've set 1 pixel. So we're expecting a certain heuristic of what happens. So let's look at Tausync data, right? So this value, which is defined to be, right, we used a define for these, I believe. So number of pixels pushed, yeah, so this is NP, number of dirty pixels pushed right here. So actually, let's color code them so you can see them. So let's color this cyan, number of dirty pixels pushed, and like, right, so we can associate those colors. And then we have this other thing, we have another thing, right? We have the other piece of data we want to look at is this number of blocks pushed, so NB, number of blocks pushed. So let's color code those, right, so you can see it. And down here, it looks like we're trying to stick to the terse variable, But every once in a while, if we want a nice little reminder, if we have enough room for the nice little reminder, we can put that reminder in our code. Like, I think we have enough room here. So we don't quite have enough room, but what we could do is we could just, you know, do that, right? And then this is num dirty blocks pushed, right? And yeah, it's a little bit ugly, but that'll do, right? So we want to query that. What are these variables going to be after we run this stuff, right? So let's think about the dirty pixels pushed. The number of dirty pixels and the number of dirty blocks should actually be a one-to-one thing, right? Because we're setting 1 pixel in each one of those dirty blocks. So the first assert we could do, we could just say that if np is not equal to nb, then error. So dirty blocks must match the clean block. The dirty blocks must match the number of dirty pixels for this specific test. So I don't know. Let's just say unit test fail 2020 12 21, and it's at 4:52 p.m. Okay. So that is when we wrote this line. It's just a unique string that we can find, right? Number of dirty pixels should match number of dirty cells, or actually 32 by 32 cells for this test. Okay. And it's specific to this test. This is not always true. This is not always true right here. This is only true for this current test. So at video integer ID is 0053, and the time is, where's the time? So 4 hours, 55 minutes, and 34 seconds. Okay, so if you need to find this, forever, like, what the fuck were we thinking? We can see this commentary here. So the next thing is, well, what are these values supposed to be, right? And the value should actually be 4 times 4 times... actually, let's kind of write it in a way where we can kind of see what it is. So 4 times 4, right, 16, times another 4 times 4, and then it's 16 by 16, right? So, oops, sorry. Okay, so times 16 by 16. And also, let's do something like this. So let's take this calculation right now, and let's make sure we know exactly what that value is. So let's just put that into Google, see what it says. Maybe we should open a proper calculator rather than using Google, but Google just is kind of fast for what we're doing. So let's just say that, you know, we're just going to assert that, you know, this equals that, right? And then... you know, what is that in hex? Because I really, for hard-coded values, I really don't like decimals. So let's see, let's take this and look at, what is this in hex for a second. So, 2 hex. Okay, oh, that's nice. I really like that value. It makes sense, because it's a power of 2, so I'm not actually surprised. But, so let's, assert, right, so... Right, so this is hard to comprehend, but when we see this hex value, it makes a little bit more sense. And then what we can do is we can make sure that, you know, if np not equal to, actually, let's put the constant value first, so use a Yoda expression. Okay, and really this is going to fail either way, right? Like, we have this equal to case, so it's not like we need to do these tests on an individual basis. However, this is test code. This should be as redundant. This should be redundant. Don't feel about being redundant and writing too much code, because it's test code. That's perfectly fine. It's test code, okay? So don't feel bad about writing a lot of test code. The whole point of test code is redundancy. So even though this and this is kind of redundant, it's kind of unneeded because we have this. Well, the point is redundancy. What if, like, you know, something happens to our test code, we accidentally delete this line, right? We have a little redundancy that's going to protect us from that kind of mistake. So be redundant. It's test code. You can be redundant. Don't feel bad about it. So for this, let's do like you know, air, and let's just keep with this pattern of UTF 2020, 12, 21, and 4:56 p.m. and 4:56 p.m. Or actually, just call it 4 p.m. A. Just because we want something that we can, like, we're running out of space here, right? So what we're gonna do is we're just gonna do the date with without. We're gonna remove the right now. This looks like a random ass number now. That's fine, right? It's enough to. We just need something unique to grab onto here, right? So once again, we'll just call this B, right? A and B. Now we have some unique strings that are in our code base, and yeah, that's fine. But what is this? Why do we have? I'm gonna guess that's just a stray. That's just stray. We just kind of made a mistake there. Okay, good. Good. So we got our second kind of test here. And one of the things we want to make sure we're doing here is after we run this, we have a cleaning function, don't we? Have a somewhere in here, don't we have some type of function that should be cleaning the data, like resetting the data so that we can do another kind of test? I know we do somewhere. Let's look at, it's probably in here. We probably only did it once. Where the fuck are you? Oh, yes, this force clear for unit test. So if we look at what is force clear for unit test, and what is it actually doing? So like right here, I know we're going to need it. And what does it actually do? Does it do everything we need it to do? So let's look at the, so it's in Tausync, so let's look at that and see what it's doing. Tausync. So we have a little bit of interlacing of our different libraries. But these are kind of tightly coupled libraries, right? They're all Tausync, right? They're all Tau libraries, so don't feel too bad about that. And let's make sure that it's clearing what we think it's clearing. So it's clearing those cells, but it doesn't look like it's clearing the actual data. Oh, actually it is. It's clearing the actual data right here. So we're clearing the actual bitmap data as well as clearing the tree structure. So we're going to need that so that when we're ready to do our next test, we can run this. And actually, we should probably put it at the beginning of each one of these test blocks. So this right here, so we have a little smoke test. That's fine. Variable, yeah, let's just put this right here. Okay, that's good. So this is our little smoke test. This is our more comprehensive test, and we're good. Let's give that a run and see where that goes. And then I'm gonna need to take a 15-minute break. Actually, we're gonna make it like a 20-minute break. I'm gonna take like a quick shower as well. But let's just see what goes on there. Function. So I've screwed up my little macro here. So let's see what's going on here. And does not give a valid pre-processing token. Shit, so we've thrown in a... Okay, I see what we've done. I see what we've done. Let's go fix that. So macros, you can shoot yourself in the foot with these macros sometimes. So in here, where the fuck did we put that? I don't even know where we put that. I thought we put it here. Oh, it's in the... it's in tausync.f, but it's in the... Okay, actually, I need to take a break now because now I gotta pee, so... maybe that's too much information, but we're gonna get to fixing that macro problem. But we're gonna take a let's see, is it gonna be 20 minutes? How much is it gonna be here? Yeah, let's give it 20 minutes. So I'm gonna take a really quick shower. I'm gonna do this as quickly as I possibly can, right? Because I'm gonna heat up my coffee. I'm gonna take a shower and all that business, and then we're gonna get back to this. But I need to take a break. So the way I do breaks is I'm going to set a timer. I'm going to put the timer on the screen, and it's going to count down. Even if I come back before the timer is through, I'm not going to write any more code or change that screen until the break is over. So that way, if you're listening along right now and you want to have a break, you want to have a 20-minute break with me, you're guaranteed that 20 minutes, right? So... even if it takes me less than 20 minutes, I want to make this easy for people to follow along. So we're going to do a 20-minute break. And so let me just get up a little timer here. And we're going to do a 20-minute break. If I come back before the break is over, we're just going to keep on this break screen until it goes to 0, right? So it does... actually, hold on. Let me load my scripts here. Okay, so I have a timer that I like to use for this. Okay, so we're going to set it to 20 minutes. Let me go to the break screen here. So, break screen and 20 minutes. So, if you need to do something, you got 20 minutes, and I'll see you then. I hope to see you then, because I like not doing things alone. So 20 minutes, everybody! Water, need water. All right. Okay. Let's see. Let's close this. Okay. Let's get back into it. Let me take a sip of this coffee. Let's remove the break screen. So we were doing something, and I totally forgot what we were doing. I know we're trying to run these tests, but there was some type of sanity check or something I was about to do down here, and honestly, I don't remember. So what we're gonna do is we're just gonna give it a run and see what breaks. You know, that's a good way to remember where we need to be. So, oh yes. So the function macro needs to be fixed. So. Within, and it's not within here, it's, let's just go look for fn. I know it's in the same file. So if we do like define fn, we're gonna find it pretty quickly. Yeah, so this macro, it's not the macro itself that's wrong, it's the address, right? Because I have the address operator inside of that macro, and that's right. So this is why I said, you know, we don't want to get too tricky with our macros because, you know, stuff happens. You know, it's just so error prone. So let's see, does that look proper? Yeah, it looks proper. Now, like I said, we do not have to Python is life. I'll let you keep that up there. You know, so to talk about Python for a second, it is interesting that some of the design concepts of Python are very similar to. Hey, how's it going? I don't know how to pronounce that. Herhotzenplotz. Some of the design concepts of Python are very similar to C, which kind of shocked me when I first looked at that, because you think that they're so different from each other. Oh god, rating. All right, sweet. All right. Hey, how's it going, Red Fox? So I guess I should give a quick intro as to what the hell is going on. Let's give a quick intro, even though you know a lot of you have already seen what's going on. Let's explain what the hell is going on. Let's give a quick. First of all, we are looking at some memory, and if you know what uniforms are for GLSL shading, it's a way to get variables into your shader, right? Uniforms are a way to get variables into your shader code. I want to get a shit ton of uniforms into my code. How am I going to do that if I'm going to exceed the limit for how many uniforms are allowed in a shader? The way we're going to do that is we're going to use a texture to encode uniform values. So we're going to take this 512 by 512 texture, and each pixel on that texture is going to be used to encode uniform values that we're going to push up to the GPU. But we have a problem. If we have a 512 by 512 texture, and we are trying to push that texture up to the GPU every single frame, we're going to get horrible performance. So we're going to overlay a quad tree-like structure over the 512 by 512 bitmap that we're pushing up to the GPU, and every frame of the game, we only push up the dirty sections of that bitmap, right? The dirty section of the bitmap is the variables that were updated, right? The variables that were changed are the only variables we need to resync with the GPU. So we have a 512 by 512 section of memory divided into 16 cells. One of these cells corresponds to another 16 by 16 division. So now we're in a 128 by 128 pixel subdivision. And then one of these cells here corresponds to a 32 by 32 pixel subdivision, or sorry, this last cell is 16 by 16 cells, and it's 32 by 32 pixels. The way we do this is each one of these 32 by 32 blocks of pixels is going to be used to encode a different set of variables. Usually it's going to be a set of variables for a certain subsystem. So let's just show you something shiny for those of you who are still here after the raid, since I feel like most of this is going to be pretty boring, so why not show you some of the shiny stuff. So let's look at my demos. So GMI, right? I just feel like that'll keep you interested to know what I am working towards. So you see this little guy. This is a little animated GIF of a bomb kind of game I worked on many years ago. and we're going to try to remake the engine for this using some other technologies. So it's going to be a tile-based game, but our tiles are going to be 2D, but they're going to be fucking fancy as hell. So one of the things we want to integrate is tiles that are generated with shader code, right? So that we can kind of like do some really tricked out 2D graphics to the tiles. The also important aspect of a tile engine like this is that we can zoom into these tiles and nothing gets pixelated, right? So if we zoom into these tiles, nothing's pixelated, and look at all that good shininess, right? It's all shiny, it's nice. All right, where's this, oh, hold on, where's the other one I really liked? This texture, right? So you can zoom in and you do not lose any detail, right? So you can zoom in. That's one thing that I want. I want these like procedural tiles where you can just make awesome looking levels by like layering together these awesome procedural animated tiles. So we want to take this technology and we want to merge it with this game engine here. Okay, and then we want to take some more technology. We want to take this tech. This is a tile map with multiple layers and rendering modes. So what you see on the top, middle, and bottom are the exact same tile map with different render settings applied to them, right? So we want to take this technology, we want to take this technology here, and we want to take this technology, we want to merge it all together into a single engine. Right, and here's some of this lighting system from the previous game I made. Here's a tile editor that I made as well. And we want this technology in the game as well. Some other fancy stuff that doesn't really apply. But yeah, so we have all these things we want to merge into the final engine. So, hold on. Let's give a quick demo of the game, since pretty soon we're not going to be able to play Flash on browsers. So let's just show you that really quick. So this was done in ActionScript 3.0, and now I did it over 2 years, and now the code base is, it's worthless, right? Because it was done in ActionScript, and that is why I am doing C code, because I can go as slow as I want in C, and I don't have to worry that C is not going to be around. It's going to be around for quite a long time, so if I want to code a code base in something, using C is a good choice. So, okay, the basic premise here is it's like Bomberman, but we have directional bombs that go in vertical, horizontal, four-way, and then we have, like, instant kill bombs. You see the geometry falling down over here. When falling geometry hits bombs, the bombs explode. So falling hits the bomb, explodes, chain reaction. Okay, so different bombs, different directions, right? So this is an intentionally very slow level, just so that if you don't know to go towards the door, it's going to slowly force you towards that door, right? You see up here, there's these little plates here. If you hit the plate, things blow up. So the reason that things blow up is these little pistons here. They're called flame pistons. They emit a little spark. The reason why we need pistons to emit a spark is because all of these bombs are proximity mines, so you can walk past them. When you walk past the bombs, they light up, and after a while, they start to blink, and then they explode. The problem with that kind of game design is it's very slow paced. So how do we speed that up? Well, the way we speed it up is the flame piston. The flame piston emits a spark when you step on it. If a bomb is underneath that, it's going to explode. So we hit the piston, everything explodes. Let's reset that level one more time for a second, so you can so I can explain some more of things going on here. So you see the material type. Different materials have different properties. This type beneath us is a vent type. It is indestructible, however, it allows flames to pass through it. Therefore, these horizontal bombs, when they are ignited, the flames are going to go through the vents and hit these glowing glass tiles, allowing us to get through here, because right now we can't get through. So basically chain reaction blows this up and we can walk straight through, right? I did the lighting engine, I did all of this. It may look like it's done in Unity, but it is not done in Unity. This was done in ActionScript. I wrote the lighting engine myself, I wrote the physics engine myself, but you know, Flash is dead, man, so So as cool as this is, we just got to leave this code base behind and work on a new engine and try to remake this game in a better engine, right? And so we're going to make that engine. The engine is going to be very tailored to this type of game, but I am going to release it for everyone to use. I'm going to figure out some type of royalty kind of thing where, you know, as long as you've made... If you've made, like, under 100,000, you don't owe me anything, right? So we have different levels. Different levels are different styles of play. Some are more puzzly, some are more high-speed, kind of fun levels, and, what is it? So, instead of having a difficulty change by how much health you have, we're going to change difficulty by just giving people different level designs. You want more puzzly levels? Then, honestly, I don't remember. But I know if you want, like, fast-paced levels, you got the fast-paced levels. What's your reasoning for making your own engine instead of using an existing one? For fun practice. Oh, so the reason for making my own engine is I have a very specific idea of what I want to do, and I want to optimize the hell out of it. And I'm actually doing a lot of very unique things that that really are going to require my own engine. So are you familiar with Glamburos? Glamburos? Are you familiar with auto-tiling? Glamburos? Auto-tiling. So let me just explain auto-tiling. I think you're probably already familiar with it. If you're looking at my stuff, you're probably familiar with it. But let's look at my demos for a second. Oh wait, I gotta turn on my shortcuts. So I'm still answering your question, but I gotta get to my demos here. And there's more than one answer to this question, so I'm gonna try to hit all the points. So auto-tiling, right? Where you have, like, basically the way you could describe auto-tiling. I can take an educated. Oh yeah, no problem. Yeah, of course. Oh, oops, hold on, wrong thing. So with auto-tiling, right, you have, like, one material type, and it naturally is aware of its contours because it kind of shifts around based on what its neighbors are, right? Auto-tiling. So imagine that in an auto-tiling engine where you have a graphic, right, and it tiles together. That graphic is usually made out of pixels, correct? Well, imagine you have an auto-tiling engine where each pixel in your graphic is not actually a pixel. Instead of being a pixel, the actual pixels are in the image for the auto tile are replaced with more auto tiles. And then those auto tiles can be replaced with more auto tiles, and you can keep on nesting it. And so you can do this fractal thing. You can get some fractal auto tiling. So let me look at some inspiration here if I can find it. So I'm going to type Tilex for a second. Tilex, I'm going to try to find this thing that kind of inspired me. So look at this piece of art. So this guy made some pixel art, and you can see, if you could imagine it, you could imagine this green, this one shade of green being one material type, and you can imagine this green over here being another material type, and you can imagine this concrete being another material type. Now, how could we make much more advanced auto tiles that could be capable of this level of subtlety, of this level of detail, right? So if you look at the game where I made, one of the problems with the design of let's just go into one of these level designs here. So one of the problems with the level design here is that everything looks very childish, it looks very toy-like. Even though we have different varieties of material, everything in terms of detail is at the same level of granularity, right? So there is something very lacking in the design. Let me press next. There's something very lacking in here. Like, we got a lot of, like, niceness. It looks kind of nice, but it would look better. Oh, this is a little asshole who tries to push you into the bombs. So the auto tiles do a lot for the design to make things look very nice very quickly, right? Because the artist doesn't have to think about where to set certain tiles. They just have to worry about what material is in what places, right? But we could make this a lot better, right? We can improve. Okay, going to try to beat this right now because I can't talk and do this at the same time, but we can improve this a lot. So if we could get each material to kind of have this type of variety, where like over here is the same material as this and it's still auto tiles, we can definitely do that, and that's one of the goals of this engine. So one of the ways we can do that is by applying some fractal nature to the way the auto tiles work. And also, if you look at this, right? So you see these tile maps where we're using multiple layers. Multiple layers is going to help break up the design and make it look a little bit more intricate and make it look better. But yeah, so it's a lot of things that to do it efficiently and do it fast is going to require my own engine, because I have a very specific vision for how this engine needs to work. So I'm going to take, I don't know if you've already seen this because you're already here, but I'm going to take, this right here, I'm going to take this tech here, I'm going to take this tech here, and I'm going to take this tech here, and I'm going to merge it all into a single engine. And then I'm also going to have a goal of kind of getting this kind of quality. But not only do I want this kind of quality, but I want to be able to zoom into it, not indefinitely, but like to a, the game is called Atomic Alice, so I thought it would be fun, just for fun, if we could zoom into any part of this level and get to a molecular level of zoom, right? Like if we do a fractal nesting of the different material types, we could actually zoom into the atoms of the materials in the level design, which I think would be really cool. It wouldn't be very useful in the sense of the gameplay, but it would be fun to like just like have maybe a certain mode of the game where maybe you're not really playing the game, you're just going around and you're like zooming in and you're looking at the molecular level of the structures. Oh, awesome. I'm glad you think it's awesome. So, the other thing is, if you look at these auto tiles, one of the benefits of auto tiles is that they always fit together in a pleasing way. So let's say this is a wall, right? Let's say this is a wall right here. Oh, boy, there goes our wall. So let's just draw some walls for a second here. We'll wait for the canvas to come back to us, but let's just draw some walls with our auto tiling. And we're gonna blow out these walls after we draw them. We're gonna wait for it to like come back to get the point across of what I'm about to say. So we're gonna make some more walls. So auto tiling is awesome. Also, let's check out this, right? Like if we want to zoom into these tiles right now, I'm gonna zoom into these tiles because I'm already close to the goal of kind of like having some way to like zoom in infinitely on the tiles. And this won't actually allow infinite zoom, but it kind of is a good proof of concept for what I am going towards. So hold on, let me just kind of boom, boom, boom. Also, if you want to see this page that I'm doing this stuff on, I will show it to you. Okay, so let's say we have a wall and a bomb blows through it. Bam! Blows through it. Another bomb blows through here. Bam! So you notice that the level fits together still, right? Like there's nice, it doesn't look like someone went into MS Paint and just like deleted the edge here, right? We have these nice contours where parts of the level are kind of blown apart. And well, I'm going to read your comment here. I may be a bit ignorant on this, but do you think you could come up with similar results with shaders? Yes. This is what you are looking at. What you're looking at right now is shader code, but it's not just the shader code that is going to be responsible for this engine. Like you are dead on. You are correct. But there also needs to be a data structure that is in the correct format to store this type of fractal data, to store this kind of nesting level design, where auto tiles are drawn using auto tiles, and those auto tiles are drawn using auto tiles. We need some type of data structure to support that. We need the shader code. We need the shader code to render it, but we're going to need the correct data structures to make that possible. So you are correct. You're not ignorant at all on that. You hit the nail on the head there. So let's zoom into this. So here's our tiles. Right now each tile is 45 by 45 pixels. Let's do like 64 by 64. Let's zoom in. So let's oh, that's weird. What the hell? If it doesn't zoom in when I go to 128 by 128, I might need to restart this prototype. Oh, there we go. So 128 by 128, you see how we've zoomed in, and we still see these nice details. And then if we go to, I think 255 is the most I can go, or maybe it was 256. Let's try 256. That would make more sense, because it's a power of 2. So let's zoom in. Zoom in, woo! We still see stuff, right? So, now you notice that even though we still see stuff, we have this kind of it's kind of a vectorish kind of zoom. You know, like, with vector graphics, yeah, you can zoom into them, but, everything starts to kind of lose detail. Like, everything's still smooth, but it still kind of loses detail in some sort of ways. So the idea is, you can zoom in, but there's like more and more detail, right? It's kind of like a Mandelbrot set. You know, like, are you familiar with the Mandelbrot set? Hold on, let me type that. Caps lock. Mandelbrot set. Are you familiar with the Mandelbrot set? Okay, well, I'm going to show you a Mandelbrot set. You may actually already be familiar with it and just not have realized that that is the name. So let's go look up a Mandelbrot zoom for a second, and I'm going to show you what that's all about. So you may actually be familiar with this and may have just not known what the name is. So, right? So you have this object that exists on a complex plane, and what we're doing is we're just going to zoom into it, and you can just kind of like zoom into it infinitely. Like if you have enough floating point precision, you can just keep on zooming and zooming and zooming. And this is part of what I want to implement into the tile system. I want to be able to just keep on zooming and zooming and zooming into the tiles, right? And like I said, that's not going to be fun for gameplay, but it's going to be fun for, like, you know, maybe you've already beat the game a few times and you just want to like zoom into things and see cool patterns and whatnot. Now, I think the Mandelbrot set to me is a little bit too repetitive. Like, yeah, it's neat and all, but like it feels like after you've seen enough of it, it's weird because it's always new, but it's always the same at the same time, right? Like if I look at this, I know I'm looking at a Mandelbrot set. Like if we keep on zooming and zooming, I still know I'm looking at a Mandelbrot set. So we want to have a similar kind of structure in our shader code where you can zoom in and zoom in and zoom in and zoom in. However, the structures that our artist is going to create is they're going to be handmade. So we're going to take a whole bunch of handmade pixel art, basically, that my artist makes, and we're going to use that handmade pixel art as input data for these fractals. So it's kind of weird to say. I mean, if you manage to build this tech out, I feel like fun gameplay could potentially be discovered with some experimentation. Yeah, so I think that maybe some like fun gameplay could be figured out that isn't related to the core purpose of this. Like, there could be some other fun gameplay I could definitely discover. But right now, even though I know this is insane for me, like saying that we're going to have these tiles that you can just zoom into and zoom into, but we're actually going to, the first game we're going to make with this engine is going to be the game I showed you. It's going to be this like little bomb game, right? So we're never really going to, in normal gameplay, we're never going to zoom in that much, right? Or maybe like in the intro sequence or something, we'll zoom in, right, and have some fun, right? But for the most part, we're not going to like zoom in that much. But the tech will be there for doing that. The reason is the tech that allows us to zoom in a lot is going to give us just these very high quality tile sets that have an infinite resolution, basically. Because one of the big problems with this game right here that we worked on a few years ago is that there's something lacking with the art. Also, you'll notice that this is very dense. Like, this game is very dense. We're going to fix that as well. We're going to make some levels that are just a single... Let's see, is that where I need to be? We're going to make some... how am I going to... I'm not even going to worry about solving this. I'm just going to go to a different level. We're going to make some levels. They're going to be a single screen like this that are very visually dense. But then we'll make some other levels that are very like platformery, and we'll zoom the camera in, right? And because this game is done with pixel art, if you zoom in, you lose a lot of quality. You lose a lot of resolution. So the goal of this new engine is to kind of like fix that aspect, right? some levels, some puzzles are good as these like one-page kind of levels, but other levels are better off as something where you can zoom in. Also, these levels are 30 by 30. I don't even know what the heck that was about. Oh, okay. These levels are 30 by 30 tiles. And I felt that these levels they were almost big enough to make all the kinds of puzzles we wanted to, but they were just a little bit too small. So the new levels are going to be 64 by 64 tiles large. And that way we can do, if we have any puzzles that we like from this old game and we want to put them into the new engine, we can do that. We'll have enough room, right? Because all these levels are 30 by 30. So if we have 64 by 64 for the new level size, then we can put all the old levels in. Also, if we need to, obviously, hold on. I only have one fan level, that kind of sucks. I had like 800 testers, but only one of them submitted me a fan level. This is very dense. Now imagine the level is 64 by 64. That's way too much detail, right? This is already visually dense. Imagine it being twice as visually dense, 64 by 64. So we definitely need kind of like camera to zoom in, zoom out for some things. For levels that are a single puzzle, we're not going to do 64 by 64 tile puzzles. That would be way too visually dense. So what we're going to do for, if we want to take this level and import it into a 64 by 64 map, what we're going to do is we're going to just cut paste this 30 by 30, paste it into the middle of the 64 by 64 space of the new engine, and then around the border, we're just going to give it like solid tiles around the border, just some flat pattern that you're not really supposed to pay attention to, right? You're just going to kind of you're just going to throw that in there like that, right? So, that's the basic idea of like what is going. Oh, look, is it still zooming? Yeah, it's still zooming. All right, so, but yeah, so I do think that there could be, like you said, there could be some type of new gameplay or new mechanic that could emerge. Have you heard of Marble Marcher by any chance? I think it's called Marble Marcher. Have you heard of that? If you haven't, I'll show you that URL as well really quick. It's not my stuff. It's something somebody else is working on, but it's really cool stuff. And they make like this this marble rolling game that rolls on top of like 3D fractals, and it's really cool looking. But so I could see some type of way to build that out, build out some type of gameplay. Also, I'm going to make the game I want to make with this engine, but then I'm also going to release it to the public and allow people to like make whatever kind of game they want to with this engine. So these video streams we're doing here are serving to be documentation for the code base. Like I write a lot of comments in my code, but also these streams are going to help supplement the code. So, you know, whenever you're writing code and you're like, what the fuck was I thinking when I wrote that code? Well, the way we can solve that problem is, so you see this code right here? Let's say the comments here aren't enough, right? Well, if the comment here isn't enough and I'm like, what the fuck was I thinking when I wrote this code? I see the video integer ID is 53, and I see that the time is 4 hours, 51 minutes, and 6 seconds, right? And on my video, on the stream, if you look in the bottom right-hand corner, you're going to see that the day is Monday, and the integer ID of this video is 53. So, I do not expect anyone to watch the entirety of my streams. I don't expect anyone to watch the entirety of what I backed up to YouTube. However, as you're using my code base, if you are really lost somewhere in my code base and the comments and these diagrams still are not enough to help you, I have these little video timestamps, and you can go to my YouTube profile and you can find the exact video. It's in the playlist in this exact order, so it will actually be labeled 53. That the video title will literally be 53 and then some type of explanation of what we did that day. And then you'll just click on video 53, you'll scrub to 4 hours, 51 minutes, and 6 seconds, and you'll see where we were working on that. And that will help you figure out the code, you know? Because, like, you know, a code base, learning a new code base is really hard as hell. And, you know, no matter how well written, no matter how many comments, there's always these things you forget to document, right? So I'm going to try this experiment where we use the streams to supplement the code base. And what I'm hoping there is, you know, even if I don't ever get a lot of followers, this code base will personally help me, right? So anybody who's using the code base is going to be helped by these videos, by these timestamps and whatnot. Awesome! I'm glad you guys like it. Memish, is that like Memish or Memish? Memish 1903 or Memish? I guess meme would be two E's. Yeah, so that's the basic idea of why I'm doing like what I'm doing. And if anybody knows how to like get a Flash player, like a standalone Flash player, I'd like to know, because like if I want to show people what I'm working towards with that game, after December, I'm not going to be able to run Flash on Chrome, so I got to figure out some other way to run it. Or I could take some short demo GIFs, maybe of the game, so that when people come into the chat, they can see kind of like what I'm working on. But yeah, I'm glad you think this is a cool idea, because I think some of the things I'm doing in this code are like insane. I think that like I am like if you talk about like unorthodox coding, like I am completely unorthodox. I just do weird shit. But I have reasons for reasons why I do things weird. Personally, I have toyed with ideas that it would awesome if I could drop images as comments inside Visual Studio. Yeah, definitely. Perhaps collapsible images. I find I regularly sketch diagrams or flowcharts to mentally visualize what I'm doing, and I wish I could drop those in my codebase. So let me tell you something about that. Glamburous, I think if I'm pronouncing that correct. My first job was and it didn't last very long, so don't think I'm awesome. I'm not that awesome. My first job out of college was a technical artist for Guild Wars, a intern. And what happened was I was at college, I was at DigiPen, and I was just coding something. I was working on a rig or something. And my friend Grissom came into the lab and was like, "There's a recruiter from ArenaNet. Get your fucking ass in there. Go sign up for the interviews." And so I went to the sign-up sheet, I signed my name, I drove off to Kinko's, and I printed off all of the diagrams I had made for my technical art. All of the diagrams and all of the code snippets. So like you're saying, you wish you could put like diagrams or flowcharts like into your code. I took those screenshots. So I have the diagram. I had 3 pieces of things that I took to that interview. The diagrams, the code, and the end result screenshots. And so I sat down with my, my stack of papers, right? Sat down with them. I said, here's a screenshot of an effect I worked on. All right, here's the diagram of how that code works. And here's the code snippet. And then I showed how where parts in the diagram corresponded to certain lines of code. And I did not think I was going to get the job, honestly. I think that's all very impressive and whatnot. But the first thing they asked me when I got into that meeting was like, do you know like who ArenaNet is? And I'm like, and then I think I lied or something, but they obviously knew I was full of shit and didn't know who they were. But I thought that would have immediately disqualified me because I didn't know who ArenaNet was. And I was shocked to have gotten a job there. It didn't last very long because it was my first desk job, and I just didn't know how to function in that environment. Like, if you ever worked fast food, you have to, like, take a drug and alcohol test before you can, like, work. And at ArenaNet, on lunch break, they were celebrating something, and they offered me scotch at my desk. And I was really like, it wasn't just this, there were other things I had to get used to. But I was like, what is this, some weird sick kind of test to try to fire me? Like, why are you offering me alcohol at my desk? Like, it was just weird. And I didn't know how to function in that kind of environment, right? Because it was a totally different culture. And so to, like, get used to that took a while. And then also, they didn't really know what to do with me. So they gave me a lot of like stupid code, and they gave me a lot of documentation stuff, and I wasn't really having fun there, and that kind of hurt my performance because I was like trying to like I kind of got stuck on this thing of like, man, I'm doing all this like Wikipedia. We had like an internal Wikipedia, and I was basically the a maintainer of their Wikipedia. And I was just like, I fucking hate this. I came here to actually write technical art code, and here I am just documenting stuff all day. So I really hated it, and so I was like, how can I automate this? How can I automate some of these Wikipedia tasks? And so I got stuck trying to code stuff to automate the task, and then that just put me down a rabbit hole where it would have just been faster to just do the job they gave me. And yeah, so some advice. No matter how awesome of a coder you are, man, that sounds pretty pretentious, but just go with this. I'm not talking about me. I'm talking about you. I'm talking about everyone here. No matter how awesome of a coder you are, no matter how much you impress the recruiter, no matter how much you impress the tech leads, when you get hired into a company, expect to do the stupid grunt work, okay? They're hiring you so that they can do the fun stuff and give you the boring stuff. Just that's the reality, that there is this kind of seniority thing. So just as long as you are going to expect that and not be, as long as you expect that, I think you're going to do fine. Because that really sabotaged me, because I wasn't expecting that, right? It was a different culture, right? I wasn't expecting the different culture, and I was expecting to work on things that were actually fun based on the kind of stuff that I had shown them, and I didn't get to work on that, and that was a bad combination. And I will tell you, to quote, I won't say who it was, but it was the lead technical artist at the time, like the head technical artist, said when they fired me. So unfortunately, I have a lot of experience of like being brought into a room to have a talk with the boss and then being fired. So I know what that looks like. I know the signs that lead up to that and whatnot. But what he said when we got into that room and they fired me was, when I met you, John, I got the idea you were kind of a mad scientist type, and now I think you're just a little bit too mad and not enough scientist. By the way, they weren't saying mad as in like I'm an angry guy and like I have rage. He meant I'm crazy. He meant I'm crazy, man. And you know what? That's valid. Like I'm not gonna argue with that one, because my code is pretty batshit insane. However, the other thing my one of my other bosses said was, ever since you started working here, you haven't been working on any personal projects. And that was complete bullshit. I just never showed it off. I didn't see any need to, like, show off what I was working on outside of work, right? And they really want to, right, people, when you're at if you're a coder at, like, a top-notch company, they want to see that you're kind of like working on code outside of work, that you're sharpening your skills outside of work, that you're really you're so passionate about code that you work on code outside of work. They're going to want to see that kind of stuff, right? If you're at in a top-notch company, they're going to want to see that. And I didn't think it was necessary to like kind of brag. And so that's kind of like a political aspect. So you got there's a lot of like factors, but experience is one of those things that you don't really get until after you need it, unfortunately. So, if you're listening to me right now, hopefully I can save you some trouble. If you are in that kind of situation, or you're ready to get in one of these situations where it's like your first programming job and you don't know quite how to function in that environment. Also, I would advise, if you can work somewhere where you're working with one of your friends, that's also good. Because let's say you do something really socially stupid in the office, and you just don't know you've done it. Because a lot of us programmers are not the socially smartest people, right? Let's say you do something socially stupid, but you're working in the office with one of your friends. So then your friend can like take you aside later when you're outside and be like, man, you gotta like stop saying shit like that, or don't do this because people hate that, right? And tell you what not to do to avoid not being liked in the office, right? Because when people need to lay people off, right, they're probably going to lay off people that they don't like. Now, I know a lot of us who are really proud about being good programmers are going to be like, well, I'm a great programmer, personality, why do we have to worry about that? And the thing is like, not all programming jobs need like genius level programmers, okay? A lot of enterprise programming you're going to do is boring as shit, and it's really simple, it's really easy, and because it's so simple and easy, they can find a lot of people who are good enough to do that job. And then the differentiating factor is not skill, it's actually going to be do they like your personality or not, which kind of sucks. It fucking sucks, man, but that's the way it is, I do work as an engineer, and I understand entirely. I find my work doesn't give me the chance to learn and improve. You do have to do that in your free time, in my experience. Yeah, exactly. Exactly, yeah. Sometimes you get lucky, like if you're like a research scientist or something, you can get lucky and get one of those jobs. I think I listened to a data scientist give a talk, and he said something along the lines of, the most interesting programming jobs don't have specs or requirements or something. The only spec is like, wouldn't it be interesting if a computer could do X, right? But most programming jobs aren't going to be that fun. In fact, not to like shatter everyone's dreams, but most jobs, even if there are things you like to do, they're not going to be fun. And it's not that, it's because like anything you do for a long enough time, you get desensitized to it, right? That's just the reality of things. So you're gonna need some, even if it's a passion project, no matter what you're working on, it's going to lose some of its allure as you've been doing it for a very long time. And because of that, you need some other things to keep you going besides just raw excitement. You need a little bit of self-discipline. Also, you need some type of long-term goals to like anchor you in, right? To where when you're in the middle of this stupid fucking unit test code that we're working on that we hate, that is not fun at all, that you can think about the long-term goal of your vision of what you're trying to accomplish, right? Because a lot of times code is not fun. It's what you make with the code that is fun, that it's interesting, right? But anyway, so I've ranted enough. Let's look at our code here. We're in the middle of some unit tests. This is not our unit test code, is it? So this is our unit test code is always at the bottom, so that's nice, right? So we're trying to figure out where we are. Oh, we just fixed those macros, didn't we? So, okay, here's our unit test section. And then we have our private unit test. So I don't know if it's been obvious, but the way the names are structured is it's double namespaced. We have the namespace of the project, that's AAC 2020, that stands for Atomic Alice C 2020, 2020 being the year the code base was established. Tausync is the sublibrary, and then anything after that is a function or variable name. Also, if it is supposed to be a private function, we're going to use lowercase for the namespace, and if it is a public function, we're going to use uppercase for the namespace. And I'm going to use public and private in a very loosey-goosey kind of way. Like, I'm not going to be super strict about that. Private, to me, in this code base, just means, know what the fuck you're going to do with it. Know what the fuck this code is for, know how to use it, or and maybe a more safe, work for safe way to say it is know what this does. Read the manual, know what it actually does, know the implications of running this code because it's private, right? So it just means if it's private, I just mean be careful when you run this, right? So also private usually means that I don't want to call it from another sub-library, right? Oh, I want to call the public versions when I'm like doing my coupling of different libraries, and different libraries are calling functions from other libraries. I want that to usually be done through the public functions. Okay, so now that we got that out of the way, let's see if we can get to here. Or actually, we really want to see if we can get to this unit test end to see if this next unit test we wrote is going to run or not, or pass, right? Also, we may have made some syntax mistakes. You'll notice that I'm just using Notepad++. And that is so... a lot of times the IntelliSense really distracts me from the code I'm writing. And so I'd rather just fix all of the bugs in my syntax after I'm done with all of my thoughts. Also, it just helps me remember how to write better code rather than kind of relying on the editor to kind of just fix my sloppiness. Also, without IntelliSense and whatnot, it forces me to be very consistent in the way I write my code, because I can't just kind of grope my way through the code base using IntelliSense. I actually have to know what the function names are. So, implicit declaration of function error. So that's weird. It's in Tausync run. Interesting. So I guess I probably forgot to add a macro. So let's look at Tausync run for a second. That's really weird that... Really? When did we add... So I'm just confused because I thought that we already kind of... We wrote this code, yeah, we added this into it, but I didn't think we made any, like, other changes, like, you know, for instance, adding some type of error call. Did we? Oh, yeah, we did, We, right here, we're checking the enumerations here, so, we should probably have another, like, fail fast here, like we're nested pretty deep. We should probably have something that fails at the beginning. So let's take this while we're fixing that error macro. Let's do a kind of fail fast assertion to make sure we have the correct enumeration passed into this function at the very top. It's a little bit of extra redundancy, but I think it would do us some good. So let's define error, and we're going to call it AAC 2020 Tausync, and I use the function name halt in all of my different sub-libraries. Halt because, I don't know, because I'm a fan of Alan Turing, I guess. Chocolate Marty? Hello, how's it going? Do you want to see, like, a quick rundown of what we're doing? I'm going to have to go pretty quick with it, but I can show you some shiny stuff if you want to see something very visual right now. I can go over that really quick with you, since you just popped in and said hello. Other than that, I'm going to keep on coding unless you... Alright, I'll show you something really shiny really quick. And we're going to go pretty quick with this because we already kind of kept on doing this. But I'll show you some shiny stuff. Okay, so demos. Also, I got to put it on my shortcuts. Hold on. Okay, JMIM demos. Yeah, it won't take long. It's going to be really quick. Okay, so here's a little tile-based game that has explosions. It's just an animated GIF. Geometry falls down, things blow up. Bombs are different directions, chain reactions, awesome stuff. We're going to take this tech here, we're going to merge it with this kind of tech here, this shader tech here for making the tiles, because this was bitmaps used for the tiles. Now we're going to use shader code for the tiles, and we're also going to implement this tech where we can have different tile maps that have multiple layers and have different rendering settings. So you see these three images, they all have different rendering settings applied to them, but it's the same exact tile map for all three of these images here, right? And then over here, nice little lighting system. We're going to put that in the engine as well, and then some other stuff. But that is my quick rundown of what the hell is going on. That's not exactly what we're coding right now. We're coding a unit test for packing texture. For packing uniform values into a texture that we're going to push up to the GPU. Thank you for telling me that it looks cool. Awesome. So right now, that's not what we're doing. Honestly, we're doing really boring shit today. So I mean, if you don't want to see boring shit today, that's fine. You can come back another day. Things are going to get more and more awesome as the months go by. But for now, it's going to be boring. So I'm not going to feel bad if you leave and come back another day. But I don't want you to get your expectations up that, like, you know, things are going to be fun today, because they're not going to be fun today. Today is going to suck, and most of the days are really going to suck, until we actually get some critical mass going and get to the point where we can start making assets for this game and whatnot. So, anyways, that is your rundown of what's going on, and a little warning about, you know, the content isn't going to be that fun right now. Okay, so we got this. Let's put a little fail-fast assertion right here. So, now, I'm going to actually not make it an assert statement. Actually, I came because I was hoping I could ask them. Okay, yeah, shoot, go ask a question I may or may not know. You know, I'd like to think I'm pretty good with C code, or if you have some type of other general question, just ask away. Yeah, man. Yeah, so we're going to make a little assertion here. We're going to say that, so if, 0, and then or, oh, networks. So, I haven't really done much, network programming. I mean, I've done, like, Node.js, but I'm going to guess that since you're here, you're probably talking about, like, sockets and, when you're trying to play a multiplayer game and you're trying to do that across the network. I'm going to guess that's what you're asking about, and I do not have expertise in that category. I can keep that in mind in case I find somebody who is familiar with that on Twitch, but I don't, I'm kind of new to Twitch, so I'm not really familiar with anyone who knows about networks. I know about, like, database stuff, like I can set up a Heroku server and access a database, but I can't really do, like, real-time socket stuff that would be used for games. Well, specifically, I wanted to know, how can I see if someone from the same networking is looking at my traffic? Okay, God, I do not know. That sounds like a network security question. Something that would come to mind would be, like, maybe a packet sniffer, but, like, that's out of my expertise. Yeah, unfortunately, it's outside of my expertise. I mean, if anybody who's also watching the stream has any answers, for our viewer here, go ahead and, give them an answer, but yeah, that's not my expertise. So I'm sorry, I don't have answers for that. But yeah, if you have questions and you want to drop by and just ask questions, like, yeah, feel free. You know, unfortunately, a lot of times I'm probably not going to have answers for you. But if I do have answers, you know, I'll give them to you. And if I have somebody direct you towards, I will also do that. You might be able to use Charles Web Proxy. I never used it for that purpose, but it'll allow you to view your incoming and outgoing network traffic as it occurs. Oh yeah, and okay, and depending on what you mean by network traffic, and I don't know, like, exactly what you want to do, because it's not my expertise, but, you know, Chrome Tools has a network tab, you know, but it kind of sounds like, let's see. Hold on, let me read your question again. Oh, yeah, so you're talking about what my dad used to do to me all the time when I was in high school. So unfortunately, my dad's dead, but, and that sucks because he died really young. But, yeah, he used to be able to sniff my networking traffic all the time when I was on his network. And so I would ask him, you know what, I'm going to ask my stepmom, because they used to work together a lot, and I don't know if she'll have any answers. So I'm going to shoot off an email for you, and I'm going to make a note of your name here. I'm going to make a note of your username. I'm going to shoot her off an email and see if she has any answers. And then, you know, if she has any answers, I'll get back to you. I'll try to get back to you either way. But yeah, if she has any answers, because they used to do exactly what you're talking about to me all the time when I was at their house. So let me just shoot off an email really quick. I'm not going to show my screen here because I don't want you to have their email address. You can message me, you can email me all you want. But for other people that I personally know, you know, we can't really do that. Network traffic sniffing. Okay, I have a Twitch viewer that wants to, or traffic sniffing. I know my dad used to... Okay, yeah, so I'm sending this email off right now. Just gotta sign my name here. Yeah. So yeah, that is sent off. So it sounds like Glambrous kind of has a good answer for you, but you know, more information the better, right? Oh yeah, I totally, yeah. I mean, it's bad enough that we have landlords. You know, add somebody being a creep sniffing around on your network, and you know, geez, that's even worse. All right, very cool. Yeah. So yeah, I mean, good luck with that. Yeah. Okay. So what am I doing here? So we're gonna do a little fail fast kind of assertion to kind of check that the incoming parameters on Tausync are correct. So we're going to look at Tausync data. I keep the data on the left and the functions on the right. And we know we need these two. So we're going to say, oh man, we just have enough room. Okay, so this one and this one. Okay, so what we're doing here is, this might be a little bit weird. The reason I write it this way is just so that I can, each line is uniform. That's why I put the 0 here. It's just a formatting. It's just to help me with the formatting. And if it's one of these things or the other, right? If either one of these statements executes to true, this one or that one, we're good. We're good. Correct enum input. And then otherwise, else, we're just gonna, right, this is kind of batshit crazy formatting, but we don't really care. It's not like hard logic, so we can kind of cram it all like this, and I don't really care. My formatting, I mainly try to be consistent with my formatting and my indentation on a very coarse level, and sometimes in granular aspects, it breaks down. Bad enum supplied. And this is this function, so we're just going to take the function name, make a little nice friendly error message this time, even though we don't always do that. And we're going to give this another run, so because now we've defined this enumeration here, and if we look at the bottom of the GPU sync section, we also see that we have undefined it, so that's good. Let's take a run, see if we screwed up any syntax. At Kanji Coder, would you happen to have any book recommendations for good test automation practices and or design patterns? I've read a lot of books that emphasize the importance of creating tests, but nothing that really describes implementation strategies in depth. No, I don't think I do. So let's see. So when we're talking about like test-driven development, obviously I think the gold standard there is like clean code. So you've probably read clean code. So I don't really have anything else to add to that. Obviously, there's like the Design Patterns book by Gang of Four. There was an interesting book I read on refactoring, but that's not really what you're looking for. So yeah, that's yeah. So speaking of tests, yeah. The interesting thing with tests. This is just a random tidbit. You know how my getters and putters are kind of like putting stuff onto... Yeah. Oh, got ya. So interesting thing with the way I'm doing things, you know how I'm like packing all of my variables on a texture? Because of that, if I make a mistake where I store the exact same two variables at the exact same pixel location, if I do a getter putter test where I test if I do a put this value, and then right after I put the value, I get the value, the test will pass when it should have failed, because, okay, let's say that I have two variables I want to set on that texture. I want to set this variable called game time, and then I want to set another variable called game time and player speed, right? I have game time and player speed, and I want to set those variables and make sure the getter setter works. So I set game time with the setter, and then I use the getter, and I see, oh yeah, I got the value that I set. Great, I set game time, it worked. Then I set the player speed, and then I get the player speed, and oh, that worked too. Great, my getters and setters work, yay, but they don't actually work because the game time and the player speed are actually stored in the same pixel. But I didn't detect the problem, but I would have detected the problem if I ran both of the putters first, and then I ran all of the getters. So if I did it in this batch kind of processing, if I organized my tests like that and did all of the puts first and then did all of the gets, I would have actually found a problem. But if I did it with just get put, it doesn't work, right? And so that's kind of a very specific example, but I think it also illustrates as to where, yeah, encapsulation, I get the goal of encapsulation and why it's a good idea, especially for enterprise software, but a lot of times you need some type of knowledge of the internal system to effectively write a thorough test. So that's just like one piece of insight as to writing tests. I'm not really a fan of TDD, but I'm all for experimenting, right? Like, I've done lots of experiments of, like, writing code in different styles. So there are things that I have very strong opinions about TDD. I pretty much hate TDD. I love tests. I hate TDD. But I think that as far as, like, experimenting with TDD and experimenting with TDD, trying it out, trying all these different ways to write code, I think that's great. I think that the more things you experiment with, the more things you're going to find out about yourself, what works for you, and the closer you're going to get to an absolute truth of what builds good code for your kind of style, right? You're going to write a lot of shit code as you go, and the more things you experiment with, the more search space you use, the more you're going to hone in on that great way of programming that may be particular to you. Right? You're going to hit like if you don't search wide enough when you're experimenting with programming styles, you're going to think that you hit in math terms, you might think you hit like a maximum in terms of like a graph of like the maximum optimal coding style, but it might just be like a local maximum, you know, because you didn't branch out far enough and like try enough things. So I think trying different things is great, and I'm all for like experimenting. Yeah, so TDD, my opinion on TDD is TDD is really good when you know what the design constraints are up front. Like when the client says, here's this API needs to do this, and this. Because you've been given these requirements up front and you already know exactly what the API needs to look like, right? Because you're going to start from the front end with the interface because it's the most logical place to start, because you start with these design requirements that the client wants, right? So you know exactly what you need to do in terms of that interface. And that's why you can write the interface right away and write the failing test right away, and then start to flesh out those details. Now, although in reality I find it so rare that the requirements are that clear ahead of time. Yeah, totally, right? It's one of those things that, like, it's academically, it's kind of like, academically, in a academically perfect world, it like makes total sense, but then the dirtiness of reality always reality rears its ugly head and fucks your day up, So my personal thought on that is start wherever you have the clearest idea of what needs to be done. Sometimes the clearest idea of what needs to be done is that interface, right? And if the clearest idea is the interface, go ahead, TDD the fuck out of that, right? If the interface is the clearest thing, TDD. If the clearest idea is the data layout, then flip that on its head. Flip it on its head, flip it over, start from that low-level code and all those little details. And as you're working on that low-level code, you'll start to get an idea of what that interface needs to look like. And I have a good example of that. So let's look at like my little notes here. So you see this like dirty sector update? I had no fucking clue that the interface for dirty sector update needed to be these 3 parameters to correctly locate certain sections of the memory that were flagged as dirty. I had to figure out what this interface was going to look like from actually, figuring out an efficient way to kind of subdivide the data. And then from after doing that low-level stuff, I was able to figure out what the interface needed to look like. If I had started the other way around for this, it would have been disastrous. Now, if we're talking about, like, Node.js programming, right, and we're talking about, like, some type of API that we want to... Let's say I want a scoreboard kind of API. It needs to, like, submit... It needs to be able to do, like, the CRUD operations and all that good stuff. Yeah, then I'm probably going to TDD it. That's fine. TDD for that, that's fine. It makes sense to do it that way. It's really a case-by-case basis. And I think that arbitrarily saying that you either got to start at the front API or you got to start at the low-level nitty-gritty details, having a hard, fast rule of having to start at either one of those points seems kind of too... it seems too rigid for me, right? And I'm pretty rigid with the way I write my code, but in terms of like attacking the problem, sometimes I just think that it's way too rigid. Now, I think that that sticking to that rigidity for an experiment, like you're doing, like you want to experiment with TDD to do a project, doing it in a really rigid way like that, and applying certain very rigid constraints like that is a good way to experiment, right? Because when you're experimenting, you want to isolate variables, right? So you want to isolate some type of thing that you're testing, and you don't want to change that one thing. You don't want to like break the exception. So a good example of things that I isolate with the current code experiment that I'm doing that is this code base, it's pretty obvious. It's the fact that all of this code is exactly a 64 column limit, right? And it's pretty obvious that I have a very strict column limit here, because, right, I got the little column limit line, and when we scroll here, we don't see anything going past that line, right? So it's an experiment to be like, you know what, I think that code is... It's an experiment where I'm like, I think code should be linear. I think code actually belongs on a vertical monitor. But since we're doing this as a stream, it's like, you know what? Since I'm very terse with my code and I keep everything with a very strict column limit, I think this would be very good for a stream because I have enough space to put code on one side, code on the other side, and we still have enough real estate where I can zoom in and everyone sees what's on the screen. Anyways, let's give this a run because I honestly lost track where I was because I was talking. But this is fun. I'm enjoying talking to you. Too few arguments, yes, because we need to fix that up. So let's go look for where that's being called. We're not calling it with anything right now. So yeah, for this Tausync run, yeah, we're just going to take the Tausync run. This is the public version. We're just going to have to pass on the those enumerations. So we're going to take this enumeration. It's a UO8. And yeah, nothing there. We just got to do a little kind of refactoring here. So UO8. And I think we have that declared. Linus Torvald. He says functions are special. So he likes to do this, and then all other cases he likes to do it like this. I think Linus is a smart guy. I'll take some advice from him. I'll take I take actually a little bit of advice from how Linus thinks things should be done, and then a little bit of advice from how like John Carmack thinks code should be written. Which I guess is an appeal to authority, but I guess if we're going to appeal to authority, let's appeal to people who actually have proven they know what they're doing, you know? Okay, so this right here, and then we're going to move this over here. We got to throw this in here. Technically, that sanitization of where we're doing, like, the check for what this value should be, that really should have been in here. Like, the public versions of functions should be the ones where they have, like, more of the air checking, right? And the private functions can be more like safety off, no air checking kind of thing. And we kind of screwed that up. But you know what? Whatever. We're just going to add more air checking because I know it's kind of clutters up the code, but I would rather be safe than sorry. So let's just, we could do it in a different way. We could just write in assert, but we're probably going to run out of room, aren't we? Actually, no, we can't write it that way. So let me just go back up and see what kind of statement we kind of wrote for that. So we kind of wrote this. I'm just going to take this, cut and paste it, and reuse these air checks, which is kind of stupid for me to do. It's kind of ugly. But I'd rather be overly protective when I'm running my code than to not be. So we'll capitalize this so it's coming from the public version. Also, when I name my variables, if it means the same exact thing, I'm going to try to keep the variable the exact same name. And variables that are spelled longer like this means that they are things I kind of like made up on the fly. And when a variable is very short, if a variable is very short, it means that it's kind of like a standardized variable that I use a lot. So like so for instance, like pixel name, pixel array, pixel width, and pixel height, right? Like if I have names like this means that I use them quite often and they're formalized into things like this, right? If you ever heard of like Hungarian notation, like systems Hungarian and apps Hungarian, I don't want to get into too much of a rant about the difference. I think that systems Hungarian is stupid. I think apps Hungarian is a great idea. I do something in a similar vein of thought. It's that each one of these variable names has a very specific definition, which means that by looking at this variable name, I know exactly the type of this variable, and I know exactly what that variable represents. In other words, the type, I know the type of the variable, and I know the kind of the variable. Kind is like a more informal thing. It kind of means like, for instance, let's say we have like, dex pix and we have dex com, right? So the type of both of these is integer, right? So they're both integers because they're indexes. But the kind is an index accessor, right? And the type is integer, right? So type versus kind. So there is your quick tutorial on apps Hungarian notation and what that's all about. Right now, apps Hungarian actually, uses some weird fucking prefix in front of things. I think that's kind of crazy. It's less crazy than systems Hungarian, but it's still kind of crazy. I think it's kind of a good idea sometimes, but it just makes really bloated variable names. So I'd rather have the type and kind embedded into the variable by having like a very strict, rigid index of variable names in my documentation. Okay, so we threw a little air checking in here, and did we? U08. Do we have a U? I don't know where we are again. Let's just run this and see what happens. Unexpected before uint 32. So you're gonna see me do this a lot, where I just look for the line that the problem happened on, and I don't really read the error message. I'm just like, half the time the compiler is gonna lie to you about what the error message is, just because you could do something weird with the syntax or something, and it says one thing, but it's actually another underlying problem. So, on line 488, what we got? 488. So I'm kind of scared right now. 488, where are you? Is that really 488? So this looks like, if that's 488, is this the right file? Tausync.f? Ooh, that's kind of scary. Oh, 533. Okay, 533. Macros add a little bit of indirection into the error messages. So we got U32, P1, P2, P3, and... Okay, I see. Got ya. How are we going to shorten this? We're just going to call it pixvar, and we're just going to have to know that pixvar, it means pixel variable. Yeah, so we kind of forgot our closing parentheses there. So the idea of writing it this way was so that we can kind of like close this 0 in with the comment. And I'm purposely tightly coupling this commentary with the variable assignment, and that's very intentional. I like to ingrain the commentary in there very deeply. So another thing is so pixvar. Pixvar means pixel variable. Okay, I can't type. Okay. So we could just shove that over here in this block like this. That's fine. I tend to just rely on my IDE to tell me types, unless I'm working in Python. Then I'll add some notation to inform myself that type I expect the variable to be. Yeah, so IDEs make you a lot faster. Like no doubt, like the game I worked on in Flash that I showed you was done in Flash Develop, and it made me like it sped me up probably 10 times faster maybe. So IDEs will make you a lot faster, by far. The reason I don't use an IDE right now is because it makes it so that I have to be very rigid on how I write my code. And it changes the style, right? The tools you'll use will change what the code looks like. So, and there's another reason for it is I'm kind of like a pocket knife person as opposed to like a blender person. That's an analogy. Like let's say in your kitchen, right? In your kitchen, you could have like a food processor and a blender and like a whole bunch of very specialized tools, and I'd rather just to have like a very simple kitchen that just like has like one good knife, one good cutting board, and yeah, it's gonna take me longer to like dice that lettuce because I don't have a food processor, but it kind of like reduces my cognitive load in other ways because I have just a very simple way that I do things, right? So for instance, I'm not using CMake, I'm not using make or CMake to build this, right? So let's so if we actually open up this bash script, right, open with Notepad++, you're going to see that this bash script is actually very simple. It's just, take the C11 file and compile it, and then compile and run it, right? That's all we're doing, right? And then all of the extra stuff right here, it's basically like compile stricter, right? That's all I'm doing. It's like here's some files for me to compile stricter, except for this one. I ignored the warning for overlink strings just because I need a very large string for different shader code that is embedded into the shader. And I looked up the implications of this, and basically as long as I'm not operating on some type of like archaic architecture, this warning we can ignore. But yeah, so there is no real build script here. It's just like, here's some settings to make sure that I don't fuck up when I'm compiling, right? So some settings that aren't going to let me do anything too stupid. And so there's no like CMake or anything. It's just GCC the C file, right? GCC the main C file. No linker, right? No linker to worry about. None of that stuff. Simple as possible, right? So then it's like, well, how am I gonna like manage everything if it's like I just have that script? How am I gonna like have some type of build system? And so the build system, if you can say that there's a build system in here, if we look at the root C11 file, which I may have already showed you this, right? The root C11 file, I have this thing called a library chain, and these are the names of all the subsystems of the game, and there is a very strict dependency. So gra quad, that is the gradient quad that sets up the basic GLSL kind of pipeline, the OpenGL pipeline. And gra quad cannot reference anything in front of it. So immediately when I'm looking at GraQuad and I want to understand what's going on GraQuad and I want to know like what other things it uses, I can immediately ignore these when I'm trying to understand what GraQuad does, right? I immediately know it can only possibly be referencing something back here. The other reason for this kind of build system, if you want to call it a build system, is say if something goes wrong in my project, I do something really weird, like I seg fault, or I do a memory stomp, or I do some type of weird memory coherency problem because I'm multi-threading, I can subdivide. I can compile up to here, see if I still get the weird side effects. And let's say when I compile up to here, everything works. So then I split and I compile here. Things don't work, so I know the problem is happening somewhere between here and here. So I split again, see if this works, and I do like a binary search to see if things are working or not. So it's a very kind of like, you could call it a very rudimentary kind of setup here that I've got going. But the idea is just to keep my code kind of like least common denominator and just keep it as simple as possible. Now, I have done things like dependency injection in the future and lazy initialization and other ways of like solving dependencies, but I find that knowing exactly what your dependencies are and having a very strict ordering of your dependencies really helps understand what's really going on with your code in a very low level. So, for example, if you're using dependency injection, if you add another library into your code base, it could change the way the dependency chain is like resolved, right? Because you have to take that you have to take the dependency graph and you have to linearize it, right? And if you introduce a new library, all of the includes that need to be like included could be like included in a drastically different order than before that library was included. So it introduces a lot of potential for just weird things happening because you drastically changed the compilation order by introducing a single library. So it's very tedious to kind of figure out the exact order that certain things need to be, but I know that when I add a new system, right? Like when if I have to insert a new system between here and here, I know that the chain of includes here is very consistent. It hasn't changed. Nothing weird has, happened, right? Okay, so anyways, where are we again? Let's just give it a run. Too few arguments, so we gotta fix that. Obviously, we're going kind of slow because we're kind of chatting, but I'm enjoying it, so it's fine. Okay, so let's see. Where are we calling this run function without any parameters? So right here, and do we have a define? Yeah, we have a define for dry run, so we're going to take that dry run define because this is in our test code, and we'll put dry right here and anywhere else that we're calling that. So we're good there. Okay, let's just give that a shot, see what happens here. Wait, that's the same. Oh, wait. Oh, okay, hold on. Never mind. I was looking at some old console. Okay, so is everything, it looks like we failed. Did we fail? Well, something went wrong, that's for sure. Yeah, so we failed the test. And we're going to have to figure out what went on. So let's take a look at where we failed here. So it looks like the number of pixels is not matching the number of blocks, right? And our goal was to... Oh yeah, you gotta run, no problem. If you gotta go, you gotta go, right? So I don't know if you're already gone or not, but good talking to you, man. So I have to run for now. Thanks for the stream and the chatter. It's been very informative and interesting. Yeah, no problem. Like, if you're interested, that's awesome. All right. I'll send you a little message just in case I missed you. Yeah. All right. So, anyways, where are we? So I'm gonna guess everyone else is just kind of listening along, and this will go a little bit faster since we're not kind of chatting. Now that we know that these numbers aren't matching up, what we're gonna do is we're going to expand out this block and just kind of like get a printout of what's going wrong. And so the idea is, to make a little printout of what's going wrong takes some time, right? And we want to follow the Yagni principle. So Yagni being you aren't gonna need it, right? So until we actually need this, we're not gonna code this, right? So it would have been foolish to code what we're about to code before this error got tripped. But now that this has tripped, we might want to get some more information, right? So let's just print off what's going on, right? Let's get some feedback. So we're just gonna echo out these variables. So these should be decimal values, right? So n and p, and then n and b, right? So the idea is that just by looking at what these values are, we may find something kind of unusual, right? We might find something that kind of tips us off as to what's going on. So that's the goal, is to hope that by just seeing the numbers, that some type of pattern will kind of emerge. Or maybe we don't know how to spell printf because we suck, I guess. Let's printf, there we go. So we're gonna take that and run that and just kind of inspect, like, what are those variables? Okay, so we got a so that's right. So when it's something like this obvious, it really helps, right? So we see number of pixels set is 1024, but the number of blocks is 0. So I'd say that's pretty that's pretty helpful, right? If it was like off by 1 or something else really weird, it would be a little bit harder, but 0 and 1024, that tells us we're not even setting this value. So we look at NB, right? And NB is either a macro or a variable or something like that. And NB, okay, so NB looks like it is the number of dirty blocks pushed, and so we just did something very stupid, which is right here. To get back that variable is not, that variable is returned from the function, right? So we actually have to go NB equals to get back that value, right? Because the number of blocks pushed is actually returned by a file scope variable. So if we look at, that should be in Tausync. Are we in Tausync? Or in Tausync's data? Yeah, so this is right here. This is NP right here. So we could make a note here, NP. That may not be the best note. That just might make things confusing. Let's just do this. Let's just put it at NP like that. And then in our little commentary, obviously NP could change. Like, it's a very terse variable, so it might not always mean that. But we can go into our little documentation here and just like be like, at NP, and we could just say like C NP is NP in this case is number of pixels, right? And then we can just make a note of what we want to see there. What is this file? This is tausync.d, right? So just a little note to know, like, maybe that'll help a little bit, make that a little less confusing, because we don't want this, like, random annotation that's kind of like just there, and we're like, what the fuck is that, right? So, so let's do this. All right, cool. So let's keep on going. So, yeah, so we made a really stupid mistake. And so I'm really hoping that this unit test is just going to work, right? I'm really hoping this is going to be, like, easier than the last unit test I wrote, where everything just kind of works. Yeah, that's, oh, no, that's not. Okay, so interesting here. So let's look at this. So we see that it's a negative. A negative, either you can have 0 blocks pushed, or you can have some positive number. So this negative tells me that it's some type of trap value. Now, that's a weird negative value, so I'm going to guess that we use some type of hex value, so we can't find it in the code immediately. So what we're going to do to fix that is I guarantee that, well, I don't guarantee, but I bet you if we just look this up in Google, right, I mean, that we're just, instead of a calculator, we're just going to say convert this to hex, and we're going to look up this hex code, and this is why I use Google. Fuck this. I like Torch, but to get Torch to configure correctly to always use Google seems to be harder than it should be. So we're going to take, actually it needs to be negative to hex. So let's just take, oh yeah, but then the signedness is screwing with us, so we'll find it. We'll find the problem. Just, I was hoping that it would be a little bit easier than that, but let's run this again so I can make sure I know which one of those values is negative. It's a trap value, so I'm fairly certain I know where it's been set, but the fact that it's not a hex code is making it a little bit harder to find. Actually, what we could do, here, let's do this. Rather than try to figure this out right like that, we can take this and to print it as a hex, I believe you just need to do 0x like that, and I think that'll work. So let's try that, and then we're going to print it off as decimal, and we're going to print it off again as hex. And I think if we search for whatever hex gets printed off, I think we'll be in good standing to figure out where that's coming from in the code. Okay, so hex is... God damn it, that doesn't make any sense either. That doesn't look like something I encoded. It looks, first of all, it looks too large. Well, that sucks. So, let's, I keep on closing my console out of, like, force of habit. So I want to keep this open, because I want to, like, reference these numbers when I'm looking through the code. So it is the NB value. This NB value is a problem, right? So if we look at Tausync run, and we're, like, wondering what's being returned, we see this number of dirty sectors pushed to the GPU. And we see it's like a negative... value int32. So that's really weird. That's wait. Yeah, so we can't actually set a trap value here, right? Because this is going to be like incremented every time something's pushed, right? So this was just a stupid idea to put a trap value here in the first place. This is complete nonsense, you know? Must be 0 here. You know, we could just do like fucking 0, man. Or... Alright, we could do this. We could try to kind of make sure we don't screw this up in the future and say must be 0 here. I don't know, maybe that's too heavy-handed. Yeah, you know what? Let's not do that. Because that's I don't like how that's just wasting a whole bunch of space here. So let's just do this. A num dirty sectors push. Do we have a define for that? No, we don't. Okay. So this is just me kind of like saying, you know, a little redundancy to make sure that this is initialized to 0, right? So must init to 0 here. And then what we can do is we can take the current video timestamps and we can put that in our notes here, right? So the current video we are on is video integer ID 0053, and okay, the timestamp is 6 minutes, 57 minutes, and 32 seconds. And this is always going to be the timestamp that I'm currently looking at on the clock. So any of these timestamps, you'll probably have to rewind a few seconds to get to where we actually kind of talked about that. But it's better than having to look through hours of footage to find something, I think. Okay, must to 0 here, and I think that'll actually fix our problem. So let's, yeah, I can't believe I did that, but I do a lot of stupid things, so... hopefully everyone watching feels smarter, because I do stupid things. Maybe some good can come out of this. So, unit test fail, and what do we got? We got, the number of pixels is 1024, but the number of blocks is 256. That's pretty interesting, right? Because we got powers of 2 here. And what I'm noticing is 1024 looks like it's 4 times as big as 256. So let's actually throw that into a calculator right now, even though I'm pretty sure I did that math correctly. But let's just take 1024 and divide it by 256 and see what's going on there. So it's 4. Yeah, 4. So what we're going to do here is, before we fix the error, I think what would be nice and helpful here is we're going to go into the code, and we're going to find exactly where the problem happened, right? We're going to go find the problem that happened. And we're going to say that if NP, right, which is 1024, divided by the number of the number of pixels, if the number of pixels divided by the number of blocks, if that equals exactly 4, right? And actually, maybe we should put. Well, it doesn't really matter, does it? Because they're both constant expressions, so it really doesn't matter which side it's on. It'll still be a problem if we accidentally assign. But if this exact case happens, we're gonna go like we're gonna print off something like print off, you know, NP is exactly 4x of n. Oh, sorry. N is actually 4x of NB, right? Right. So, and then we could kind of bring some attention to that, right? Like, it's a very specific case, and I don't know, I just think that it may be helpful to have like a very specific message for that. So if this error ever happens again, you know, we can offer some solution as to why exactly that has happened, right? So let's run this again, see if we can see this very specific error message this time. Because the more information we can gather, right? So we had to check on a calculator to make sure that that was the case. But now, if that is the case, we're going to have a much more specific error message here, right? So NP is exactly 4x of NB, right? So when we're looking at this and being like, this looks oddly like one of these is a multiple of the other, right? And we can look at it and be like, yeah, that is exactly the case, right? Also, I'm a little confused here because look at these numbers. Even though we see 4 times as much on each one of these, I just realized that one of these is hex and the other one is decimal, and I do not know which one's which. So we should correct that. So we see this first printout is decimal. So what we're going to do is we're going to just make a note here. This is dec, and this one is hex. And I don't know how to get like the zeros in there to how to like print it with like a 0x whatever. But let's just do that, and then let's make sure that it looks like it's sensible output that we can kind of like comprehend what's going on there, right? Okay, so also at 9 hours and something, I'm gonna have to end the stream and maybe either start up another one a half hour later or something, or actually what I'll do is I think I'm gonna want to keep coding after 9 hours, but we'll stop and restart the stream like right away and have an immediate break, like maybe a 20-minute break. And then we'll keep on going. And the reason for that is if the video gets to 10 hours long, I won't be able to put it on YouTube. And that kind of defeats the purpose of this being kind of like a of documentation to supplement the code base. Okay, so does this output help us? So we see decimals, and we see the hex, 1024 and 256. NP is exactly 4x of NB. Okay, that's great. That is helpful to me. Because now we can think about, well, why is that? So, the number of blocks is less than the number of pixels. So that's telling me that on certain places where I thought I was only setting 1 pixel on a block, I'm somehow setting more than 1 pixel. So, the way we're traversing this data structure, we've made a mistake in our looping. So if we actually look at our looping here, we actually can see exactly what the fuck we're doing wrong. So this is, so right here, oh, actually, hold on. Oh, yeah, okay, yep, okay, yep, that makes sense. So right here, this for loop here, this actually should not be there. Unless we want to say that, we can keep the for loop, but we need to say v equals 0 and v is less than or equal to 0, right? And then we'll make a comment as to why that is the case. Okay. I don't know if I want to keep a comment. So, v is 0. So what we'll do is we'll do v is 0 to 0 for this test. Okay, we're gonna make a little hashtag comment here, and then we're gonna notate when we wrote this. So let me close the console here. So the video at vid integer ID is 0053, and the time is 7 hours, 4 minutes, 50 seconds. All right, so this is the timestamp in the video archive, where you can find video number 53. At this time is where we're going to discuss what this is all about. So when we're setting, we want to make sure that the number of blocks that are dirty and the number of pixels that are dirty is 1-to-1 in this current test. In order to do that, we need to set only one dirty pixel in each of the 32 by 32 blocks, right? So that means we're going to iterate through all of the t values. So these are our t values right here, our t values. Let's color code that. We'll color code everything the same color here. So over here, we'll color that, and we'll color that. So these are the t values, these indices, 0, 1, 2, 3, etc. Then, and that's kind of hard to see, so I'm sorry. And then over here in our s values, we're going to iterate through every one of those. Okay, here's our s values. Okay, this isn't, oh god, I did it wrong, oh god, okay. Control 0, hold on. Let's do that again, I'm sorry. Let's color, and then other color, right? So, t values and s values. And then, once we get down to here, this is all the same. This is the terminal block. This is our terminal 32 by 32 block, right? So we only want to set one pixel on this, right? And in this loop, what we were doing, well, let's color code this. So let's give this like a different color. Let's give this purple. Okay, so in the loop previously, we were looping through every single pixel, right? And that's 32 times 32 pixels. I don't know exactly how the math works out, but it gave us a value 4 times larger than it should have been, right? Because we only want to set exactly one pixel here. Now, we might want to be able to visualize kind of what the data structure looks like that we're iterating over. So we might want to set this to exactly 0 just to help us out there, right? So to get this entire block to be marked as one dirty block, we need to set one pixel here. If we set more than one pixel in this block, it's going to make it so the number of dirty pixels and the number of dirty blocks is not going to match. So that's why we need to just have this 0 to 0, right? So now that we have this little commentary, what we're going to do is we're going to go into our master. It's not really a master notes file. Well, it kind of is. We're going to go into this chronological notes file and just document that in a little bit more detail. So we'll take this, and this way if somebody wants to search in the code base for this exact phrase, they'll see this extracted comment here. The v variable index must only be one value, one loop iteration for these nested loops. because we only want to set one dirty pixel per 32 by 32 block, because we are trying to get the number of dirty blocks to match the number of dirty pixels in this test. So this commentary might be kind of horribly worded, but it's better than nothing, right? And you know, if this is horribly worded commentary, you still can go here to find out like a little bit more detail, right? Okay, so I'm satisfied with that. I think we're actually going to get this running now. We might want to make a little comment here. I did a lot of Visual Basic back in the day, so sometimes I like to mark the end of my loops with next, T, S, and V, right? And that's not, it's Visual Basic-ish kind of a style. It's not quite, it's my own little take on it, right? Because it's a comment, I can write whatever I want. But this is just a reminder that these brackets go to the T, S, and V, right? There's no need to like waste space by putting these on a different line, so I'm not going to, right? The reason for these on a different line and not indented is so that I can see them lined up nicely, right? I can see vertically, I can see everything lined up nicely, and I can visualize the pattern of what's happening. It doesn't make any sense to indent this or even add spaces between this unless you're actually going to do something inside of there. Otherwise, you can keep it nice and compact and present the data or present the code in a way that makes the most sense for what's actually going on. And so a lot of formatting of the code I really think is a case-by-case basis. So I really don't think you can apply some general auto-formatting to a code base, or at least the way I indent my code, the indentation of my code would be destroyed by any type of auto-formatting, right? I think of the formatting of my code very much as a natural language, where there's a lot of exceptions. There's a general like philosophy of how we need to format, but a lot of it is very, there's a lot of very, it's very, there's an art to the way I write comments. Man, that sounds pretentious as fuck, but yeah, sure. Yeah, let's give this a run, see what happens, because I think that this test is going to pass, and then we're going to have to think about what's the next thing that we can kind of add to this test code to further assure ourselves that, man, I just suck, don't I? So now the number of, okay, so the number of pixels is 4, and the number of blocks is 256. So that is not good. That's not good. That doesn't make any sense. Okay, well, we got to figure it out. So, right, the number of pixels is 4, but the number of blocks. So the next thing might be like why is that? Because I thought the variable. Yeah, that's really weird. Why is that? Well, this is why we write tests, right? If we can't get the test, if we can't get this simple test to work, then good luck getting the whole system to work, right? So it is a good thing that we've gotten this. But why is that? So 4 and 256. So we still see this weird multiple of something or other problem. So let's just go into the code here. And it's still this error, right? It's the error that happened at originally 404. We wrote this error code at 4:52 p.m. Let's just add some more stuff. So what is 256 divided by 4, right? What kind of relationship between those numbers can we find? And what kind of insights might that give to us if we take 256? So, all right, so I'm looking at my output. I'll show you it right down here. So we see that the number of blocks that have been marked as dirty is 256, but the number of pixels that have been marked as dirty is 4, which makes absolutely no fucking sense. Because pixels exist within dirty blocks. So you could expect the number of pixels marked as dirty to be more than the number of blocks marked as dirty, but you should never see the opposite, right? You should never see more dirty blocks than dirty pixels. So one thought is that we did not clear this data, right? That we're running this little test and we forgot to force clear for unit test. So we may want to yeah, because the number of blocks there is 256. That's exactly how many this is the max number of blocks, I think, right? Or maybe it's not. So let's think about that. So 4 times 4 times 4 times 4 times 16 times 16. Okay, let's look that up really quick. I'm sure that's much more than 256, and of course it is. So what is 256 divided by 4? What's the relationship between that, right? So 64, okay. That's not as much insight as the last time we did that, but I don't know, let's just do this. So solution, v loop needed to be from 0 to 0 inclusive. Okay, so the solution for this case, the solution for this problem, we're just going to document what that solution was, right? So we're going to kind of leave scars in our code where we just kind of like mark, right? Like, you know, like if you break, you get a cut, right? You get a really deep cut and you end up with like a scar. Or like, you break a bone and then like, well, not always. Like, I think sometimes bones don't heal stronger than originally, but like you get a scar or whatever and it scars up, right? So, or like, oh, you know what, a better example? You break something and then you epoxy it together, right? And now that site where the breakage is it looks like a scar, right? Like if you broke a vase and had to epoxy it back together, it would have visible scars, but the strongest part of that vase would now be where the epoxy is, right? So where the code breaks is we want to like scar it up and add like little air checks and stuff to make once we heal up the code, we want to make it stronger than it was before. That's kind of a weird analogy, but hopefully that kind of makes sense. So 256 divided by 4 is 64, right? So if 64 equals the NB divided by NP, right? And then we'll just do a little printf, and we'll say that NB hold on. Hold on. Oh god, I lost the track. Okay, so NB divided by NP, right? Because NP is our larger one. Hold on, let me put this down here for you. Okay, so NB divided by NP is getting us 64. Okay. Okay, so NP is 1/64th of NB. Okay, so NP is 1/64th of NP, right? So correct me if I got that math wrong, if I like flipped that. Pretty sure I didn't. So we're just gonna like issue a little kind of statement of what's going on, so that next time we look at those numbers, when we see those numbers in the error message, we don't have to go refer to a calculator. The relationships between those numbers are going to be shown to me right away in the error message, right? So I see this message, NP is 1/64th of NP. Well, that's not right. Hold on. So here's NB. Here's NB like that, yeah. Okay, let's run that again. And then let's check our math, right? Because I may have got that flipped around in my head. Okay, so if we look at NP, NP is our smaller thing, right? So NP, yeah, NP is 1/64th. Yeah, I got that flipped around. So it's NP first. So NP and then NB. Okay, so let's run that again. I know some of this is kind of tedious. It's not going to really be really fun what we're working on right now. It's just kind of boring, but we got to get it done. Okay, so NP is 1/64th of NB, and we see that NP is 4, and it's 256. So we're saying that, 64 of them, it's a 64th, so 4 times 64 is going to get us 256, right? So let's check that math. 4 times 64 is 256. God, I fucking wish this browser defaulted to Google here. Yeah, okay, yep, so that's right. So now the next question is, well, what's causing that, right? Because that's totally incorrect. Why? Why is that happening, right? And, I don't know. Let's figure it out. So the number of blocks is more than the number of pixels. It's completely nonsensical, right? Why would that happen? That makes no sense. Obviously, we've done something horribly, horribly wrong. And we need to figure out what that could be. So, one thought is, this here is a file scope. So maybe we forgot to... Is there the potential that we forgot to zero this out, right? Like we're incrementing it, but we're not zeroing it out at the beginning of the function, right? That could create some problems for us. So number of dirty pixels pushed. Oh, really? That's the number of dirty pixels pushed? NP? Yeah, number of dirty pixels pushed. That makes sense. That makes sense. Okay, yeah. So the dirty rectangles look like they're probably the wrong size, right? Because we only set 1 pixel on each one of those 32 by 32 regions, so we're expecting that each one of those rectangular regions would be exactly 1 by 1 pixel, but judging by this, I'm going to guess that's not what we're getting. Now, let's look at this. So the... this number of dirty pixels pushed is this supposed to be an accumulator? Because we see this number of dirty sectors pushed right here as a plus. But this number of this is why our number of dirty pixels pushed is wrong, right? The number of dirty pixels was less than the number of blocks, and the reason for that is this value is supposed to be an accumulator, and we're not using it as an accumulator. So we see it right here, and it looks like we should really zero this out. Where do we need to zero this out? Is this, this needs to be zeroed out at the top of the function, correct? Yeah. Now let's check out where else we're kind of referencing this. Looks like we're only doing it right here. Are we using we're using defines, aren't we? So NP really should not be set. We should manage that value in the, yeah, we should really, function should set this, right? The function really should set this value, not our test code. We shouldn't really reach in there and change that, so, we're going to remove that. This was wrong. This is wrong. We don't want to set this here. That's just... I think that's asking for a little bit of trouble. So let's just look for where NP is kind of used here. And... Or do we need it like that? No, because it's going to be one... It's going to be one sync the syncing function is supposed to be like used in one big go, right? So, yeah, so it makes sense to not set it in these. I'm gonna like make this red to mark it as like a deletion. Like, this is here for reference, but don't fucking do that, is what that red means. Okay, let's make sure I'm just gonna loop through this one more time, make sure that every point at which I'm kind of setting this value is kind of like removed. Okay, looks like we're good. Looks like we're good here. And then the next thing we need to do is this value for NP. We need to set it. We need to reset it at the top of the function, right? So at the top of this function where we're pushing the values, we need to reset it. So, and this is the number of dirty sectors pushed to the GPU, and the number of dirty pixels pushed is also 0, right? That's kind of hard to see. Let's I don't know. Let's do the same kind of thing where we kind of like also kind of like did a little assert there. And let's try to like create a little section for this. So let's kind of reset heuristics. I have no clue how to spell heuristics. Maybe I shouldn't use that word. But let's look up how heuristic. I'm gonna spell it once and heuristic. Okay, so here I think heuristic is reset histogram vars. I don't know. I don't know what to call it. I guess reset histogram instead of calling it heuristics, just because heuristics, I don't know if I'm even using that. No, heuristics is a processor method. Yeah, I definitely mean histogram. I do not mean heuristics. Okay, so we're gonna kind of like put that in a nice little section right there, like that. And yeah, so we put it in a nice little section like that. Reset histogram. We got this guy here. We got this guy here. We might also want to make a note that NP. So the number of pixels is this guy right here, right? And it just might make it easier to find things in the code if we do this. So NB, the number of blocks. So okay, so a sector is equal to a block. You know, synonymous language, right? So maybe I should have been more consistent with how I kind of named that, but we'll just patch it up with a band-aid of a comment and kind of like say that's good enough for us, right? Okay, so we've reset the number of dirty sectors pushed, and then we are going to also reset the number of dirty pixels pushed. And at the end, I believe this should be the number of dirty pixels pushed, right? So if we look at what we're returning here, yeah, number of dirty pixels pushed. We also have to fix this as well. Or what are we returning? Maybe it's dirty sectors. Okay, we're going to push the dirty sectors, not the pixels. That's fine. That actually makes more sense. So this actually needs to be, we could, I feel like, here's what we're going to do. We're going to reorganize this a bit. Okay. And plus equals, say numpix. And we're kind of out of room there. That's, okay, that's kind of ugly. It's ugly, but no, we're gonna stick with it. That's good. I mean, it's ugly, but yeah, we'll stick with it. So this right here, right? We weren't using this as an accumulator, right? So it was getting overwritten each time. That's why we weren't seeing the correct number of pixels pushed. So we're just gonna say like this numpix equals this, and then we could declare it here, I guess. Is that the most efficient way to do it? Well, this is the only place that's referenced is here and here. Does it really make sense from a readability standpoint to declare this variable like somewhere way up top or something? I don't really think it does. So we're going to say like I32, and I believe we're using it int32. So we see this Tausync num dirty pixels push. We see it's also an I32 over here. So yeah, we'll use an I32, int32. And now it's an accumulator, right? So, so we could make a note here, you know, update accumulators, right? Update accumulators, okay. And then numpix is obvious to me, but other people it might not be. So, number of, and then pixels. Okay, so if you want to know what numpix means, do we have enough room to actually write it out? So numpix. Yeah, we kind of, if we kind of do it like this, yeah, numpix. Okay, yeah, sure, why not? Okay, so let's give that a run, and I think that I think our test is actually going to pass, and then we got to write some other type of test code to solve more problems, or we could just, you know, completely fuck that up. So here's an example of a Yoda expression, right? So the way I wrote this, I wrote 0 equals this, because we can't assign anything to a constant here, right? L value required as left operand of assignment, right? So this error message doesn't actually match what we did wrong. What we actually did wrong was we meant to write a double equal sign, but we accidentally wrote 1 equal. But because I always put the constant expression on the left, we saved ourselves from some horrible, horrible problems. So that's good. We're going to keep on writing things weird as shit to help avoid problems. So on line 145, I believe, we can find the problem. So 145. Some people would say that's a magical incantation and to not do that, but it just saved my ass, so let's keep on doing it. Okay, yeah, so that's all we needed to do. Yeah, that's good for me. Oh, I see how this is nicely lined up. Can we get this nicely lined up? I don't think we can, because it's like too big. Too big? Yeah, too big. Alright. That sucks. Oh, well. Oh, actually, you know what we could do? This is kind of dirty, but I'm going to do it. Define A is assert, and then down here at the bottom of the section we'll undef it. Undef A, right? And then from there we have a little bit more column space to work with, and then we might be able to get this to line up nicely. Okay, there we go. That's just so I can kind of like see, I don't know, it feels better if I can kind of line this up and kind of see these nice and lined up like that. Maybe it's just an OCD thing I kind of do. Okay, yeah, that's good. Okay, that's good. I'm fine with that. We could actually do like this. We could, I think we have enough room where we could just say 0, you know, if we really want to, make a note of, define 0 and just, you know, 0. Now the reason is, like, why the hell would you do that, right? Like, what is the sense in doing that? And I'll kind of give you a justification. Hold on. Okay, so the reason for that is just so that I can see, I can click this and I can just see 0 and 0 highlighted right here. So it kind of directs my attention to like, oh, what's they're both zeroed out, right? Also, you know, it might make sense to say zero out histogram. Maybe that's another. So sometimes I like to double label the sections of code. You know, if I think that there's another phrase that might be more helpful or might be better, I'll kind of double label things. So I'll give them kind of like 2 different labels. We need to kind of change this up a little bit. So let's kind of do this and then reset histogram. Let's take this over here. Let's paste this over here. And let's boom, 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 boom. Also, we need this here. Okay, so obviously sometimes I can get a little bit too designy with the code. But the idea is I really follow the rule of, I don't know if it's a rule, more of a philosophy that, you know, code is only written once, but it's going to be read a lot more than it's written. So I'm going to take the time to just make things look pretty, right? So for these little comments here, did we actually make a commentary about what that was all about? No, we didn't. So let's take those oh, actually, let's check really quick, make sure. Okay, yep, no, we didn't. So we can talk about what we're doing here. Okay. Okay. Oops. And and then boom, boom, boom. Okay. Okay, so to help with writing unit tests for F. I think it's Tausync run, correct? Yeah, it's Tausync run, yep. So namely, so we have 2 things we need. Stored as a file scope variable. And then 2, the other thing we have is the number of dirty sectors pushed, right? Now, the number of pixels pushed, right? Okay. Returned as 32 from function. Okay. So this is just a little note about what's going on there. And then we can make a little note about, like, where did we write this? At what time do we write this? We can do, like, @vid integer ID, and the ID of this is the 53rd video in my archive of videos, and the timer of this stream is 7 hours, 36 minutes, and 51 seconds, right? So that way we can find where we talked about this. Maybe we didn't talk about it enough, but there is always the hope that when we wrote out this comment, that as we were doing the stream, you know, we said something that was not properly conveyed in the comments, or somebody wants to know more about information that kind of surrounds this, so they just want to jump to this timestamp in the video and kind of see the video footage surrounding specifically that area, right? Let's make sure that this is what's actually returned. Is this the same variable returned? Yeah, so this is the variable we're returning. We only have 1 exit point, so that's good. I mean, I'm pretty sure we only have 1 exit point. If we don't, we're in trouble. Okay, let's see what we got. Okay, let's run that. Okay, so, and we still done fucked up. So NP is exactly 4x of NB. Great, now we got the same, we got the previous mistake. God damn it. What did I screw up now? So the number of pixels is exactly 4 times the number of blocks. Oh, God, what the hell, man? Right, so we stomped one bug. We stomped one bug, and then we just got another in our test. So that's like, maybe I've been coding for too long, and, I'm just starting to do some stupid things. So it's the number of pixels that's too high now? Number of pixels, exactly 4 times number of, okay. So number of dirty sectors pushed to the GPU. Number of pixels pushed, number of pics. That looks correct to me, but it's saying that the number of pixels is just way too much, right? Okay. And it's coming from the same test code, right? So, because we wrote those very specific statements. And somehow I've managed to screw this up twice, right? So it's this little message here, right? And let's see. So NP and NB. So NB is getting returned here. NP, do we remember to reset it? I think we do. Yeah, we reset it at the beginning of the function. So Tausync run is right here, and we're dirtying everything up over here. We're only calling it once. So fuck, man. Let's take a look at what we're doing, right? Let's get a look at our little diagram here and say, so T, S, and V, right? We only want to loop 1 through the V, right? Because if we do that, we're definitely going to get more. So we need a little note here of, for the number of sectors, how many sectors are we actually expecting to be updated, right? And it should be 4 times 4 multiplied by 4 times 4, right? That should be the number of dirty blocks, right? The number of dirty 32 by 32 blocks should be that. And what is let's just do int32 num expected number NB. Let's call it expected NB equals 4 times 4 times 4 times 4. We're just going to write it this way so that we can kind of visualize the data structure a little bit better and what that is. And then let's just do a little assert here. We're going to actually assert that this is equal to something or other. And that way, or actually, no, it's no, we're going to need to do it this way. Okay, so, okay. And we're going to use an assert here, so we don't need to pop out a calculator to be like, well, what is that value, right? How close to that value are we, right? We don't want to have to pop out a calculator each time we're doing that. 256, huh? Okay. So, we're going to do another printf. Actually, no, we'll printf that right down here. So printf and expected number of blocks that were pushed, and %d new line, and then expected number of blocks, right? Okay, this is what we're actually expecting, because we're expecting every single block that's in this structure to have been updated or marked as dirty, right? And also updated, yeah. So let's take a run with that and kind of see what happens, and then we'll kind of like look at the output and make some more guesses as to what we have screwed up, right? Okay, let's see. So the expected number of, actually I should put this back on the screen where we can see. So the expected number of blocks is 256, right? And it's kind of confusing because we have this hex over here. But we can see that the number of blocks is indeed 256. And that matches the diagrams. So I think that something is wrong with this. This is 1024. It's exactly 4 times. So I'm thinking our inclusive rectangle math is wrong. I think we're probably doing like we're off by 1, and that plus or minus that we need is probably flipped, right? We probably have a plus where we need a minus, and you have no idea what I'm talking about, but that's fine, because we're actually going to look at that code right now, and we're going to see what I'm talking about. It's that inclusive, right here, okay, right? So I'm thinking that this is off. Actually, this rectangle is correct, right? It's an inclusive rectangle, so we have to minus both of these, and we have to add 1. So the problem here is not, the problem with this rectangle is not here, but somewhere else this rectangle is being improperly computed from looking at the results we're getting. So we need to fix that. Now, we're almost at 8 hours. I believe that we can go up to, like, 9 hours, 59 minutes, and 59 seconds, and we'll be fine. We'll be able to upload to YouTube. However, once we get close to 8 hours, it's like, oh, I feel like I'm risking it, and I absolutely don't want to risk not being able to upload this entire thing to YouTube, because we've done a lot of work here with archiving, like, the integer ID of these videos, and we want this to be a video log of... that will help augment the code documentation, right? So what we're going to do right now is I think I want to go on a break. So I'm going to stop the stream. Okay, I'm going to stop the stream. I'm going to change the integer ID in the bottom right-hand corner from 53 to 54. I'm going to immediately restart the stream. And then... once the stream has been restarted, we're going to immediately go on a 20-minute break, and then we're going to come back and we're going to finish writing this test code. So right now, it's we're even on a new section, right? Because now we're on Tausync unit test. So Tausync unit test, okay, and or unit test, I guess technically. And then a note: Tausync. What is Tausync? So tau is texture as uniform, and sync, syncing with GPU. Okay, so I'm making some notes about what the title of what the title is when we come back, and getting ready to restart this stream, because once I want to kind of restart this as quickly as possible, so you're not like, oh my god, where do you go? So that looks good. Yeah, we're just gonna stop the stream. I'm gonna it's still Monday, right? Is it still Monday? Yep, still Monday. So we're gonna just change that integer ID, restart the stream, go on break. So I will be back in a few seconds. Anyone who comes back, thank you. If you don't come back, that's fine. I know I've been going at this and it's kind of boring. It's kind of just unit test stuff. So yeah, I'll be right back. See you if I see you, I guess.